Hi everyone. I welcome you all to the live session on Big Data Hadoop full course by Intellipaat. This session is conducted by multiple experts who will be teaching you everything about big data from basics to advanced level. Before we begin the session, make sure to hit the subscribe button and also hit on the bell icon so that you will never miss an update from us. On saying that, let's see the agenda of the day. Firstly, we will begin with Introduction to Big Data. In that, we will tell you what is big data and why one has to choose big data. Then after that, we will be telling you how to learn big data and what are the job profiles in big data. Then after that, we will introduce you to Hadoop and also tell you how to become Hadoop developer. Post that, we will be learning about relational database management system. And also, we will be telling you the difference between RDBMS and Hadoop. Then later on, we will be learning about Hadoop ecosystem. In that, we'll be explaining you what is MapReduce, Pig, Hive and other components of ecosystem. Then later on, we'll be learning about Spark, Scala and Kafka. Then finally, we have covered the difference between Hadoop and Spark and also Hadoop interview questions and answers. So guys, this session is going to be very interesting. So stay tuned and watch the video till the end.
Why choose big data as a career option? So there are a lot of fields in which you can expand your career in, but why should you choose big data? The answer for that is quite simple. Data is the most valuable commodity in today's world. All successful companies like Amazon, Facebook, Google, all of these companies keep their commercial data hidden. It is a secret, it is confidential, and it is quite frankly the key to their success. If somebody external gets their hands on that data, they could replicate their success formula. But why is that? Why is data such a commodity? The answer for that is quite simple as well. We create multiple accounts on these websites like Amazon and Facebook, millions of users every day generating terabytes and terabytes to petabytes of data every day. So data is being generated in a fast and continuous manner, which means on an everyday basis. And the data is extremely large in nature as well. Like I said, petabytes at times, the data could be extremely large. So the companies on which these users are creating their accounts on, performing these transactions upon, the company has two choices. Either they could keep the data as it is, discard the data, or use that data for their own commercial success. So that is what data analytics essentially is. And when the data is extremely fast and continuous in nature, it's being constantly generated, and the data is extremely large in nature as well, coming from various sources, then that data is termed as big data. And the terminology we use to define the analytics of big data is big data analytics. So if we look at the trends on Google Trends, if we look at the search term data analytics, we can see that since 2004, there has been a gradual increase in the number of times this particular term has been searched. This indicates the increase in popularity in today's day and age of the term data analytics and the field and domain in general. So there was an article by Gartner which said by 2020, augmented analytics, which is a subfield of data analytics, will be the dominant drivers of new purchases of analytics and business intelligence. And we can see the left-hand side, the top 10 technology trends in data and analytics. So it involves a lot of artificial intelligence and machine learning. Because naturally, when you have a large amount of data available to you, you can create a lot of models. You can increase the accuracy of your machine learning models. You can increase the efficiency of your artificially intelligent systems. And this is precisely why data is so valuable. Once you've accumulated the data, once you've collected the data, there are a lot of branches you can go about. You can go into machine learning, you can go into artificial intelligence, you can just be doing simple data analytics, you can go into data science, you can go into data visualization. There are a lot of fields and scopes available to you once you've collected the data. So business intelligence is mandatory for commercial success, and especially in today's world where every company is going online. If you want to compete with these companies who are going online and using these technologies like data analytics, like data science, like machine learning and artificial intelligence, if you want to compete with them, you have to come on the same platform as well. And what is business intelligence? It is simply a branch that arises out of the data analytics domain. Then competitive customer satisfaction is driven by analytics as well. So this is especially true, for example, for e-commerce companies like Amazon. The reason Amazon is at the top of the food chain today and not eBay or any other company or any other e-commerce organization is because Amazon uses its customer data, Amazon uses its transactional data in the most efficient way possible, in the most profitable way possible. They've created the best models, the best recommendation engines, the best customer service, the customer experience that they provide. So, all of these things have attributed essentially to their immense success today. And customers are naturally driven to better experiences since Amazon provides them that experience. That is why Amazon is at the top today. Then large amounts of data. So the big data part of it comes when we're dealing with extremely large amounts of continuous data. So that comes under big data analytics, yet another branch of data analytics that we're discussing about today. And organizations like Facebook, like Amazon, like Google, the data that they generate is in such a large amount that it definitely qualifies for a big data case as well. And then the optional artificial intelligence and machine learning. So once you've created your models, once you've extracted the data, collected and cleaned it, then you can implement artificial intelligence and machine learning on it. It's not the most widely adopted tool today. A lot of companies are getting into it by seeing the success that it brings to other organizations. So these are fields that are arising out of data analytics that can be expanded upon once you get proficient in normal data analytics. And once you're able to create successful AI ML models out of this data, there is no doubt about it, you will be able to arrive at your output at a much faster and much more accurate way. So here are some major organizations that use big data analytics today. So Google, Bank of America, Tesla, Apple, Amazon, Netflix, Facebook, IBM, so all of the big corporations, these big companies, they are successful today, and they're successful exactly because they've kept up with the times and they've implemented big data, they've implemented data science, and they've implemented AI and ML in their workflows. And make no mistake about it, these organizations are continuously looking for talent. And that brings me to the average salary of a big data developer. So in the United States, the average salary is about $107,000. In India, it's about 10 lakhs per annum. And in the UK, it's about 67,000 pounds per annum. So that is a lot for an average worker in the big data developer industry. So that competes with a lot of popular fields today. But that's not it. The reason why this amount of salary is lucrative is because this field is ever evolving. This field is the future. Data analytics, data science, and AI ML are the future technologies. And these technologies are going to stay. So if you learn these technologies, you will be able to be viable in the market for a much larger time. And that in turn brings me to the importance of a certification. So, a certification is a stamp of excellence. So, it basically says to the employer that you've completed a course in the set amount of time with a set required amount of percentage or grade, whatever the course is offering you. So that naturally helps you get hired because the company now knows that you can be vouched for, that you've actually had some experience because you've been certified. There's also a substantial increase in pay if you're looking to expand or change your job profile. If you're coming from a simple data analytics role, if you're coming from a simple relational database role, and you want to expand your role to a big data analytics expert, so there is a substantial increase in pay because those two fields are vastly different. And you have clear corporate requirements. So because these fields are so lucrative, they obviously want the best talent because there is a lot of talent out there in the world. So they've set their requirements at a set standard, and you need to succeed in those standards to be hired in those organizations. So what helps in that? Knowledge plus projects. And the certification basically tells the employer that you have both of those. So let us look at the learning path that is involved in this particular technology. So if you're getting into big data, if you're getting into data analytics in general, firstly, you need to have a basic and minimum understanding. So I'm emphasizing on the word minimum because that's all you need. Basics of mathematics and statistics, like averages, like graphs, how to read graphs, and all of those things. You need to understand just a little bit of that. And then basic programming. So if you're getting into big data, then you need to know some programming. A basic amount would do. You don't need to know a lot. You need to be accustomed with database technologies like MySQL and NoSQL and all of these other relational database tools. So you can get proficient at one of those, and that would suffice. And then we have the big data technologies. So in order to implement data analytics in a big data environment, you need to be accustomed with the big data architecture, and those are essentially your big data technologies. And then once you've understood how the data analysis works, how the data collection, cleaning, and processing works, then you need to be able to present your information, your insights to higher management to in presentations. So for that, you need to have really good data visualization tools. So there are tools for that available as well, inbuilt in the technologies that you would be working with in big data. And then let us look at the job profiles. Now that we've looked at the learning path, let us look at some of the job profiles, example sample job profiles that are available for you to apply in the field of big data. So this is the summary of what would be asked of you in a big data role. So the first point is the usage of advanced computerized models for data extraction. So when you have raw data, you need to be able to extract that data and be able to implement it in your tools. So you would be using some advanced computerized models for that. And that is exactly what is taught to you and what you learn when you start getting into big data. So the first step is data extraction. Then you need to be well aware with the cleaning of data because the data will have inconsistencies. The data will not be accurate always. The data will have missing values. So you need to be able to deal with that. And that comes under the art of cleaning of data. And then the art of analysis comes in. So you have to analyze the quality of data. You have to analyze whether the data holds true for every condition or not, and whether the data is usable. So that process of analysis is called the quality assessment. That is also a step involved in big data. And then you have to further analyze that data to extract some meaning out of it, or just to extract whether the data would have meaning when the models are created or not. So further analysis is required for that. And then the final analysis comes in where you've confirmed that the data has meaning. So you need to see whether the data fits accurately to the model that you've created or not. So that is done via creating some testing models and some training models. You do that, you create your models, and then you see whether there's a fitting, there's a match involved in that to determine whether your analysis is correct. And then whatever you've determined, you need to prepare reports for it. So you need to have good communication, and you need to be able to visualize that results, those insights that you've derived from your data to upper management. So data visualizations comes in there. So the typical sectors where there's big data is used is banking, software development, consultancy, telecom, social media, very obvious use case, social media, academic, and pharmaceutical. So these organizations that are in these domains, they are generating a lot of data. and they need to be able to do perform these analysis on that data to be able to have some viable insights in their user bases, in the work that they do, in the jobs that they are doing. So if we look at Spotify's big data analyst job profile, we can see that you need to be able to scope and solve loosely defined problems. So the problem statements will not be very specifically designed to you. Upper management will just instruct you with a set of guidelines as to what you have to do. And you need to be able to innovate and get to the solution yourself. You need to have deep understanding of statistics. So once you are familiar with the field of big data, once you are experienced with it, you naturally develop the deep understanding that you need to develop in statistics when you're dealing with big data. And you need to be able to understand real world data, because that's what you're going to be dealing with. You need to have the technical competence to perform advanced analytics with tools such as Python or Scala, and tools such as Pandas or SQL as well. And the experience should be with large data sets, because naturally you're dealing with the field of big data. So you need to have that experience with extremely large data sets. You need to possess the statistical competence such as regression modeling, alpha beta testing, and significance testing. So those are some additional requirements that you would gain as you go along in the field. And you need to have some demonstrated experience for that, for those talents like statistical modeling. And if you're dwelling further into the field of big data analytics, as you move further into the career, then you need to possess a certain amount of knowledge about machine learning, so that you're able to expand your insights into something that is much more efficient and accurate. Then we can also look at Nike, and the responsibilities that are involved with Nike include the use of contemporary data science and analytics methods to derive actionable business insights. So Nike has a extremely large customer base, and you need to be able to use that data in order to derive some business insights as to which products might be a tad more popular than the other products, and which products are not selling, and all of those things. So the queries get complex and complex, but you get the idea. Master big data fundamentals, gather, clean, and validate large amounts of data on Nike's cloud platform. So you would be provided with a platform where you would be able to implement all of your big data knowledge, create foundational pipelines and repeatable production queries in the data warehouse that Nike provides to you to analyze these large data sets. So Nike will have this data, and you need to be able to data warehouse that data and perform your queries on it to basically solve Nike's use case. Develop process and continuous improvement of core projects through automation and process enhancements. So there would be some automation involved with your process, and creates the reports and visualizations. So in order to show upper management and the marketing campaigns, in order to improve the marketing campaigns that Nike has, you need to be able to sum up all of your insights, wrap it up nicely with a bow, and be able to visualize it in front of upper management.
So guys, Hadoop is basically an open source technology which was developed first by Google. So it was not called Google Hadoop back then. So what basically happened was that Google, since it had to deal with such a large user base, and it had to do web crawling for so many web pages which are available on the internet, it had to devise a system which can basically process large amount of data in the shortest time possible. Now, when it had to do that, it basically made us to basically develop a new system which we can basically implement and use, which can basically make or solve the big data problem, which is data at large scale. Now, when we wanted to do that, so some Google engineers came up with an architecture, came up with an infrastructure through which we could solve that problem. And once Google implemented that technology and was able to solve everything using that technology, Google basically rolled out a white paper, right? And then this white paper was taken up by a lot of companies who were facing the similar kind of problems, that is the data problem or the processing problem of such huge data, right? They implemented that infrastructure, they implemented all the properties which are mentioned in that white paper, and this finished product was called as Hadoop. Later, Hadoop was basically made open source, and that's how now each and every company who's dealing with data, which is most of the companies these days, is basically they're making use of big data, right? And for solving the big data problem, the software which the people developed using that white paper is called Hadoop, right? Now, Hadoop is basically having a lot of other softwares as well, which when combined together, they basically solve the big data problem. Okay, now people who work on this technology, those are called Hadoop professionals or big data professionals, and there are a lot of profiles out there which are basically related to Hadoop, which we are going to talk about in this session. Moving forward, but why should you learn Hadoop? I just told you guys Hadoop is a software solution to a problem where when you had a huge amount of data or you have huge data to be processed, right? How to do that on using the traditional systems or the systems that we have, right? The server capacity that we have, how to solve that huge amount of data using the server capacity that we have is basically what Hadoop is, right? So why should we use Hadoop? Let's go ahead and understand that. So guys, now this basically the reason of using Hadoop, I'm going to tell you with respect to why you should basically change your job domain to Hadoop, right? I'm going to talk about professionally why you should basically go ahead and learn Hadoop and implement the technology, right? So the Hadoop market is basically seen or is going to see a staggering growth in the coming years according to Cloudera, which is basically one of the major companies who are working on the big data technologies, right? And they also happen to give custom software with respect to Hadoop, and they also the Cloudera framework. So the Cloudera company basically has devised a framework which is basically implemented on top of Hadoop, right? And according to them, Hadoop has seen a staggering growth in the past and is going to see staggering growth in the coming future as well, right? The second point is, according to Forbes, the average salary of a Hadoop professional is $115,000 in the US, and in India it's around $615,000, 615,000 rupees per annum, right? Now this is an average salary, guys, and a person who is shifting to the Hadoop domain based on his experience, he can gather a lot more, right? For example, I know people who are big data professionals and are also earning around 25 to 30 lakhs, right? So it all depends on your experience, it all depends on your skill set, which you bring to the table, because of which you will be getting a job as a Hadoop professional, right? Third point is, according to Glassdoor, in the last month alone, there were 5,765 jobs which are posted in India with respect to Hadoop, and currently there are 33,000 jobs in the US which are vacant for a Hadoop professional, right? So if you were thinking, is there demand for Hadoop? Yes, there's a lot of demand, and according to big companies, this demand is going to grow in the future as well. So the future looks bright for Hadoop, in the sense that a lot of companies are going to implement the Hadoop technology to solve their day-to-day needs. And also, if you think logically, guys, if we are dealing with data, right, you must have heard about this term that data is the new oil in the 21st century, which basically means the more data that you have, the better your product would become, right? You would have heard about data science, you would have heard about machine learning algorithms, you would have heard about a lot of other things. So what companies these days are doing is they're basically reading how the user behavior is, right? Or they're reading how the trends have been in the past to basically predict what the user behavior or what the trends are going to be in the future, right? And since when we talk about a company at scale, if we talk about a company like Google, who is literally basically serving the needs of almost 60 to 70% of the world population, right? Having a company of this scale and this size, and obviously when people are relying on you, you would have seen that businesses these days, they're using Google products like anything. They rely on that Google product. They don't ever think whether that Google product is going to be down, right? So that is the kind of that is the kind of relevancy, or that is the kind of that much we are dependent on Google these days. And now, when you're dealing with a company like this, that company has to come up with products which are world class, right? And that company has to come up with response times which are world class. Now, when I say response time, when you do a Google search, it gives you, in a matter of fraction of seconds, it gives you the search results. Now, how do you think it is able to crunch so much of data for your particular search query? That is because they are able to solve the big data problem. They are able to solve the problem of solving or indexing data, even though every day every user is contributing around GBs of data on the internet, right? So that's how your click streams, your personal data, your any website that you go to, they log cookies, right? They log sessions. So every data, if you basically talk about in a gist, or if you were to take an average, you basically are uploading GBs of data every day onto internet. With respect, if you are a if you're a internet user, or if you're a user who is there on the internet throughout the day, right? So when you're basically uploading this much amount of data, and then Google has to process this much amount of data for you, let's assume, right? They're able to do that in a fraction of seconds. And how they're able to do that? Because of the big data technology that they are implementing, right? Similarly, other companies, let's take the example of Amazon. Now, Amazon, what it does is, you would have seen that they recommend you products when you buy a certain product. How is that possible? Using machine learning. And how is machine learning able to predict? By looking at how other users reacted to certain products. And this basically is possible when you have data with respect to what a user choice is, and how they should be basically saved, how they should basically be processed. And all this is possible using the big data technologies that we use in our day-to-day life. Okay, so this is just about what Hadoop is doing in the world today. Now let's talk about the Hadoop developer role, or the Hadoop job role in general. So what are the requirements and skills for a Hadoop developer? Let's go ahead and discuss that. So guys, these are the roles and responsibilities of a Hadoop developer in his day-to-day life, right? Or when he's applying for a job, these are the responsibilities, or these are the skills which are basically expected from a Hadoop developer. So your Hadoop developer should know how to develop and implement Hadoop architectures. He should know how to set up Hadoop architectures. He should know about Hive and Pig, which are nothing but sub components of the Hadoop ecosystem. Then you should know how to deploy H-based clusters. You should know about how to query data at high speeds. What kind of queries would be able to query data at high speeds. We need to know about data privacy. We need to know about security maintenance. We need to know how to basically translate functional requirements or requirements from our stakeholders into requirements which other Hadoop developers will be able to understand. This basically requirement would be majorly when you would want to become Hadoop architect. I'll talk about more roles as we move along. Right? He should know how to write MapReduce codes. He should know about data warehousing, databases, Hadoop ecosystem in general, Apache Spark, Scala, etc. Right? Now, I basically told a lot of things on this particular slide that you need to know in order to basically get into a Hadoop job. Don't get scared with all the things which I mentioned over here, right? With all the good things which come in life, you actually have to put in some effort. And don't worry, I'll tell you how you can basically channel that effort so that in the shortest time possible, you can basically, if you are interested, you can basically shift your domain to Hadoop. Okay, having said that, let's now look at some of the skill sets which basically your Hadoop developer should know. So he should basically have proven skills in HBase, Hive, Pig, and Hadoop. He should know how to write Pig scripts. He should know how to basically handle data with respect to tools like Scoop and Flume, how to use Hive query language, MapReduce jobs, and this he should basically have good knowledge on Hadoop as well. Now, apart from these, you would have also heard that a lot of companies have now shifted to cloud, right? So a good Hadoop developer or a Hadoop professional should also be able to know cloud platforms like AWS, should be knowing cloud platforms like Azure, should be knowing cloud platforms like Google Cloud. And this knowledge will also help you, because nowadays all these cloud platforms, they are basically also releasing big data services. For example, if I talk about Google Cloud, it has a service called BigQuery, right, which is nothing but a data store for big data through which you can query data fast. Similarly, in AWS, you also have some big data services. In Azure also, you have a lot of big data services which you can use and basically implement them to solve problems in day-to-day life which companies face. Okay, so apart from knowing the Hadoop ecosystem, it has also become advantageous to basically know about clouds such as AWS, Azure, and Google Cloud, right? Having said that, what is the average salary? This we have just discussed. Just to summarize, in the US, it's around $130,000 per annum. In India, it's around 6,80,000 per annum. And in the UK, it's around £60,000 per annum. This is the salary of a Hadoop developer in the United States, in India, and in the UK. Okay. Now, your next question would be, then how do we go ahead and become a Hadoop developer or a professional? Now, before we go ahead with this, let me talk about the 3 profiles which are there in the Hadoop ecosystem, right? And then I'll also tell you which profile would suit you in order to basically shift your domain to the Hadoop domain. Okay, so the 3 profiles are Hadoop admin, Hadoop architect, and Hadoop developer.
Just a quick info, guys. Check your knowledge of Hadoop by answering this question. Which of the following are the core components of a Hadoop? A. HDFS, B. MapReduce, C. HBase, D. Both A and B. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Now, what is the difference between these 3 profiles? Now, if you are a Hadoop admin, your basic job would be to manage the Hadoop infrastructure which will be deployed by a particular company, right? For example, the regular maintenance of the servers, if any storage node has to be added, if any data node has to be added. A Hadoop admin's job would be to basically maintain the cluster which is already running, and at the same time, if there's any need of adding any infrastructure, etc., that should also be handled by a Hadoop administrator, right? Then there is Hadoop architect. Now, what does a Hadoop architect do? A Hadoop architect's job is to basically solve problems using the Hadoop software. Now, what does that mean? Let's say I'm a customer and I come to your company and I say, this is the problem statement that I'm facing. For example, you would have seen in cricket, with every ball which is basically delivered, it basically gives you facts about what happened 10 years ago in this over at this particular point in time. What happened when this particular batsman, or how has this particular batsman performed in this particular stadium in the past 3 or 4 matches that he has played entire his career in that particular stadium, right? So all these kind of analysis are possible because of big data. And let's say I'm a customer who come to you and say, I'm basically from a cricket association, and we want this kind of a solution for us wherein we have all the data. What we want is this data should be used to do all these kind of predictions on the go. So can you help me with that? So this conversation will basically be done with the Hadoop architect. The Hadoop architect will basically understand, okay, so these are the requirements. He will basically convert them into requirements which his team of Hadoop admins and developers can understand, and they will then go ahead and create a solution for them. Okay, so a Hadoop architect role is basically a very senior role. Then comes the Hadoop admin role. So when the Hadoop architect basically tells which kind of an infrastructure they need, what kind of nodes they need, what kind of softwares they need, the Hadoop admins go ahead and implement them, right? And the applications which basically are developed onto the Hadoop ecosystem, which work on the Hadoop software, these applications are basically then done by the Hadoop, or then created by the Hadoop developer. Okay, so these are the three profiles. Today in this session, we are basically focusing on how to become a Hadoop developer, right? But if you were to think of which profile is more suitable to you, if you are from the admin background, if you know about Linux, if you know about clouds, then I would suggest you go to the Hadoop admin profile. If you are a person who is from the development background, who basically wants to go ahead and pursue his career in development, I would basically suggest you should go ahead and become a Hadoop developer. And if you are a person who has a lot of experience under his belt, he understands how architectures are deployed, but he still wants to shift to Hadoop to understand how architectures are deployed in Hadoop, you should go ahead and become a Hadoop architect. Right now, with this thing cleared, let's go ahead and talk about how you should become a Hadoop developer today. So, guys, a Hadoop developer uh, can play a lot of roles when he's working in a company based on what kind of company he's working for. For example, if he is working for a startup, he would be expected to do the job of a Hadoop admin and a Hadoop architect as well, and he will be paid very well for that particular job role. So that job role would basically involve planning, it will involve architecting, it will involve managing, and at the same time, it will also include monitoring and support. But since the Hadoop developer job profile only will be handling so much things, so many things which most of the companies are expecting a Hadoop developer to do, they pay a very good scale for that kind of job as well. Now, the average salary that we basically discussed, that will not be relevant to this kind of a job role where they expect you to do planning, architecting, managing, and monitoring and support as well. You can easily expect your salary to be between 10 to 16 lakhs per annum in India. And in the US, you can expect your salary to be between 130 to $150,000, given you have this much skill set that you can play multiple roles inside that company. Okay, so uh, what all do you would want to know if you want to have a successful career as a Hadoop developer? You should know planning, you should know architecting, managing, and monitoring and support. Okay, now what are the different things that you would need as a skill set when you want to become a Hadoop developer? You would not want to know about cloud, such as Amazon Web Services, which is the biggest cloud provider in the world. You would want to know about a programming language such as Python, so that you can do scripting more easier. You would want to know about Linux as an operating system, because Hadoop primarily works on the Linux operating system, and most of the other softwares in the IT industry too, right? Most of the servers that are deployed on the cloud are also based on Linux, right? And you should also be good with shell scripting, that is the Unix or Linux shell scripting. That should also be a skill set that you should be knowing. Okay, and knowing about an additional cloud provider such as Microsoft Azure would also help you in understanding how things work.
So a little bit of background history on Hadoop if you guys are interested. So Apache Nutch was a software that was created by Doug Cutting and Mike Caffarella in 2002. Then the Nutch distributed file system was established. This is essentially the first iteration of the HDFS. And then the MapReduce was established out of Nudge to be clubbed into a new project. The NFTS and the MapReduce was extracted out of the Nudge software to be put under a new project called Hadoop, and that is the Hadoop that we know today. That updated and upgraded in versions to the Hadoop, the 3.2, the latest version of Hadoop that we know today. So Yarn was introduced somewhere in between HBase, Hive, all of these components on top of Hadoop, and finally the Cloudera was incorporated, and the final release that we have in Hadoop is Apache Hadoop 3.2. So that was a little bit of background history of Hadoop, although not very relevant today, but it's important to understand the history of how certain component softwares have come to the point that they have. So what is HDFS? We discussed HDFS before, so what is HDFS in specific? HDFS is a file system designed for storing very large files with streaming data access patterns running on a cluster of commodity hardware. So the most important revelation that Hadoop brought to the scene was the usage of commodity hardware. Up until Hadoop came into the scene, what was happening was we were using these expensive servers to store big data. We were using expensive servers and processors and to basically store big data and store it in distributed file systems or single file systems, running all these operations in parallel. Hadoop basically gave us the benefit of being able to use commodity hardware. Commodity hardware means regular use hardware. It could be your PC or my PC that we use personally at home or at our offices. The specifications of these computers don't need to be that high because what HDFS essentially does is connects all of these computers that we would call nodes in parallel across the distributed file system, and all of the operations, all of the storage that is being implemented in these file systems are stored uniformly, equally across all of these nodes that are present in the cluster. So commodity hardware, basically we don't need to go out and buy very expensive server hardware for this. We can just use the clusters, the nodes that we have in the office already present, and we can store large files with it. Basically, the storage of big data problem is solved. We can process this big data using the processing components of these components of these nodes that we have across the cluster, and basically this reduces the cost a lot, helps us increase fault tolerance, and overall increase the efficiency of things because Hadoop manages all of this in the background. We don't need to manually interfere with anything other than the configurations. So, what are the design factors? What are the advantages essentially? What was Hadoop distributed file system designed with the aim of? So, the first is high throughput, basically high efficiency, and the second is handling large data sets. Obviously, if we have large amounts of commodity hardware present inside the cluster, we can store data in a quantity that is directly proportional to the cluster size. Then we have hundreds and thousands of nodes, so we can keep adding nodes in this cluster. The more devices that come inside the organization or the workplace that we're working in, or more servers that come in, we can keep adding that. So basically, thousands of nodes can be managed and maintained in uniformity using the HDFS, and then portability across heterogeneous hardware software. So say your nodes are not of the same operating system or don't have the same hardware in them. It doesn't matter. You don't need to have compatible hardware or compatible software across the cluster. One person can have a Mac PC, the other person can have a Windows PC, and the Mac PC and the Windows PC can still be part of the same Hadoop cluster. So these are the things that the HDFS achieves, and these are the design qualities of it. Then we discuss the architecture. Firstly, we'll look at the architecture just in diagram form. Firstly, the primary two components of the HDFS are the name node and the data node. The name node is essentially, if you've studied linked lists before, the name node is the node that provides us with the addresses of the data nodes. So say if you have a large text file, it's a 3 terabyte text file. So it's divided into three 1 terabyte files to store across various nodes. So it's distributed uniformly across all the nodes present in your cluster. So what the name node contains is the information of the start of the first file and the end of the first file and start of the second file and the end of the second file and third file, so on and so forth. So the name node contains that information. It basically points to where the data begins and where the data ends. So whenever the data is being read or whenever the data is being processed in the data nodes, from the data nodes, the name node can easily access that amount of data, whichever is required, because it has all the information stored in it regarding where the data is stored. So the client wants a write or the client wants a read. So the name node manages all of that depending on the file location in the data node. So we will be discussing an example in diagram form. What happens? What is the exact process which occurs when we are writing a data into the HDFS? So basically, what does writing a data into HDFS mean? We can look at this from a Google Drive point of view. Say you're on a Windows PC, you're uploading a file from your local system to your Google Drive. So in a similar way, you are working in a workplace which uses a Hadoop cluster. You have a local system. You want to upload something on this Hadoop cluster. So when you upload a file from your local Windows system or your local Ubuntu system to the Hadoop system, that is essentially the writing of data into the HDFS because you are storing that data into HDFS. Rather, I would say the HDFS is automatically storing that data uniformly across its nodes. So the first step is the client requests to create a file. Obviously, you're sitting on the client end and you connect to this large Hadoop cluster. You request to create a file. The name node is connected once a block of data is accumulated. When you
Just a quick info, guys. Intellipaat provides online big data Hadoop training in partnership with IBM, the course link of which is given in the description below. Now, let's continue with the session.
upload it, when you put the data through for writing inside a file, writing inside the cluster, the name node essentially communicates to the data nodes, the list of data nodes, the name node responds to the client with the list of data nodes, basically the information of where the data is stored so that the client is able to see it. The data nodes receive data after the client, the name node and the client have approved the storage of data, the writing of data. So essentially, we write the data inside the data nodes when the data nodes receive it from the HDFS client. Then the data node forwards the file to a second data node for replication and to a third. So this is where the fault tolerance aspect of it comes in. So say if it's a relatively smaller file, you don't need to divide it into various subfiles. So basically what the data node would do is create copies of that file and store it across different data nodes so that even if one data node fails, we can still access that file. So, however, how doesn't matter how many parts of that file have been created, all parts of that file are replicated to enhance fault tolerance of an HDFS. So then what happens is the name node commits the file creation into persistent store. It receives heartbeat and block reports. So the name node in its own information storage area, it stores the data, stores the information of the data where it has been replicated and where the original data is. It stores all of those information, all of that information, and the name node also manages the monitoring of the health of these data nodes. So it keeps monitoring the heartbeat. So essentially, it keeps pinging them. The name node keeps pinging the data nodes to wait for a response, and the data node responds. Then that means the heartbeat is healthy. If the data node doesn't respond, then that means that the data node is not functioning. So the name node can use another neighboring data node to pick up the file if the client asks for it. So the core component, the second core component that we discussed just a while before is MapReduce. So MapReduce also acts as a core component for the Hadoop ecosystem. It is a completely a software framework, so it doesn't involve any of the node logic in it. But yes, it is coded in Java, so it is essentially used to leverage the HDFS and perform much better than traditional processing frameworks for big data analysis. So what does MapReduce do? So basically, when you have a file, a large file, it may be divided into subfiles and present and stored across various data nodes. So the mapper, when you push your programming logic inside the HDFS inside your Hadoop system, so the code is pushed into it. The mapper then starts running. Now, what the mapper does is, according to the code, it would run parallelly as an instance for every part of the file across various data nodes, so that we don't have to perform that processing sequentially, and it all happens at the same time essentially. So it speeds up the process. So when all of the processes have executed in parallel, the output is then sent into the reducer. So reducer might be a common place where all of the mapping output is sent to, and the reducer gives us the final output, and which is stored in the output file essentially. So two aspects to it: the map and the reduce. So that's why it's called the map reduce. The mapping deals with the parallel processing of data, and the reducing means the aggregation of data. The aggregation of data might also happen in parallel, and we might create multiple files for it, and those multiple files may be merged into one so that we can see it as a common file. So that is how the MapReduce component of Hadoop works. Then we discussed the advantages of Hadoop. So why do we use Hadoop in general? What benefits does it have? So why don't we use legacy systems to do this? Why don't we use traditional distributed file systems to do all of these things and just run the code parallelly on all of them? The problem of scalability, process only structured data. So legacy systems only process structured data. They are expensive, as I told you. If you're buying specifically for maintaining a cluster of distributed file systems, the server component parts, the hardware parts might be a tad bit expensive, cannot process huge amounts of data. So, since there is no software framework involved with these legacy systems, there is no efficient method to process this large amount of data. So, it might not go in the most appropriate manner for possible when we execute analytic operations on these large amounts of data. So, cannot process huge amounts of data and cannot process heterogeneous data. Heterogeneous data means if the data has some sort of variety, as we discussed, that for a data to be classified as a big data, it should have variety. If the data has a lot of variety, legacy systems are not capable of handling that data. So why Hadoop? It is flexible. A major challenge for any company or organization is the handling of structured and unstructured data available in big data. Hadoop is flexible and handles structured and unstructured data efficiently. So whatever you put into Hadoop, whether it is unstructured or structured, Hadoop is able to manage it flexibly with the use of software. Hadoop can also manage encoded data. Basically depends on what the company needs. If the company is dealing with encoded data, Hadoop, inside a Hadoop framework, we can program it in such a way that we can deprocess that encoded data and take out some information out of it. Then we have scalable. Obviously, Hadoop is scalable, which means we can add as many nodes as we want and remove as many nodes as we want. We don't have to do anything complex to add the new configuration. Hadoop does it automatically for us. Once we just set up a new node inside the HDFS, Hadoop automatically detects that there is a new node and it distributes the files accordingly. It balances the weightage of files present across the various nodes inside the cluster accordingly. So we don't need to deal with that. Hadoop does it for us. That is why it's scalable. And the nodes are independent of each other. So if you're using systems present across a workplace, even if one PC goes down and one server goes down, the other servers are still functioning. The data has been replicated. So there's no loss of data and the nodes are independent of each other. So if one node goes down, that doesn't mean that any of the other nodes should go down. Fault tolerant, as we said before, we replicate data and high speed data processing. So because the processing is running parallelly across various nodes, that means we are achieving high speed data processing and doing things much faster than we would be able to if we were doing it sequentially. So Hadoop versus RDBMS, what are the advantages of Hadoop over RDBMS for storage? If we are using traditional relational database management systems, they only contain structured data. We obviously need to add attributes to it, and that is how we can store data. Hadoop can be used for all three types of data: structured, semi-structured, and unstructured. It can be used for large data sets, while in RDBMS we cannot use it for very large data sets. It would be a lot of overhead on the server, and then Hadoop can read and write data quickly, and whereas in RDBMS we might have to implement certain methodologies to write data quickly, but we can access the data we can only read the data as we desire. We cannot actually write as much as we want in a huge amount of time, in a small amount of time. Then we move on to the hands-on section of the tutorial. The MapReduce that we have right here, we have three components. The first is the word count. It is the driver class. We're doing a word count operation using MapReduce. We have the driver class over here. The driver class first calls the mapper. The mapper basically acts upon all the files that have been divided inside the HDFS in parallel. So it creates what we call as key value commented over here. Key value pairs, that is what the mapper creates. So basically, if you have a file which is I am a good person I. This is the content of the text file that you have. What the mapper would do is create files like create an array, create a list essentially with I, comma 1. I would map to 1. M would map to 1. A would map to 1, and so on until again we come with I would map to 1. So this is what the mapper would generate, and once this has been generated, we can see that we have two I's over here. This all could be executing in parallel. So say you have two different mapping operations that are going on, and this file had been divided like so into two parts already across different nodes on the same Hadoop cluster. So the first mapper would be operating on this, and the other mapper, which would be running in parallel, would be operating on this. So This would generate this output, the A and I, and this would generate this output. So as we can see, there is a similarity between these. There are two similar key values, which are I's. So the special logic that the map reduce would follow is that it would send these two I's to the same reducer. So the final output that all of the reducers are, all of the mappers after running in parallel for at least the I key element, in the case of I, it would generate something like this. After all the mappers have executed in parallel, we now know that there have been two instances of I with the value 1 mapped to them, as you can see here. The int writable for the key is 1, so every time 1 has been mapped whenever a key is occurring. So this would be sent to one reducer instance. So essentially I'll copy this from over here and paste it over here so you guys can have a reference. So it has been sent to the reducer now. So this is what the reducer gets as an input, one reducer instance. So here we can see we're initializing the word count with 0. So initially the word count for I is 0, and while there are new values in this list, while has next, values has next. So it will keep incrementing it with values.get. The values.get would give us 1, and it could give us anything, but in this case, since we are only writing 1 inside the mapper, it is giving us 1. So we would get that, and once this has finished executing, as you would, the final value that word count would have after the loop has ended is 2. Since there are 2 occurrences per 1, so it would add 1 and 1, and we would get 2, and when it would reach the final uh, position on this list, and when it would check what has next, it would give us null, so the loop would exit control, and we would finally do the output for collect. That's just the word count. For the key I, we would get the word count, which is 2. So the final output would contain I. So this is how basically the reducer works. So we, from that example, we know that things can happen really fast if all the mappers are executing in parallel and all the mappers are independent of each other in their processing. So they don't need to communicate with each other before performing their respective tasks. It is only in the end where their works are being aggregated by the reducer. So that is where the sequence sort of matters. While the mappers are executing in parallel, any of the parts of the text file can execute first. It wouldn't matter the final output. So once this has been executed, I'll simply create a jar file out of this and show you how easy it is to run MapReduce operations in big data analytics. Simply create a new file called word count yt.jar and paste it over here. Finish. I haven't saved one file. Save it before we execute. I've saved it. So export jar word count and I'll click on finish. Yes, there's already a file that exists on desktop, word count yt. I'll replace that and click finish. Once we've finished, we already know that there's a word count yt.jar. So before we begin, we have to create a directory to store our source document inside the input document. We write do fs mkdir, we create a directory and call it input ytt. Let's enter. Create a new directory. Not create a new directory, actually we'll upload the file from our Linux system to the Hadoop server. Put Shakespeare.txt. This is a text file that is present in my home directory, by the way, don't be confused by that. And we'll simply, let's not type this, I'll just copy the input directory that I just created and paste it over here. Once we have done that, we can be sure that our file has been uploaded inside the Hadoop server. Now we will simply run the Hadoop jar operation that we have on the new file that we just created, which would be under home training desktop. As you can see, it's on the desktop, word count yt, and the file name, which is word count yt.jar, and we would use the class name, which is word count, the driver class name, the main class name, basically, and then we would use the input directory for our file where we've stored our Shakespeare.txt. We'll copy that and paste it over here, and then we would create a new file, new output directory to store our output into. So we use the training, and we would call this output YDD, and we'll press enter. As you can see, the job has started, the MapReduce job, and it will take some time before it executes. It's basically counting every word that is present inside that data set. The mapper has successfully executed, and the reducer has executed as well. We will now check the output Hadoop fs and use CAT for that. We will use the output directory that we just created for this. And paste it over here. We'll add part 5 zeros. And this would be the traditional naming system that Hadoop uses to inside the HDFS to create output files. So Shakespeare.txt is a smaller file, smaller data set, so it generally generates only one part file. So we don't need to concern ourselves with the other ones. So we'll basically look at this. And here we have our word count, basically count of every word present inside the Shakespeare.txt. That's a little bit of hands-on how MapReduce works and how easy it is to use Hadoop, and that is about it in the hands-on. So basically what you need to gather from this is you can write simple Java code as long as you're importing Hadoop libraries inside. You can perform those simple Java operations on very large data sets as well without having to learn any newer technologies or whatnot. So that is the one of the biggest advantages of becoming a big data developer, understanding big data, because the possibilities are endless, and once you have access to a big cluster, you can execute that same sort of logic using the same methodologies as you would use for smaller data sets. So
Just a quick info, guys. Test your knowledge of big data by answering this question. Which of the following are incorrect big data technology? A. Apache Hadoop. B. Apache Spark. C. Apache Kafka. D. Apache PyTorch. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
if you're intimidated by by the phrase big data, you shouldn't be, because it is basically same coding logic. You just need to implement it inside a Hadoop cluster. So now that the hands-on is done, we can now discuss about the other elements that run on top of Hadoop or alongside Hadoop, the components that we can use that complement Hadoop, basically the Hadoop ecosystem. We have a figure for it. So up until now, we discussed what the HDFS is and what MapReduce is. So MapReduce essentially deals with the processing aspect of Hadoop, and deals with the storage aspect. So one step by step, we will now be discussing everything that is present inside the Hadoop system. First, we have Yarn. Yarn is resource management. So how does Hadoop operate? How are jobs allocated inside Hadoop? As you just now saw, I executed a MapReduce job. So how are those jobs allocated efficiently across various nodes present inside a Hadoop cluster? So we use Yarn for that. So what Yarn does is it assigns jobs to the various nodes present inside your Hadoop cluster in a manner efficient enough that there is no imbalance created anywhere. So basically, a resource management system. We have Hive. Hive is a data warehouse software. Basically, it's a warehousing tool. It is used to take the larger data set present inside a Hadoop file system, and we can basically warehouse it and view it according to however we need it to view. So, what is Spark essentially? Spark is a computational engine which is 100 times faster than Hadoop. It uses Hadoop as the storage unit, so basically all the files that Spark picks, all the is stored inside the HDFS, but it doesn't use the MapReduce implementation that Hadoop has. Spark uses own computational engine. It processes the data, and it could use libraries like mlib to further create models, machine learning models out of that data. Spark works with Python and Scala, so these are the two languages you can use to basically take advantage of Spark. Then you have Pig. Pig is used for processing large amounts of log files. So log files fulfill the criteria of big data because they are continuously generated. They are of extreme sizes when we are talking about large websites, large commercial organizations. A huge amount of log is created in those entities. Then we have HBase. HBase is a NoSQL database. So with your storage place set in the HDFS, the database set in the HDFS, if it is a NoSQL format database, you can basically query it with HBase. And then we have Zookeeper, and Zookeeper is basically used to coordinate the various nodes that we have present across the present across the cluster essentially, and it is used to coordinate all of those nodes to perform a single task or multiple tasks, basically scheduling the tasks. That's what Zookeeper does, management and coordination. We've already discussed Spark. Kafka is used to attain data in a real-time environment, creates a pipeline between system and applications to ensure a fluent flow of data between the system and application in real time. Then we have something like Uzi, which is used for scheduling inside a cluster. It's used to schedule jobs just as well as Zookeeper. Then at the bottom, we can see something like Flume and Scoop. What Flume does is it takes real-time data from websites and it transfers it and stores it inside the HDFS. As you can see, there are a lot of logos near Flume, like Facebook and WhatsApp, and the unstructured and semi-structured data that is generated from these websites that is accessible by Flume, that is publicly accessible or accessible within an organization. It takes that data and puts it into the HDFS so that we can further process it using any of the tools that we have on top of the Hadoop architecture. On the right hand side, we have Scoop. So if you want to transfer data to and fro between a traditional relational database management system and the Hadoop distributed file system, if you want to transfer data in between those two entities, you can use Scoop for that. So it acts as a bridge to for transfer of databases between the two.
Introduction to big data, right? For those of you who are completely new to the entire concept of big data, we're going to be going through this step by step. So, understanding the concept of what data means in the first place is extremely important because these days data is quite a generalized term. It actually covers a lot of things, but there are categories associated to it. So, firstly, by definition, data is the individual unit of information that is defined as figures or facts and is stored for later processing onto your computer hard drive. It could be anywhere, essentially any storage device, and it is divided into three parts. So the first is structured data. Now, for those of you who are coming from an SQL background, this sort of data you're quite familiar with. This is the data that is present in SQL tables with proper rows and proper columns, right? It's in proper queryable form, so to speak. You can query it pretty easily. There is structure to it, and it is the most organized form of data that exists. Secondly, we have semi-structured data. Now, this is a combination between completely a random order of data and some sort of a structure associated to it. So, for instance, you have files like JSON files, CSV files, and those files have a particular format associated to them. For instance, in CSV files, which is an abbreviation for comma separated values, all of the data records are separated by commas and delimited by by line changes. So essentially, it mimics an SQL table with proper rows and proper columns, except it is in the form of a file, and you have just provided commas between the data records to differentiate between the column. So that is what essentially CSV is. So in a file format, it does have some structure to it. That is why that file format is called a semi-structured file format, and the data is called semi-structured data. And so is the case with JSON and XML and other semi-structured data sets as well. And finally, we have unstructured data. Now, this is completely random in nature. As you can see, the examples that we can see are JPG, PDF, MP3. So if you were to convert these data files into text files and see the contents of those text files, you will see completely random order of information. It would make absolutely no sense, right? So that is what unstructured data is. Now, unstructured data is the most challenging data because to derive some structure out of it, you need a lot of computing resources. You need to understand how the data behaves and a lot of other aspects as well. So these are the three types of data that exist. Now, big data has a definition. It has a distinction. It simply does not mean that the data is extremely large in size. There are other criterias as well, right? So there are five criterias in total, and these are called the five V's of big data. So, what are the five V's of big data? These are the five V's of big data: velocity, volume, variety, veracity, value. Let us go through them one by one. Velocity, the rate at which the data is being accumulated or generated should be really high, right? So, say for instance, you're working for an organization where data is coming in real time, say per minute or per hour, per second, in that sort. The data has a really high volume per second or a really high volume per minute. In that case, the rate of the data is really high. The rate of the accumulation of data is really high. So in that case, it satisfies the criteria of velocity. So if it's anywhere between the higher gigabytes to terabytes to petabytes in a day, then you can account for velocity in that particular aspect. And then we have volume. Volume means the most obvious thing about big data is that it's big. So anywhere you're storing big data, it should be extremely large in size, from terabytes to petabytes. That accounts for volumes. Next, we have variety. Variety means that the data should not be coming from a single source, and the data can be of multiple file formats or data formats as well. So, for instance, if you're working for a big e-commerce organization like Amazon, so you have something like user data, you have something like sales data. So, both are two separate databases, right? But for people in the higher management, they need to see this data all collaborated together, right? So, they will combine that data and see it together. And basically, when you're combining data from multiple sources together and seeing it in a combined view, you're accounting for variety as well. So, any big data case, you need to have variety in the data as well. The data cannot simply be of a homogeneous source. And then we have veracity. Veracity means that the data should not be error free. So basically that means that the data should have some noise in it. Data should have some missing values in it. The data should have some wrong or inconsistent values in it. So that basically means that any data set that you'll pick that is based on real world values will always have inconsistencies in it, right? Say for instance, if somebody is generating a data set out of Facebook, so a lot of people on Facebook have created fake accounts as well with fake details, right? So if you were to perform a marketing survey, right, you cannot actually look at these fake accounts and decide your marketing strategy based on that. You need to be careful about that. So the data should have veracity as well because any real world data set will have that. And finally, value. So whatever columns you're picking, whatever data you're picking should have some value to it, right? Say, for instance, you have a data set filled with complete random numbers, 100 random numbers, and you have a data set which has the academic records of students in an university, right? So you will not consider the data set which has 100 random numbers as the data set with value because you cannot create any analytical model with it because it is just a set of random numbers. They don't have any value in the real world sense of things. So now that we understand the initial concept of big data and the distinction between data and big data, let us go through the characteristics of big data, right? So firstly, the most natural problem that comes with big data is the problem to store it, right? So I just talked about the volume of big data, and it should be from somewhere around terabytes to petabytes. And these days, we hardly have 500 gigabytes to 1 terabyte of hard drive spaces in our laptops or in our working computers, right? At maximum, we have 2 terabytes, right? So it's quite a difficult issue to store big data on those computers, right? So that is the first problem that we have with big data. The second problem that we have is that it's really time taking to process, right? So for instance, if you have a data set with 10 records, 10 rows, it's very easy to process. It'll happen almost instantly, right? But if you have a data set with billions of records, right, which may be the case in big data, then obviously it'll take a lot of time to process that. Maybe days to months, depending on the processor speed that you have, depending on the number of cores that your processor has, depending on the number of threads that your processor can run simultaneously, right? So these are the two primary problems that we have with big data. So even if we had a 10 terabyte hard drive, right, and we were storing 1 terabyte of big data on it, right, we still need a very, very powerful processor to be able to process that 1 terabyte of information. So, with these problems arising, solutions also came up. The solution for the storage issue was Hadoop HDFS, and the solution for the processing issue was initially Hadoop MapReduce, and then in the modern times it is Apache Spark, right? So these are the technology stacks or frameworks, I should say, that solve the big data problem, right? So let us understand these frameworks and how these frameworks work and how big data clusters work, right? So firstly, let us understand what HDFS is. Now, HDFS is an abbreviation for the Hadoop Distributed File System. So it's quite similar to the file system that you have on your own computer, like you see in your Windows Explorer or your Mac File Explorer, right? Or your Linux File Explorer. You look at the file system over there. It's quite similar to that, except this file system is collaborative in nature, right? So that means this file system is not just based on one computer, it is based on the entire cluster of computers that you're connecting together in a network to create your Hadoop or big data cluster. So it might be confusing. Let us go through this step by step. So Hadoop is a Hadoop distributed file system is designed for storing very large files with streaming data access patterns running on clusters of commodity hardware. So, very large files means that the data can be gigabytes to terabytes and petabytes in size. The HDFS manages that storage flawlessly. Streaming data access, each analysis of the dataset involves a large portion of the dataset, so the time to read the whole dataset is more important than the latency in reading the first record, right? So basically, that means that even if the computers are far off, right? Even if the computers are not connected together at a very close range, right? If they're connected remotely together, right? That is not an issue as long as the internet speed is good, right? So for instance, the latency might be high between two particular computers, but once the request response starts, right, you still have a constant speed between those two computers and the jobs will run without any issue. So that is what streaming data access means. Basically, the latency is not that relevant unless you're doing something where latency matters a lot. Then we have commodity hardware. So commodity hardware was a concept that came up back when Hadoop was created. It was when hardware was really expensive, when RAM was really expensive. So what it essentially means is that instead of buying entire servers with a high RAM, high hard drive space, what you can do is you can install Hadoop on commodity hardware, which means you can install it on the computers that you have in your own office spaces, the everyday workstations, right? You can just reserve a certain section of those workstations and dedicate it to your Hadoop cluster. So instead of investing in an entire server farm for your Hadoop cluster, for your big data cluster, you can simply use the computers that you already have. So that is what commodity hardware means. So next up, let us understand the architecture of a big data cluster, right? So you have LAN wires in your office space, right? You have Wi-Fi in your office space. So what it essentially means is that whenever you are configuring Hadoop on your cluster, on your network, right? And you're telling all of these systems to find each other. When they start functioning, they will start sharing files with each other as well when required. And all of that happens seamlessly without you knowing any of it, right? So that is the advantage that you get with Hadoop. So if we were to map the previous diagram to a more refined and detailed HDFS architecture, so we can see that we've converted one of those computers into a name node. So we've basically configured one of the computers into a name node, and the remaining three we've configured as data nodes, right? And we've installed Hadoop on all of them. So what happens essentially is, say for instance, you are a client or you're somebody who's trying to access this particular cluster. So you have a file to upload. Essentially, you have a petabyte file or a terabyte file to upload, right? So you will contact the name node first. The name node will tell you which data nodes have free space, right? So once the name node tells you which data nodes have free space, you are connected to the data node that you need to be connected to, and then you start transferring your file there. But it does not end there. What happens is, say for instance, you have a 1 terabyte file, right? But it is almost a certainty that these data nodes will not have that much of free space, any single one of them. So what will you do? You will divide this file into three parts, right? Depending on the size of the file, depending on the block size that is configured into your HDFS, this file will automatically be divided into a lot of blocks, right? So for now, for example's sake, let us assume that that 1 terabyte file has been divided into three blocks, right? So the first block will represent by green, the second by this orangish color, and the third by this reddish color, right? So you've uploaded that file, and say for instance, the green part gets uploaded on data node 1, the red part gets uploaded on data node 3, and the orange part gets uploaded on data node 2, right? So keep in mind that there may be a lot of other data nodes as well, but right now we are going with an example of only three data nodes, right? So what happens after that? The file has been divided into three equal parts and it has been stored in three data nodes, right? But what happens when you try to access it? Right? When you're a client, when you try to read that file, you'll see that file as a one file. You wouldn't see it as three divided files. You will see it as one file. The combination of files and the division of files when we are writing it and reading it is managed entirely by the HDFS. So the next thing that is very important is data replication. So basically, in order to provide a data loss prevention feature, HDFS has come up with a feature called data replication, where you can set up a replication factor, right? So say for instance, you have set up a replication factor of 2. So what will happen? You store one block of data on data node 1. The data node 1's block, the screen block, will automatically be replicated two times on the nearest two data nodes or wherever the data nodes have available space. So one would be stored on data node 2, the other would be stored on data node 3. So in this particular case, even if data node 1 fails or something goes wrong with data node 1, you still have access to the first part of the file, right? So that is the advantage of data replication. So you can set up auto data replication. So whenever you store anything on the HDFS, it will automatically be replicated across the cluster as well, so that if any damage occurs, you still have access to the entirety of the file. Let us understand what MapReduce is. So we know how storage happens in Hadoop. Now we can understand how processing happens in Hadoop. Like there are two parts involved in any big data procedure. So first is storage, the second is processing. MapReduce is the programming model suitable for processing huge data, right? So MapReduce is unlike anything you've ever seen if you are not aware of the domain of big data. So basically, Hadoop is capable of running multiple MapReduce programs written in various languages like Java, Ruby, Python, and C++. So you have MapReduce libraries available for these particular languages. And MapReduce programs run in parallel. So they are very useful in performing large-scale data analysis using multiple machines in the cluster. So for those of you who are not still understanding what this means, it means that we just discussed earlier on in the HDFS architecture that we were dividing data and storing it across nodes in a cluster, across three data nodes. So for instance, here let us imagine these three data nodes, right? So this particular data node contains the green part, this contains the orange part, and this contains the red part, the third one, right? So what will happen next is that you'll map it. So firstly, any procedure, any data analytics procedure that you're performing, whatever is present in your code, it will execute in a map reduce format. So firstly, the data will be mapped. So it will be converted into key value pairs, and then the next step is same keys will go to one reduce operation. So for instance, if there are key values with the key being 1, all of the keys which are 1 and the values corresponding to them will go to one reduce operation, and all of the keys which are 2 will go to one reduce operation, right? And then you'll finally get your output essentially. So to sum it short, to give you the brief explanation of this, each data node is executing their part of the file on their processor itself. They are not actually collaborating until the output has been generated, right? Once the output has been generated, they all combine their output and show it together. So that is what parallel processing means. So instead of performing this entire operation on one computer, this entire terabyte of file, we have divided that 1 terabyte of file into three parts, and we are executing each part of that file on their respective node using their processor, dividing the entire time of the operation by 3. So you can understand how efficient this can make things. So depending on your cluster size, you can further reduce the time it would take to perform this operation as well. And we also discussed about Apache Spark, right? So there is one other technology that is used today because MapReduce, like we just discussed, is now sort of redundant, right? But based on the same concept, essentially, we have Apache Spark. So for instance, let us look at the distinctions between MapReduce and Apache Spark. You have a big data set available to you right over here. Then you pass it through a MapReduce program, and then you get your desired output. The problem with that, though, is that earlier on, when MapReduce was built in the early stages, where RAM was extremely expensive, we used to use hard drive space as a sort of replacement for RAM because RAM was really less. You had like 512 megabytes of RAM on one computer, and you had a terabyte of file, or say you had a 2 GB block size on your particular node, right? So it would take you 4 steps essentially to process all of that data if we were to go by it roughly. So problem with that is every time you're transferring that 512 MBs of data to your RAM, you're having some latency issues with read and write operations. So every time you transfer data from your hard drive to your RAM, it takes a bit of delay, right? And if you are dealing with extremely large amounts of data, that little bit of delay over time can add up. So when that adds up, your process of getting your output becomes slow. So we can see that there are read-write operations on the disk. So you're transferring the data into the RAM. The data is going into the CPU. It is being processed. It is being put back into the RAM and then being put back into your hard drive, right? So the time taken between for the data to transfer between to and fro between the hard drive and the RAM is adding up essentially. So you're getting your output, but with input output delays. So as random access memory or RAM or physical memory got cheaper, we came up with the technology called Apache Spark, which uses the Spark engine, right? So Spark engine is something that speeds up this entire process over 100 times compared to MapReduce, depending on the size of the data. For lower sized data sets, the difference is not that noticeable, but for higher sized data sets, you can definitely see the difference between the performance of Apache Spark and Hadoop MapReduce. So Apache Spark does this by using in-memory processing and the usage of shared variables across nodes, something that MapReduce did not do. So what does in-memory processing mean? In-memory processing means that when you transfer that data and say for instance now that RAM is cheap, you have like 64 gigabytes of RAM in mobile phones today. That is how cheap RAM has become. You can simply transfer the blocks of data that you have on your respective node on the data node and transfer the entirety of that in the RAM in just one go rather than four tries. So what that will do is you'll have the entire data available in your RAM at all times during the entirety of the execution of the job. So until you're closing down your Spark session, like until you're closing down your Spark job, you will have the entirety of the data set available in your RAM. So that basically reduces any possibility of input output delay between the CPU and the RAM and the hard drive, because you're not dealing with the hard drive after the initial transfer. You're not dealing with it anymore. Once the hard drive has transferred the data to the RAM will store that data until the execution of the entirety of the program. And then once the execution has happened, the output can go back into the hard drive. So you're essentially minimizing all sorts of input-output delays. So this is what in-memory processing is, and essentially the usage of shared variables across nodes can help with a lot of logical aspects in programming as well.
Just a quick info, guys. Intellipaat provides online big data Hadoop training in partnership with IBM, the course link of which is given in the description below. Now, let's continue with the session.
So let us look at the Hadoop ecosystem as well. We have looked at some technologies. We have looked at HDFS, MapReduce, and Spark. There are other technologies as well. The foundational elements obviously are the HDFS. So this is the storage system, and everything that is happening in the big data ecosystem is because of this storage system. So let us look at Flume. Flume is something that helps you integrate your HDFS with online APIs and services. For instance, data coming in from Twitter, Facebook, you can configure your Flume to ingest that data from time to time, and you'll get that data stored into your HDFS automatically. We have Scoop for people who are in the RDBMS business. They can essentially integrate HDFS with their RDBMS service by transferring data to and fro using the service we call as Scoop. And there are other services as well. We're not going to be going through all of them. For instance, we just understood what MapReduce means. We also have Hive. So a Hive essentially is something that uses MapReduce to perform data warehousing and querying on the data present in the HDFS. So Hive can be used for that. You have Spark machine learning library. So right now we discussed Spark processing. So you have other options as well available with Spark. So using the same format that Spark uses, you can also create machine learning models out of Spark. For creating scripts using the MapReduce concept, you can use Pig. You have HBase, which is essentially a NoSQL database present for the HDFS data. We obviously discussed Spark. We have streaming services available which transfer the data in real time to your HDFS. So, say Kafka will stream the data coming from a particular source into your HDFS continuously. You have other services as well. You have Oozie for scheduling, and you have Yarn for resource allocation. So Yarn essentially what it does is allocates resources. So for instance, any job that you try to run on your Hadoop server, Yarn will look at the resources that are available. It'll queue your job up, and then eventually it'll get your job executed by allocating resources to these data nodes to execute that job. And if you're looking for a UI to manage all of this, right? For instance, if you don't want to deal with command line terminals, you also have UIs available, and one of these UIs is Apache Ambari. It has Zookeeper in it, which helps you manage and coordinate all of the services and frameworks that are running on your Hadoop cluster. So why big data? Why is this field so relevant, right? So let us take an imaginary scenario. For instance, there are two organizations. One is organization A and B, and these are organizations that are dealing in the same business. Both organizations are generating sales and customer data for each transaction and user sign up interaction. So, e-commerce businesses have login, and you can basically create your account, and you can perform transactions on those websites. And these organizations obviously have a record of that data. They're collecting that data. So, here the same case is happening as well. Organization A decides to use this data to improve their business, while organization B doesn't do anything with that data. It just lets that data remain in the database, and it just continues on with the buying selling model that it has. So, in the span of 2 years, what happens is organization A takes over the entire market share, and organization B goes out of business. So, why does that happen? Why would that happen? It would happen because, say, for instance, you have user and sales data. What you can do with that data is you can gain insights with regards to what the customer needs or and what the customer wants, right? And once you know that, you can improve your website. So firstly, you will detect like which particular aspects of the user interface the customer likes, and based on that, you can improve the overall experience that the customer has whenever they log into your website or your mobile application. Then, secondly, you can expand or focus your product range. So, based on what the customer likes on your website, as an e-commerce in business, say, for instance, the customer likes computer hardware a lot, right? So once you know that, you will understand like, okay, there are a lot of customers who like computer hardware. Let us expand that product range on our website so more customers buy it, right? So and then you have some customers who are only interested in food items on your website, right? Then you will focus the recommendations for that customer only limited to food items so that they are more inclined to buy products from your website. And then, based on those accurate recommendations, you can provide targeted ads. So a lot of these organizations also have ads on their businesses available on the side, like pop-ups and whatnot. So based on what you like, based on your activity on their website, they can target ads towards you, so that there is a statistically higher chance of you clicking on those ads and actually subscribing or buying the products that are being displayed in the ad. And finally, because of all this, because the customer gets what he actually likes, because the actual data analytics model or the machine learning model simply assesses and aggregates what the customer likes and shows that product to the customer, shows the exact recommendations that the customer actually needs, and gives the customer a good user interface. There is customer engagement and there is customer satisfaction. These are the two key things in the success of any business, and that results in better sales obviously, and that could also result in the organization getting the entirety of the market share as well. So kind of a similar story with Amazon as well. because they have such good data science and data analytics models present within their algorithms, they have succeeded and they have gotten to the apex of the e-commerce industry. Nobody even comes close. So that is how important this is, big data as a concept in general. So gaining insights with regards to what the customer needs and wants, that is data analytics, and gaining insights with what the customer needs and wants when the data satisfies all of the five criteria that we had discussed, when the data is essentially of an enormous scale, which would be the case for Amazon or websites like Facebook, right? Then this entire process is called big data analytics. So organizations are looking for talented individuals in this field, big organizations, because a lot of organizations are generating data in that magnitude. So there is also a learning sort of progression that is involved with big data. For instance, you will start with data analytics, you can get into big data, right? And then you can get into data science with big data. You can get into machine learning with big data and artificial intelligence with big data. So rather than transitioning from a normal data analytics career to a data science career where you're not accustomed to big data, when you know big data, you can essentially create more accurate, way more accurate models in data science and machine learning because your data set is extremely large. You know how to handle streaming data. Right? You can create these models way more accurately than anybody with just a normal data analytics experience. So that is the advantage that you get with big data as well. It gives you an edge in the industry. So the average salary in the United States for a big data analytics expert or a developer in the United States is about $110,000. In India, it's about 7.5 lakhs per annum. In the UK, it's a good 45,000 pounds. So keep in mind, this is the average salary, right? So if you're getting into the field, you'll obviously get a lesser salary than that. But the more experience you get, these salaries are not basically providing you with a limitation. You can gain more salary in it as well. You can expand your career, you can learn more technologies, and you can increase your salary based on the experience as well.
How does MapReduce really work? Okay, guys. So it's a very simple concept. Books, a lot of people around, when you read a lot of blogs, would try to complicate it. Well, it's important to complicate because that's how people make money, right? So it's very simple. So just focus on the example, focus on the story, and we are done. Just focus on the story, and MapReduce will be done. It is one of the simplest thing that you would have heard, or you would be learning today. People would make big things about MapReduce, but it is that simple. So just focus on the example, my friends, and we are done. Just focus on the example. Focus. Tighten your seatbelts and focus. MapReduce is processing, but if I was a student, I would ask one thing to myself. What nonsense. Blocks are broken. Data is individually getting processed, but somewhere it has to consolidate, right? How will that work? Who will do that? That is where you to understand the concept of MapReduce. That somewhere data is broken, but boss, somebody has to consolidate. How will that work? And that's what we are going to see right now. So it's going to be very simple. Just pay attention, it will be done. Okay. All I need is your attention for next 25-30 minutes and we are done with this topic. So let's say we have 4 guys. We have 4 guys. Ajay, Abhay, Amit. So these are 4 friends who work for an organization. Ajay, Abhay, Amit and Abul, 4 guys are there who work for this organization, and their manager has told them that for next 1 year they are supposed to work on every Saturday and submit a report. Oh man, this is bad for them, right? So 4 guys, Ajay, Abhay, Amit and Abul, 4 guys. These 4 guys are supposed to be in office for the next 1 year. Every Saturday they are supposed to come, and they are supposed to do some job, whatever, some report they have to generate, some XYZ report we don't care about, but they have to come to office. Now Saturday is a weekend and you don't want everybody to waste the weekend. So these 4 friends Ajay, Abhay, Amit and Abul, what they do is they say that let's have a small deal that let's come at 8 o'clock in the morning. Let's work till 10 o'clock. Let's work from 8 o'clock to 10 o'clock. And 10 o'clock, one guy will stay back and consolidate the whole thing. One guy will stay back and consolidate the whole thing. So that not everybody is wasting the whole weekend, right? I mean, we'll come for 2 hours and then every week we will take turns. Like week 1, Ajay may stay back, week 2, Abhay will stay back, week 3, Amit will stay back, week 4, Abul will stay back. So that's fine. Let's do that. So it is this Saturday, early morning 8 o'clock, Ajay, Abhay, Amit and Abul, all 4 are in office. And from 8 o'clock they start working. 8, 9, 10. Everybody is done with their work. 8, 9, 10. 10 o'clock everybody is done with his work. And this week Amit is supposed to stay back. This week Amit is supposed to stay back. Okay. So all of them will hand over work to Amit. Amit will consolidate and give the output. My friends, this is MapReduce. Nothing big. MapReduce is so very near real to what our life looks like, how consolidation looks like. 8 o'clock to 10 o'clock, when people are minding their own business, that phase is called as map phase. Whenever you hear map, that means mind your business. That means you are not looking at the left how many people are there, you're not looking at right how many people are there. You are just doing your job. That is map. At 10 o'clock, everybody is done with the work. And when you push everything to Amit, that is called shuffle. And Amit will consolidate everything. Don't worry how that works. That is sort. And finally, Amit will do the whole thing. We will see what is sort, and that is called reduce. So my friends, all I want you to remember one thing about MapReduce is MapReduce people will make it very, very tough, but it is divide and conquer. All you should know is map means divide, reduce means conquer. Map, divide, reduce, conquer. Map, divide, reduce, conquer. Okay. All right. Let's take one more example and we will really simplify it. Okay. Let's take one example. So I want a number of students from each country. Okay. Now let's say all student details are in a file of 189 MB. That's fine. I don't know the size, you also don't know the size. Let's have it 189. So I'm putting 189, you're free to choose your number, that's fine. One thing is sure that with 189 MB, there'll be 2 HDFS blocks. How many blocks? 2 HDFS blocks. 128 MB and 61 MB. Now in map phase, we will have 2 mappers. How many mappers? 2 mappers. Now the way map works is it will take one student at a time and basically process it. I'm supposed to find students by country. So the mapper output will look like some students will be here, some students will be here. Because mapper will take one record at a time and process it and give the output. So our mind your business phase is over, where 2 blocks were minding their business without knowing what is happening on the other machine. They were only interested in what is happening on their machine. They were looking at one record at a time. That's how mapper is coded. Okay, life is good. After this is done, there is a reduce machine and everything should go here. So the act of throwing data here, oh, this is called shuffle. But my friends, before reduce can start, we need to create something called as groups or bags. And here there will be 5 groups created. Let's see how the groups will look like. China, C, D, okay, so it will be India, Malaysia, RST. Sorry, I'm not good at ABCD. This phase of creating bags is called as sort. And finally, reducer will take one bag at a time and say China 30, India 30, Malaysia 20, Singapore 10, Thailand 10. This is map reduce for you. Simple stuff. Divide and conquer. Divide and conquer. Divide and conquer. Simple stuff. Now, it's possible that it may still appear to be, no man, it's pretty complicated. Well, you have been doing map reduce since the very beginning of your career. Let's look at this. Now, the previous example that I saw, can I say this was nothing but select country, comma, count of star from students table, group by country. If you really see there were 3 students or there were 100 students, how will it go through? The RDBMS will find a way to go through each and every record. Okay, so eventually there is loop where scans each and every record. Then if the bag is created, if the group is created, insert in the group, else create the group. Don't worry, it's simple. And finally, for each group, perform count. Is not created. Think of it this way now. Even RDBMS will go through each and every record. Now, let's say first it finds India. First it finds India. Is India group created? No. Sorry. If the group is created, insert, create the group and insert it. Okay. So scan each and every record. If the group is created, insert in the group, else create the group and insert it. So let's see how it looks like now. First it looks at India. Is India group created? No. So create a group and insert within India. Okay. So like this it will insert, finally have India, China and all. So the bags will eventually look like, here each and every record is scanned, and here the bags will look like, the groups will look like China, India, and finally here for each bag you will say China 30, India 30, blah blah blah. Now let's phase it out. Going through each and every record, it's called map phase. Going through each and every record, it's called map phase. Putting everything in group, creating bags, it's shuffle and sort. And finally, performing the count or performing the aggregation. Reducer. This is MapReduce for you. It is that simple. It is that simple. So if you're clear with this, we are done with MapReduce. There are two more small details which I will add, and we will be looking at the code, but that's MapReduce for you. So just two more small things here, and we will. So MapReduce, everything is clear. Only problem is, man, that this diagram somehow has serious limitation that all the data should go to the same reducer. What if that reducer does not have enough storage? Then we are in deep trouble. Then we are in a serious trouble. See, this diagram is excellent diagram, but with a limitation that all the data should go to the same reducer. Man, if in big data, if you're talking of a diagram like this, there are thousands of machines running, everything going to one reducer, everything will be dead. Correct? So the point is, by default, the number of reducers in MapReduce program is 1, and you can change it, but you can change it. So if I wanted to have a load balancing, I could go for two reducers. But then if there are two reducers, my whole thing goes in a mess. Why it's a mess? How will I know what should go where? How will I know what should go where? And that is where a component just below the mapper is running, and that's called partitioner. Partitioner will decide which data should go where. So partitioner will ensure some data goes here and some data goes here. How it will decide, we'll see. So relax out. So partitioner may decide that, okay, China and India will go to reducer 1 and remaining 3 will go to reducer 2. Okay. And then here we will get China 30, India 30. And here I'll get Malaysia 20. Sorry. This auto suggest can really ruin your relationships. Singapore is 10, so it's 3080, yeah, and Thailand is 10. And then the developer can easily just run a merge command, which will just merge these two files, but the files are complete right now. So that is possible because of partitioner. Partitioner is the guy who load balances, but on what formula? Let's understand that. partitioner uses a generic formula which says key dot hash code. Now hash code is, just don't worry, it's some integer. It is generated by JVM, Java Virtual Machine. So key dot hash code divide by, or modulo, not divide by, modulo number of reducers. Key dot hash code modulo number of reducers. So think of it this way. Let's say India dot hash code. Let's say it's not in my hand, it's not in your hand, so let's put any number. Let's say 80. China dot hash code 86. Malaysia dot hash code 71. Singapore dot hash code again 71. Who knows? Nobody knows, right? So neither am I in a position to tell what it is, and neither are you in a position. Thailand 79. So if you see, modulo 2 is 0, modulo 2 is 0, modulo 2, because the number of reducers are 2. Modulo 2 is 1, modulo 2 is 1. That's how it gets decided who will go where. That's what is done by hash code partitioner. So partitioner by default works this way, and it is a guy who will basically load balance the whole thing. It will simply load balance the whole thing. It is as simple as that. Now, neither do you know hash code, neither do I know hash code. If everybody was having an even number, then everything would have gone to one reducer. That would have been a problem. Okay, so that's where a developer can come in and he can change this logic. He can write Java code to change this logic and say that, oh, I don't like this partitioner, I would like to have a different partitioner. So a developer can do that also. A developer can do that also. Okay. All right. So this is partitioner. Now there is one more last topic, combiner. Okay, let's do one more topic quickly, small topic. Move back. So partitioner is basically a load balancer. Let's do one small thing.
Just a quick info, guys. Test your knowledge of big data by answering this question. Which of the following are incorrect big data technology? A. Apache Hadoop. B. Apache Spark. C. Apache Kafka. D. Apache PyTorch. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Now, what comes out of mapper? So what comes out of mapper is India 1, China 1, Malaysia 1 and all that, and we are consolidating China and India. Why can't we do something like this? That we add everything up and we directly send India 22, China 22, Malaysia 6, Singapore 6, Thailand 6, let's say. And here itself we consolidate India to be 8, China 8, we know India, Malaysia 14, Singapore 6, and Thailand 4, Singapore 4. Now, instead of China and India like this, with combiner, we will get China 22,8, India 22,8, and here we'll get Malaysia to be 6,4, sorry, 6,14, 6,4, 6,4, and we get the consolidation. This is done by one guy sitting before the partitioner called as combiner. So that is combiner and partitioner. So that is combiner and partitioner. So now this kind of consolidates the entire map reduce for us. We understand map, that is one record at a time. Then we understand partitioner, which is load balancer. But before load balancing, if we want to combine something, we can run a combiner, and then we do the reduce part. Okay. So let's understand, guys, carefully. As a programmer, how do I predict my number of reducers? Now, actually, there are no royal ways, but there will be a couple of tips out here. So let's understand. Okay. And in 30 seconds, I'll put the answer and check if your answer is confirming. Answer should be 12 reducers. Why you should go for 12 reducers? Because here your use case is very clearly telling you that, listen, for Bank of America 2016, I want monthly revenue where I would like to have 12 output files, each file having 1 month's data. That means your use case is very, very clearly telling you how many reducers are required. In a year, you cannot have 13 months at all. That's not possible. So for most use cases, this is what will be the pattern. Now some cases when we don't know, like say word count, there is no classification. Well, then it's trial and error. Okay. So, and here knowledge of data will also be required. There is absolutely no magic on this one. It's trial, error, and Okay, so that's the answer. Unfortunately, if your use case does not tell you what is required, then you are in trouble. Not trouble, but yeah, you'll have to do trial and error, and there is no royal way for it, because that will also need a lot of understanding of your data. Okay, okay, what kind of data it is, probably what kind of bifurcation we are looking at. You'll have to do multiple runs to really settle down on a number that looks good for you, and there is no other way, because if your nature of the data changes, you are back to square one. But that's how it is going to be. So for example, in one of the places, right, what we really do is, let's say we do number of reducers to be 72. Now we just add, okay, this is the amount of RAM we have, and did some calculations that this is the RAM we have. Probably each reducer will take 1 GB RAM. Based on that, we choose, okay, let's have 144 GB RAM is there. Let's have 72 reducers for all the jobs where we don't know what it is. But that's always going to be changing. So there is no one royal way where I can say, no, this is how it has to be. But when your use case is perfect, like it clearly tells you, your manager comes and says, listen, I want monthly revenue of BOA for 2016. And even if he tells you that, you kind of know that, okay, man, I can bifurcate by month and maybe have 12 reducers. That's the idea. Okay. Okay, guys. So now here we come to map reduce, and let's understand this. So this is, okay, guys. So this is like the final diagram of the day. So let's take up this diagram, and this will complete our map reduce explanation. Okay, guys. So first, I submit my job data, which is 640 MB. That means there are 5 blocks. When I submit my job, automatically my number of mappers, because the blocks are 5, will typically be 5, and I can specify number of reducers. And let's say the number of reducers is, let's say it is 2. It is 2. So I submit my job. Number of mappers will be 5 because the blocks are 5, and number of reducer as a developer, I said I want 2. When I submit this job, AppMaster starts the job, and AppMaster tells so number of mappers is 5 and number of reducers is 2. When I submit my job, the AppMaster tells the Yarn master that, listen, I will first start with the map phase, so please give me pi resources, 5 resources. And now I am replacing this word resources with containers. It's called containers. So AppMaster says, hello, I will first do mapper phase, give me 5 containers. Resource manager says, go take them, man, take 5, go enjoy. Now after the map phase is completing, the AppMaster will go and say, hello, I need 2 containers for reducers, and you can give me on any machine, because anyways there'll be some traffic. So resource manager says, of course, take your container for reducer. So let's say one reducer will run here, other will run here. And after map is done, all the data is coming from all the machines. This is shuffle phase. And now the reducer will run, and it will generate 2 output files. Output 1, output 2, which you can merge later. So now let's first understand how these labs are set up, how we will practice everything, and then we will basically go through the whole walkthrough. So let's jump onto it right now. Now before we jump into any of the labs, let's first understand the setup. Now I'm sure most of you will at base have a Windows laptop or a MacBook. Okay. Most of you will have. Okay. From your LMS, so Intellipaat's learning management system, you will download something called as a virtual machine. So now what happens is, there is this virtual machine which will run on top of your Windows operating system, and this is running an OS called as CentOS. Okay, so that's where CentOS is running. When you say Hadoop is already installed, following services are already running on your virtual machine. So even without, let's say, in case you've not gone deep into it, but these are 5 services which are already running on your machine. So the first service is running as name node, then you have data node, then you have secondary name node, then you have resource manager, then you have node manager, and then you have job history server. These are the 6 services that are running on your virtual machine. Okay, now your setup is done. Windows, Mac, CentOS, Hadoop is installed, life is good. Then you came for a theory. We did so much theory. Now it's time to practice 2 things. First thing is, we should practice some HDFS commands. Okay, and second thing we will practice.
Just a quick info, guys. Intellipaat provides online big data Hadoop training in partnership with IBM. The course link of which is given in the description below. Now, let's continue with the session.
Is MapReduce commands or MapReduce programs. So when you leave for the day today, you would be very clear that, oh, I have a virtual machine and Hadoop is properly installed. Yes, that was done. And today you practiced, or basically you would see how to do it, HDFS and MapReduce. And then you can basically take your time to do that as an assignment. My Linux box, that CentOS Hadoop that you've got, it actually has 2 file systems. CentOS will have something called as Unix file system, and Hadoop will have a file system called as HDFS. So hope everybody is clear that Unix is different file system, HDFS is different file system. Today when we practice HDFS, we will be dealing with Hadoop file system. Okay, so this is the setup. This slide will be important to you. I'm sure everybody knows what is name node, but I'm just reiterating this so that this slide stays with you. Name node is master for storage. Data node is slave for storage. Secondary is backup of name node. So this we've covered in detail. Okay. Resource manager is master for yarn. Okay. Node manager, he is slave for yarn. But now there is a problem. Problem is, let's go to this diagram. That yarn, that is resource manager, has to maintain multiple frameworks like MapReduce, Spark, and so on and so forth. That's why resource manager says, I will maintain your job only till it is running. After the job is done, forget about it. Find a way to archive the status of the job. What I'm saying is, oh, you ran a job on Friday, today is Saturday. You want to see how much time that job took. Resource manager says, listen, it's not my job to archive that information. Okay, because I, as a resource manager, has to handle MapReduce, Spark, and so many other things. So for archiving the MapReduce job status, okay, there is this service called as, the name itself is very self-explanatory, job history server. Okay, think of it this way. It is status archival for MapReduce job. What I'm trying to say is, as soon as your MapReduce job is done, resource manager says, okay, bye-bye, I got your output, see you, and I'll forget the status. And that gets archived in job history server. So it's like an archival service. Think of it that way. Okay, dude, how do I believe a trainer that services are working or not? I should be able to see it in real world also, right? What services are running or not. Well, there is an interesting utility, and I will paste the command because it's an interesting thing. So there's a short command called as JPS, Java process status. It will tell you all the Java processes that are running in your cluster. Okay. So this is my cluster. And yes, trainer says Hadoop is installed, but how do I verify that? Let's do that with that particular command. It's an interesting command. So the command is sudo user java latest bin JPS. So basically we are running a command called JPS. JPS full form is Java process status. This is our way of questioning. Listen, Mr. Cluster, can you tell me which Java processes are running? So our cluster is kind enough to say that, oh yes, name node is running, oh yes, data node is running, oh yes, secondary name node is running, oh yes, resource manager is running, node manager is running, and the job history server is running. Okay, and I will paste this command in Evernote. Okay, so won't be able to paste, so I'll just type it. Sudo user java latest bin JPS. And by the way, this command is not married to Hadoop. This command is married to Java. That means on your server, if any other Java process is running, I mean, take an example. Okay, let's give an example. Let's say on your laptop, in that cluster, let's say Lotus Notes is also installed. Lotus Notes is an IBM product which runs on Java. You will see Lotus process is also running. So this command is not married to Hadoop. This is married to Java. Okay, Java process status, JPS. Okay, so that's a command. With that, now let's move on to our thing. So first thing is, our first agenda is, hey dude, I want to practice HDFS. So the first thing trainer keeps on talking about HDFS is that Linux file system and HDFS file system are different. How do you prove that? Okay, let's run a small command. lsltr/, or let's simplify it more, lsltr tmp. So this is my temporary directory, and I see some files, keyring, jetty, virtual training, something, which is fine. Now I'm again running the same command. Okay, in front of you I'm just running the same command, but this time I'm saying Hadoop fs ls tmp. So here I was seeing tmp, here also I'm seeing tmp, but God, the content I see is different. When I see tmp for Hadoop, I see Hadoop yarn, but when I see tmp in Linux file system, I see so many other things. The reason is Linux file system is different, Hadoop file system is different. When you just run a Linux command, this is Linux command, and if you want to run a Hadoop command, you can always run it as Hadoop fs ls or hdfs dfs ls. Okay, so the idea is that this prefix will decide whether it's a Linux command or Hadoop command. This prefix will decide whether it's a Linux command and Hadoop command. So first thing is amazingly verified that yes boss, this thing is clear that they are two different file systems. How did I verify? On Linux I'm saying temp, I see something else, and when I say Hadoop fs ls temp, I am seeing something else. That means they are two different file systems. So that's good. So our hands-on has to be done on what do you call HDFS. Now the common pattern for Hadoop commands is Hadoop fs hyphen your Linux command. So most Linux commands will work like that. Hadoop fs hyphen and put the Linux command. Okay, so if Hadoop fs is not there, this is Linux command. If Hadoop fs is there, this is HDFS command. Okay, now there is one exception to this rule, and that is that we cannot do VI, that is, we cannot edit a file in Hadoop. In Hadoop file system, once you write the data, the file cannot be updated. It's more like from a warehousing perspective, they never let you update. I mean, warehouses do let you update data, that's fine. But Hadoop file system will not let you update the data, will not let you update the data. So Hadoop is also called as worm. Write once, read many. Hadoop is worm. Write once, read many. That's simple as that. Okay. The second variation to this is, in Linux, there is an amazing command called as cd. So I can say my pwd and I can say, let's say, cd workspace. And when I do my pwd, my present working directory changes. But my friends, in Hadoop, there is no cd command. That means, let's look at a simple example. I say Hadoop fs ls temp. Now I am tempted to say that Hadoop fs cd temp Hadoop yarn, and the cd command is not there. That means you are always supposed to give the full path, and your present working directory is always, carefully look at it. If I say Hadoop fsls, it's showing my present working directory, and that is nothing but same as user training. Aggregation, output, input, same thing, aggregation, output, input. So what I'm trying to say about HDFS is very important. Let me note it down for you here. For most part, HDFS commands are very close to Linux commands. So there is no special practice required for you. When we run MapReduce program, you will end up practicing them. Okay. So if I just say Linux command, this runs on Unix file system. And if I say Hadoop fs Linux command, this will run on HDFS. So we are clear with this. Now, two important points for HDFS before we move to this thing. Two important points. You cannot update a file in HDFS. That is, HDFS is worm. Remember this word because this will save you a lot of trouble. Read many. Second, there is no cd command. You will always be at user, that is, in this case it's training, and for everything else please use the full path. So that brings us to the end of HDFS. Now you can just play with this. So let's quickly play with a couple of this. Hadoop fs mkdir. Okay. So I'm creating a new directory called as Apple. So what I see is Hadoop fs ls. I see a new directory called as Apple. Now Apple is a directory created in Hadoop file system. How do I put some data into it? Let's take a simple example. So in my Linux file system, I have a file called as, let's say, test.txt. So I'll say Hadoop fs put test.txt in Apple in HDFS. Wow, it goes. How do we see it? Hadoop fs ls, and we see a file text.txt. So two major commands to remember. One is put, okay, and other is get. Now if I want to get this test.txt dot outside, then I should use command called get. So get and put are two major commands. I can delete this file also. Hadoop fs rm-r apple/test.txt. Okay. So these are some of the commands. Now you will have lot of practice on it. See, by the time you complete this whole training, you will be a champion at these commands, because every hands-on that you do, you will have to use these commands. Okay. So that kind of brings us to the end of explanation of HDFS and how to play with it. We move to our next important topic, which is MapReduce. In our hands-on, we are going to look at a couple of things. So how to write a basic program and how to run it, how to basically, let's say, aggregate data, how to perform some kind of joins, and so on, so forth, so on, so forth. Now, before that, let's kind of understand the architecture of how you deploy them, so that we are very, very clear with this. So pay attention. Yeah. So let's go ahead and do everything. Okay. So that the flow remains. So let's first talk of the same diagram here. Oh, I have Mac. Okay. I have CentOS. It has Unix file system. I have Hadoop file system. We already saw HDFS commands. Now it's time to run MapReduce. So let's first understand the deployment architecture. So on my CentOS, I will write this great code which is called MapReduce code. And oh, that code is written in Java. So I have code that. Good. When I submit this code, okay, it will get registered with the resource manager. So I'll be able to see on resource manager that. So leave the code part. Let's first understand the deployment. You write code on your CentOS machine. Write it. After you write it, when you submit, it goes to resource manager. Resource manager internally will call app master and say, okay, boss, do the job. App master will do the job. And after the job is done, the job will be archived at job history server. So don't worry about code. Don't worry about MapReduce program. First, let's worry about the deployment part so that we are clear with what is the flow. Writing code is easier part. Understanding the flow is pretty important. So without worrying about what I'm doing, let's submit one MapReduce program first. We will understand the deployment architecture. So we'll go step by step. Right now, you have to look at from a perspective that how will it get deployed on the cluster. Okay. So first, in HDFS, I have created a directory called word count input. I will first delete it in front of you. HDFS DFS ls or Hadoop FSLS, whatever you want to run. So there is a folder called input and there is a folder called output and Apple and aggregation and aggregation out. I will delete everything in front of you so that we are very, very clear. HDFS DFS rm-r user training star. So please delete everything that is there. So it has deleted. So right now my user training directory is completely empty. And now look at it from a perspective of how it is deploying on the cluster. Don't worry about the code. We have whole day to look at the code and that's an easy part. Okay. So let's first create some sample data. So I'll say vi, okay, Intellipaat.txt.
Just a quick info, guys. Check your knowledge of Hadoop by answering this question. Which of the following are the core components of a Hadoop? A. HDFS, B. MapReduce, C. HBase, D. Both A and B. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
I'll say Intellipaat is one of the very first companies who got into big data. So I've actually created multiple lines, okay, who got into big data. So they have a big data COE. They are good at big data. They are very good at big data. Let's just say I'm putting something. The idea is that just mark your words that I have used big and data 4 times. So that means big is 4 times and data is 4 times, okay? Because we will run some kind of word count job. So this is my input data. You are free to put whatever you want. So this is in my Linux box. I want to put that into my Hadoop. So first what I'll do is hdfs dfs mkdir, and I will create a folder which will be called as input. So I'm creating a folder called as input. Life is good. Then I say hdfs dfs. You can use hdfs dfs or Hadoop fs. Don't worry about it. It's the same command only. Okay. So call it biscuits or cookies. They are same only. Okay. So hdfs dfs put Intellipaat.txt in my input directory. So life is good. hdfs dfs ls input. So what I see is a file called as Intellipaat.txt. Okay. So now input is there. It's time to just run a code. So this is some ready-made code, word count.jar. I have written it for you. It's ready. Just leave it. It's fine. Right now we are not interested in how to write code. Hadoop jar word count.jar. The input folder I created is input, and the output that I will get is output. But right now my perspective is how does it get deployed on cluster. So we will see both of it. First, I will go to localhost and I will go to 8088. So this is my resource manager UI. Right now I have not submitted any job. This is simple. And this is my job history server. Okay. So let's just say, so this is my job history server. Okay, it's connecting. It's fine, it'll come up. Okay. So right now my job history server, this was my previous runs which are there. This is 0 applications. Resource manager has no applications. Now pay attention. I'm saying Hadoop jar word count.jar input output, and I say bang. Once I say bang, you see the job has got submitted and it has got accepted. We don't know the status because resource manager has just got it. Click on that and you see the job is still running. It is not complete. It is running. Let it run. It's doing something. We are seeing that. Let it run. But pay attention to the screen right now. Okay, there is a tracking URL which is application master. 24 seconds. Job is running. It is doing word count. That's easy. But look at it. The tracking URL changed to what? History. And it takes you to the job history server. It is taking you to the job history server. You can actually refresh it from here itself, and you will see that the job will get registered here. So the job was submitted, it ran successfully, and it will appear in the history. Okay, so this is the job that I ran in front of you. Now this job, okay, this is where I will see the time and everything. So this job ran, it would run certain mappers, certain reducers. This job ran one mapper, one reducer. I can see the logs for mapper and I can see logs for reducer. Okay, so now just to understand the flow, we will first reiterate the diagram again. So this is my task. I can see my logs and everything in that. So the UI is there, click on logs and you will see logs. And that's how you understand the flow of how the job is getting submitted. We will come to the code. It's important to understand the flow. So my job has run successfully. I say hdfs dfs ls. I see output directory. Life is good. Within output, I see two files, success and part r00. You know why success is required? Success is a 0 byte file, which is a flag. See, in enterprise, you use tools like Control M, Autosys, or your own automation. If you're using an automated tool, how will automated tool come to know whether this job was successful or not? It looks for a file called as success. So this is like a flag, whether this job was successful or not. And this part R00 is your output file. So there was one reducer, so it came up with one file. HDFS, DFS, cat. And I say paste. And carefully look at it. Data is 4 times and big is 4 times. So that's my output. So I have successfully run my job. Yes, we have not got into the code. We have time for that. Right now, it's important to understand the logic of deployment. I wrote my MapReduce code. It was bundled as a jar file. So for guys who are not, from Java background, just to give you information, jar file is nothing but think of it like an exe file for Java. Just think of it that way. This jar file was submitted to resource manager, and resource manager showed you on a URL which was port 8088, and resource manager tells you, hey boss, yes, job is submitted and I'm running it. It's running, it's fine. After the job is done, resource manager says my job is over, and the job history server has the status. That is how your flow will work. So you code, you deploy, and you see the status. You see the status. That's how it works. Okay. Now it's time. Now the next question that will be asked is, hey man, how do I write my code, and how do I bundle my code? So two questions now which are pending to be answered now is, how do I write my code? That's the next question we'll take up. And how do I bundle my code? Simple stuff. So these are two important questions to be answered. Once we answer these two, we will see some more programs on MapReduce. That will be the agenda. So now I'm going to talk about a problem as to how do I write my code and how do I bundle my code. Think of MapReduce program as three different Java classes. So I'll map this in the code, okay? So the first class, the main class, is called as driver. So that's your ignition point. Think of it like the place where in the car you insert the key. That's where you drive the whole engine. The second file is mapper, that talks about what should be done with each record. And then there is third file, which is reducer, which says what should be done with each group or bucket. So for example, the student's example, what should be done with each student, and here what should be done with China, let's say 11111, the whole bucket. So the driver you initialize, driver will call the mapper will write its output, automatically framework will take care of shuffle and sort, then the driver will call the reducer and you will get your output. So as a developer, you are supposed to code three things. You will code the driver, you will code the mapper, and you will code the reducer. How shuffle sort works, that's something you will not code, because that's what framework will take care. It is as simple as that. Now if you have this diagram in mind, I will map this to the code. And it is that simple. Every MapReduce program, my friends, that you use will have these three classes: mapper, reducer, and driver. So don't worry about it. It is dead simple. You just have to relax out. There are three things to know. What should I put in driver? In driver, you will put a very simple thing. Oh, who's my mapper? Who's my reducer? What is the input data format, output data format? In mapper, you will write the logic saying what should I do with one record at a time. And in reducer, you will write the logic which will say what you should do with one group at a time. Okay. Now, if this is the logic, there you will see a lot of things in the code right now. With that, today what we will do is I will show you 4 code samples. How many code samples? 4 MapReduce programs. In every MapReduce program, you'll have a driver, you'll have a mapper, and you'll have a reducer. Now you can also have advanced things like chaining, where you say that driver can have 2 different mappers, and then they will call the reducer. All these complex workflows are possible. Okay, so it's like you can go on making it more and more complicated. But the good practice is keep it simple by having multiple MapReduce programs and call them as a workflow. So what I'm trying to say is, can I code like mapper, 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 then reducer, then let's say one more reducer, for example? Yes, you can. But a good practice will be MapReduce, 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 and then chain them as a workflow. That will make your code very, very maintainable. Okay. So let's today we will look at 4 examples. So now we've understood how this works. We will now jump into the code. First thing we'll talk about is how to write a word count program. Okay, what we just did now. We will look at one more example, which is how to aggregate. Same thing, like word count is aggregation, this is also aggregation. We will then see how to do joins. So there'll be 2 type of joins we will see: joins in mapper and joins in reducer. These are the 4 code samples we will see. So let's go ahead and do that. Now it's time to basically look at one piece of code. Okay. So on LMS, let's say everything is available, you can download. Now just help me out. From LMS at download, there are, what you call Hadoop code files. So there is writing MapReduce program, multiple input format, joining, how to aggregate data. These are some of the files. So I get word count, and my code is in source. That's Java code. Let's talk of code. I open in gedit, and the first thing you say is, no man, how will I in real world write it in Notepad? So you should not. You should actually use a tool called as Eclipse. So why don't we directly look at it in Eclipse? All you need to do is open your what you call this thing. So let's start from a fresh slate. So I open Eclipse. Eclipse is saying me that, Mr. Ravi, I will look for your code. In home training workspace. So you better have your code there, because that's where I'll point to. I go to my home training and workspace, and I realize that there is nothing. There is some file called intellipaat.txt. Let's get away from that also. So Eclipse is saying that, dude, I am expecting your code or new projects will be created at workspace. And in the background, I see workspace is completely empty. So we are starting with 0. Okay. I go to workspace. Okay. So how do I create a project right now? So one way is I can directly create a project from here, and I can, build a file. I can do that also. Or I can take this project that we've got, okay, and take this word count project. So I'm just taking this and putting it inside workspace. Okay, so there are some additional files, ignore them right now. Okay, and I will simply say that I would want to create a new Java project. It says, where is the code? I'll say word count, and this guy says, yes, I realize there is word count. When I say finish, okay, so there are some files I see, but God, there are some errors also. So here you go. This is trainer's code. Looks to be pretty good. Problem is that there are so many errors. What do you do right now? The errors are because you have never got the libraries. So it's time to get the libraries. So let's look at it. There are good amount of errors, let's say 48. Let's bring the library one by one. So we say Java build path, add external jars, user lib Hadoop, and get all the Hadoop libraries. Once you come in, some errors will reduce. So there are actually less errors right now. Now we need to get libraries from MapReduce also. Add external jars, lib, MapReduce. Perfect. So some errors are less. Let's see what is the error that is still there. There is something called generic options parser that appears to be a pain. Now let's see what you are supposed to do. First thing, you've got MapReduce, but you are supposed to deploy your code on Yarn. So you should also have the Yarn libraries, and you should also have Hadoop lib in these libraries. So I've created all the libraries, and so good, all errors are gone. We are happy, pretty happy. Errors are gone. So let's say code is given to you. We've not got into code, but you imported the library and it is code free, right? It's like error free right now. So let's say export. So I'm showing you how to bundle it now. First, we'll jump into code later. I say jar, and I'll say put it in home training word count.jar. I say finish. It says there are some issues. I'll say okay, ignore them. So I see this jar called as word count.jar. This is just now created by me. This is just now created by me. Let's run this. Hadoop jar word count.jar. Now my package is com.hadoop.wordCount. com.hadoop.wordCount. Okay. I am running it with input data, and I'm running with a new folder called as, or let's run with output, but we should clear the output. So hdfs dfs ls. I will delete the output folder. hdfs dfs rm-r output. So I've deleted output. So let's run this job. It says it was expecting output folder. I said no problem, take it. So the job has got submitted. So once this job succeeds, you know how to see output. And we'll pause for a minute to document the steps for you so that you see that this pointers will be there for you to see. Okay. So let's first talk about how to create the code. So first one, take the code from LMS, unzip it, take the word count folder and put it in workspace. Open Eclipse. So good. Say new Java project. Include libraries from user lib Hadoop, user lib Hadoop lib Hadoop MapReduce Hadoop. Yeah. export the code as jar file, run the jar file, bang, you are done. Okay. So how to create a code? This is option 1. This is option 1. There is other way also, we'll see that. We will see that. So then this is your option 1. Okay. Now option 2. Option 2. So this is called using Eclipse. So using Eclipse. Option 2 is using a build tool called Ant. Let's see what do we mean with that. Let's see what do we mean with that. Okay, so we will do this and then we will jump into the code. So we'll pause for questions and then we'll jump into the code. Now I don't want to use Eclipse. No, I'm not comfortable with that. I am a guy who's, let's say, very comfortable with build tools. So don't worry, Intellipaat has already taken care of that. In the word count folder, okay, this code is ready. I'm supposed to build a jar file, but jar is already there. Let's remove, we'll see it. So you use a tool called as Ant. Ant is a tool that will create a jar file based on the steps. So let's look at it. It will be simple. Okay. Just to prove that I am doing it differently, I will do completely different setup here. So let's look at it carefully. I'm saying mkdir America. This directory is nowhere I have created in front of you. Then I say cp Hadoop code files, write in MapReduce program, word count. I want to copy this entire folder in America folder. So I'm not using Eclipse anymore, okay? I'm copying it in America. It's done. Look at it. lsltr America. You see a folder called as word count. Now I say cd America lsltr word count. What man, this jar file is already ready for me. So I will delete this jar file in front of you. I'll say rm-r word count of jar. So now you see there is no jar file. So Ant is a utility that you install and just go to word count folder and run this command Ant. And Ant has successfully built a jar file for me. So this was like from the command line. Now what I do is, it is simple. I'll say I want to run this word count.jar. I am directly running word count.jar, which we created right now. But instead of output, I'll give another folder and okay, so output came just to prove hdfs dfs ls. I'll see how it's going. So let's document. If you want to use a build tool, first in your VM, just run a command. First, install Ant. Use a command sudo yum install Ant. Copy word count folder from the LMS code files to say a new location of your choice. We did it in America. Now there, just do cd word count and delete existing jar, run ant command, bang, your jar is ready. Run your code. Now Eclipse is very easy, it's all automated. But now the question would be that, can I have this ant based stuffs? I have already given you all the steps, but if you want more details, each program has a README file for deployment. So if you go to this Hadoop code files in word count, there is a proper readme.txt that will tell you how to do it. Make sure your folder paths are correct. That is something you can take care of. This explains you the logic of the program, and at the very end it tells you how to run it also. It tells you that exact steps also. Okay, so this is readme. If you're doing from Eclipse, that is easy, just import a project that you don't need a documentation. But if you're doing it from the background, this is what you should be doing. So I've documented both the steps. So at least one thing is clear.
Just a quick info, guys. Intellipaat provides online big data Hadoop training in partnership with IBM. The course link of which is given in the description below. Now, let's continue with the session.
At this moment, we are clear with how code gets submitted, how code gets bundled from Eclipse as well as from command line using ant, how to code MapReduce. And now it's time to talk about how do you code it. Now when it comes to how to code it, every MapReduce program will have three files: driver, mapper, and reducer. Okay. So here we go, and that's where we have our word count program. And as said, we have one word count.java, but there'll be three classes in that. So let's first see all three classes before we jump. So this is my reducer class. I guess in case you're not able to see, let me increase the font size. Preferences. So we go for editors, text editors, colors and fonts, edit, and let's go for a bigger font, 14.
Just a quick info, guys. Test your knowledge of big data by answering this question. Which of the following are incorrect big data technology? A. Apache Hadoop. B. Apache Spark. C. Apache Kafka. D. Apache PyTorch. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So this is bigger. So this is my word count, which is my driver class. This is some reducer, which is my reducer class. And this tokenizer mapper is my mapper. So in this you find three Java classes. Okay. So word count happens to be my driver class. Within that I have a mapper, and within that I have a reducer. So we are clear. Let's see how does it go. So the first thing that happens is it goes to main. That's where Java code starts. That's where Java code starts. Now the first thing we are calling is, we are saying that read the configuration. Okay, that means where is the name, node, and all that. So if you recall today morning, today first thing we saw is that etc hadoop conf folder. So this basically is reading that particular configuration folder, and it is also checking if there are any other arguments that we've got from the user, some customization that user has given, for example. Okay. All right, so read the configuration and see if there are some other configurations like input path, output path, and all that stuff. Okay. Now, what we're looking at if the arguments given by the user, if they are not equal to 2, then job should fail. That means we are expecting the user to give us input path and output path, and if we don't get it, I would request it to fail. Let's look at it here. So I'm running this job and I don't give output. It clearly says the usage is word count in and out. So that's exactly what it says. So then it starts the job class. Job is basically now reading the configuration and applying it. And here we are saying that my mapper class is mapper. My combiner is going to be the reducer class only, and then there is a reducer class. So we are calling our combiner. Set jar by class is basically saying that this is our main class. So the jar file should basically look for this particular main class. So here we are good. So we've informed our framework that these are the classes that will be called. Now let's talk about the output format. Now we are saying that what we are saying is, so first here we are specifying that input path and output path is specified. We are saying that both mapper and reducer, their output is text comma integer. Let's carefully understand. So we were looking at the output folder, right? hdfs cat output slash part r00000. So this is text comma integer. So we are saying that our mapper output is word comma 1 and our reducer output is also word comma integer. So we are saying our output key class is text and our output value class is int writable. Int writable is nothing but integer which is serializable. So there is a class for that. And once we've set all that, we are submitting the job. So if you see, our driver class has no business logic. It just knows what is mapper, what is reducer, and it simply calls it. It just knows mapper and reducer and it simply calls it. So far we've not done anything with the business logic. Business logic will come later. So my driver is ready. And yes, we agree that driver is not business logic. It is just setting expectation. Oh, this is my mapper, this is my reducer, this is my input type, this is my output type, blah, blah, blah. Now let's go to the mapper. Now mapper is our smart guy who will work on one record at a time. When I say one record at a time, what do I mean? Let's talk of that. When I say one record at a time, it is hdfs dfs cat input Intellipaat.txt. Am I missing something? ls input. Okay, it's got the spelling wrong. Intellipaat dot. Why am I doing ls? I should do cat. So one record means Intellipaat is one of the very first companies who got into big data. Okay, so this map will take one record at a time. That means this is my record, and in the notepad file or text file, this starts with a byte offset 0. Okay, so it says this is an object which is key, and the value is this entire string. Intellipaat was the very first company, or is one of the very first company that got into big data. Now inside, if you see, we are tokenizing this value. That means this string is now tokenized into so it's tokenized as so that first record is broken into bunch of strings. Okay. So Intellipaat is one of the very first companies now broken into this. Now we are iterating it. While the iterator has more tokens, please go to the next token and emit word comma 1. Now what is 1? It is already defined here. 1 is this integer 1. That means the output of mapper will look like Intellipaat comma 1 is comma 1 1 the comma 1 very comma 1 first comma 1. Nice. Now shuffle and sort is part of the framework. We don't really have to code. We just have to code the reducer. So after shuffle and sort, the input might look like big comma 1 1 1 1 because there were 4 sentences and data comma 1 1 1 1. Nice. Now reducer takes one bucket at a time. That means it takes big comma 1 1 1 1. Key is text and iterable on integers. It starts sum from 0. It says 1 plus 1 plus 1 plus 1 and bang, the output is big comma 4. That's my final output, big comma 4. My friends, look at this, hdfs tfs cat output slash part r big comma 4. Why it is 4? Because in my input comma big is 4 times. That's how your word count is coded. Like this, any map reduce code can be coded. Any map reduce code could be coded. That's how it looks like. Okay, that was first what you call code. Like this, there are what you call multiple assignments, and they will more or less follow the same trajectory. So let's proceed and do one more project. We go again. Again, we are interested in looking at the code right now. Okay, so the job will run, readme is there. Let's look at how to aggregate the data. So the project is time diff, and we are interested in looking at the code right now. We know how to run it, so that's fine, and code is working, so that's okay. We need to see the code right now. Let's see what we're doing. So I say cp Hadoop code files, how to aggregate time diff. I will copy this in workspace so that I can show this in Eclipse. That's the idea, right? So I say workspace, life is good. Say programming, Eclipse. So we'll close word count. I'll start a new project, new Java project, time diff, finish. And now you know how to get rid of errors and all, but I'll just do it just to, you know, steer clear of it. Libraries, add external jars. same process which you've already seen. Okay, so now what we are trying to do here. So let's carefully understand this. Again, you want to understand it, very simple. Just go inside and there is a proper readme.txt. So it shows how to run, but the idea is this is my input data where I have some users. I have their start time and end time. I just want to know how much time they spent. Let's carefully look at it. It's a very simple thing, okay? There is a user called Ram. He started at 12 and Ram stopped at 13. So 13 minus 12 Ram is 1. Del started at 12, ended at 14. So we are just doing the same word count thing, but we are just performing another operation. So del is 2 and Maniga is 2. All good. Now let's look at the code. So again, we have our mapper, we have reducer, and we have main class. So same thing, we are setting up everybody just like previous thing. In my mapper, my output is username comma time. Username comma time. So here my output will look like this. My output actually from mapper will look like this. Now if you carefully see, so I'm putting this full-fledged thing so that you get the whole idea. But I'm only writing name, which is key, and the time as value. So I'm not writing start and end. Let's say I'm not interested in it right now. That's why I've said I want to only emit user comma time. I'm not interested in start and stop. That's how I code it, simple as that. Nothing like I can push it. It's Java, but I'm just pushing username comma this. Now to reducer, the input, there'll be 3 buckets. First one will be this, which may look like 10 comma 12 or 12 comma 10, doesn't really matter. For second one, it will look like del 12 comma 14, and for third it will look like Ram 13 comma 12, doesn't really matter. Here we are saying that take any first value as whatever you get and the other value as start. So first will be start, second will be stop, and finally we are just subtracting by doing abstract. So my output will be, I'm using the absolute value, my output will be minus an absolute value, so my output is 2, 2, so that's how you write your map reduce code. Map reduce, divide conquer, performing a join. Let's say here, this actually is a classical example of we are kind of performing a join. Okay. So I say cp-r Hadoop code files, multiple input formats, multiple to workspace. Okay, so it's multiple input. We go to Eclipse. So this is slightly strange and slightly interesting because, so we'll ignore the errors. You know how to fix them. Here what we are doing is, there are multiple mappers. There is one mapper that reads customer details, and there is another one which is reading delivery status. So there are two mappers in it, and there is one reducer in it. Okay. So here what we do is, I say multiple inputs for this particular input path, call customer detail mapper. For this input path, called delivery status mapper. So first two mapper will run, one for one file, other for other file, and then you call the reducer where you are performing a join. So let's pay attention to it. From customer side, I am writing cell number, comma, let's say customer name. From delivery side, again I am writing cell, comma, delivery code. And here, based on cell, I am giving away customer name and delivery report. So this is a classic join. Let me draw this for you. So the flow looks like mapper, mapper, and let's say reducer. So this mapper, he reads customer data, and this mapper reads delivery data. So this is complicated in terms of, you can always have multiple mappers like that. Now this guy emits, let's say, customer ID, comma, some details, and this guy also emits CID, comma, some details. What we get here is CID, comma, details 1, comma, details 2, and here we can emit details 1, comma, details 2. So this is how you will perform a join. Let's look at the readme part. This will give you complete idea. So like this, you will always have what you call more and more examples on internet. You can find thousands of them. So I have customer data, which is this, and I have mobile status, which is this. Now what we do is, one mapper will extract ID and name, second will get this, and finally I am getting the status as a join, which is customer and does he have a phone or not, let's just say. Okay. So like this, we've seen the basic constructs of MapReduce and everything that is around it. We've gone through the real code. The use case that I showed was actually doing a join. Now for join, you've got to have the key, which is same. So let's understand what we are trying to say. There are two ways to achieve it. Two ways to achieve this separate data. So let's say first is a easier case. I have a file from what you call RDBMS that came as CSV, which had, let's say, user ID and let's say XYZ info. Another file I got from JSON, the JSON structure will have user ID and again ABC. So of course, one way to tackle is my mapper will be called here. My mapper will be called here. Okay. And it will emit the same key, and then you go to the reducer. Now, this will work only if you have the key. So formats are different, but they still have a key. Now, if you have completely separate data sets, you'll have to still find a way to get a key that is for you to get it. But let's take a simple example. Okay. I'm doing some XYZ analysis on cameras. I'm doing XYZ analysis on cameras. Now for those, you know what you call, then I have some images. Okay. And in that images, I have quality of images. Let's say there is a way I calculate quality. So I have cameras, their specifics, images, and let's say their pricing information. Let's say my use case says that finally I want to know which is best camera at every quality point. So now this use case is pretty much very much like ETL, right? So I get my data into Hadoop. This is my E. This is my E. Then I may have to write separate MapReduce code to get what I want and maybe dump a key inside. So I may have to manufacture a key inside. So this will be a separate T, separate T, separate T, which is completely independent. But when I write a T, I have to somehow make sure that now I get the key right. And then I'll have to perform the final join and then do a L. So the point is, the example that I showed, keys were ready-made there, but sometimes you don't get keys ready-made. That's where you require developers who will do E. Your process of T is to make sure that data has the same key. Just like a normal traditional BI, you have dimensions and facts, you're wiring them up. It will be a tedious effort because let's say formats are like, for example, here you actually got images. In this case, T, you are extracting information from an image, analyzing it, and then basically wiring it together. So sometimes this will work where the key is ready-made and you directly do this. And sometimes you'll have to write independent jobs and eventually wire them together to get what you want. Are we clear with that? But yeah, eventually your job is to get the keys together, otherwise you'll not get your output. That's how your ETL facts and dimensions is what you create, right? That's exactly that way. Hadoop ecosystem. So let's start. So let's take a small example just to drive the whole thing. So let's say you have wrong design, but let's just say this is iPhone. This is iPhone. So sorry for the drawing, but well, let's just say this is iPhone. Okay, so we've got iPhone. When you say iPhone, what does iPhone really mean? What does Apple give you? It gives you the hardware, plus it gives you iOS, that's the software. Now this is basically your phone. Let's just say that this is your core phone. Along with that, now this is what you get when you buy a phone, but there are few other things that are related to iPhone, but that are not part of your core phone. One of course is apps. So you buy them, you install them, that's your wish, but that you don't get directly with your phone. accessories. So let's just say screen guard, cover, and stuff like that. And let's say there are some services like, uh, think of it like Spotify, music services, and so on and so forth. So these three things are not part of core Hadoop or core, what you call iPhone, but they are kind of ecosystem. Okay. Now, very similarly, when you say core Hadoop, what you get is HDFS, yarn, and MapReduce. So let's say you call up your friend and say, hey man, I have installed core Hadoop. That means you have HDFS, yarn, and MapReduce. And we've kind of covered that in a lot of detail. But my friends, that's not all. That is not all. Why that is not all? Well, just like a phone, there is a supporting ecosystem. You have bunch of applications that are there to solve some problems and add to this, and that is called Hadoop ecosystem. So let's just say that what apps are to iPhone or any phone, ecosystem projects are to Hadoop. Okay, so let's proceed with this right now. Very similarly, Hadoop has ecosystem apps. Let's see some of the apps. If I want to get data from RDBMS to Hadoop, the ecosystem project that is there, or the app that I should be installing, is called as Scoop. If I want to get data from real-time logs, the ecosystem app is Flow. If I want to, so this is my ingestion tool. If I want to process or transform this data and process, I have Hive and I have Pig. Just like Hive, there is another what you call processing layer or SQL engine query called as Impala. Then there is other processing framework called as Spark. Okay, so whatever is in black, it's an ecosystem project. So my point is, my friends, when I say I have installed core Hadoop, that means I have only installed HDFS, MapReduce, and yarn. Everything else has to be installed by me. Okay, so these are some apps. Everything that you see in black is ecosystem projects. Now, after our core Hadoop is done, today's agenda is just to discuss all or introduction to all these ecosystem projects. That's the real idea. Okay, so let's proceed now.
Just a quick info, guys. Check your knowledge of Hadoop by answering this question. Which of the following are the core components of a Hadoop? A. HDFS, B. MapReduce, C. HBase, D. Both A and B. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So here is the idea. Intensity will start when you go deep into each and every ecosystem project. So, okay, Hadoop has ecosystem projects. Can you list down some of them? Well, I'm going to list down most of them. But before I do that, note to you. So this is a small note from my side to you. Every app on your phone has a specific purpose. Like I cannot book my movie tickets from Facebook. I cannot book, let's say, my restaurant table from Uber, for example. Okay. So every app has a specific purpose. Very similarly, every ecosystem project has a specific use case. So with that, let's talk about each one of them. So let's talk about most popular. Okay. So first is Scoop, which is RDBMS to Hadoop or Hadoop to RDBMS. Second is Flume, real-time logs to Hadoop. Third is Uzi, which is workflows for Hadoop. Fourth is Pig, kind of PL/SQL on Hadoop. Fifth is Hive, which is SQL on Hadoop. Impala, which is SQL on Hadoop, just that it's faster than Hive, but does not have failover capability. That means even if one slave fails, job will have to be resubmitted. So that's one major difference. Spark, just think of it this way, it's a new framework that is much faster than MapReduce. U, it's Hadoop on browser. Sentry, ACL for Hive tables, that is grant, insert, select kind of layer on Hive tables, and so on. So the list goes on. So the list goes on. You'll have a couple of more here and there, but these are some of them. Now, what we are going to discuss here is the first five: Scoop, Flume, Uzi, Pig, and Hive. U is nothing but a browser-based application, and Sentry, again, nothing's to be covered from the developer perspective because it's just grant, insert, select to user this. So for admins, they need to set up Sentry separately. That's the idea. So Impala is just like Hive. Spark, we'll just touch base upon it, but we'll go fairly deep in the courses ahead. U is Hadoop on browser, and Sentry is basically the ACL layer, access control list layer. So now the next thing we do is, let's understand what we are supposed to do today. So I'm basically building this for you guys. Here we have so let's understand the flow. Let's understand the flow very, very smoothly. First, at the very bottom, guys, you have a Windows machine. On Windows machine, you have CentOS. And yes, there are 6 services that are installed. The services are name node, data node, secondary name node, okay, resource manager, node manager, and job history server. Now what I want is, okay, so we understood that there are 5 ecosystem projects. They have all their purposes, and we've kind of introduced them. We will first on this VM install Scoop. What is Scoop there for? So let me install, let's say, Scoop here. Once I install Scoop on my VM, let's say I have MySQL, let's say. So Scoop will help me get data from RDBMS and dump it into HDFS. So that is our first demonstration today. Okay. So we've seen the ecosystem projects. So Scoop is basically a guy who can, let's say, get data from RDBMS and put it in Hadoop. It is all good. Once my data is in Hadoop, okay, what I'll do is to process that data. Of course, one way to do it is MapReduce. So we will install Hive and we will install Pig, and we will find a way to analyze that data. Today's agenda is to see, oh, there are 5-6 ecosystem projects. How do you really play with them? So the first one is Scoop. I'll get data from MySQL, put it into Hadoop. Perfect. Second is being able to write some queries in Hive and Pig. Okay. So let's start with that. Okay. Now, just to ensure that before we go deep, you should have some things installed on your laptop so that you are ready. Okay. So now I'm going to basically demonstrate the whole thing to you. So our first agenda is, can we take data from MySQL and dump it into Hadoop? Can we take data from MySQL and dump it into Hadoop? Can we then, do some processing some any other data on Pig and let's say Hive? Let's look at that. So the VM is firing up. Okay, we are in here. All right. So let's carefully understand what we are trying to do. Let's talk about the main thing. So our main agenda right now is get data from MySQL and let's say query that in Scoop. Get data in MySQL and query that in Scoop. So first you're supposed to install Scoop. Scoop will get data from RDBMS to Hadoop. Scoop will get data from RDBMS to Hadoop. So let's do that now. First thing, Mr. Trainer, why don't you prove us that MySQL is there? So let's do that. MySQL -u root -p, that's password, and it is root. Oops, it says cannot connect to MySQL. And the error is so very clear. It says I cannot get through MySQL on the socket. Oh, that means MySQL is not running. How do I prove that? Sudo service MySQL D status. And this guy says, boss, MySQL is not even running. So I have not even got to Hadoop. I'm just making sure that RDBMS is up. If you're not comfortable with MySQL in real world, I'm sure you are comfortable with some database, be it SQL Server, be it Oracle, it's fine. So let's start MySQL. To start MySQL, the command is sudo service MySQL D start. Sudo service MySQL D start. Okay. So let me just put this command somewhere for you guys so that
Just a quick info, guys. Intellipaat provides online big data Hadoop training in partnership with IBM. The course link of which is given in the description below. Now, let's continue with the session.
so the first command is start MySQL. Second is, do you have data in MySQL? MySQL hyphen u root hyphen p root. I'm in MySQL. I say show databases. And this guy clearly shows training DB is there, which is amazing. So I'll say use training underscore DB. And I say show tables. So within training DB, there is one database called as user underscore log. Within training DB, there is one database user underscore log. So from our flow perspective, one thing is dead sure that yes, man, MySQL is there and we have verified it. Let me change the color here. Yes, MySQL is there. It is healthy and it has a database called training DB and a table called user log. Second is Scoop installed? The document tells you how to install Scoop, so you don't have to worry. So I have installed Scoop here. When I run, it says try Scoop help for usage. That means Scoop is installed. If it was not installed, I would have got an error command not found, but it is perfectly installed. So now let's play with Scoop. Let's play with Scoop. Let's do some simple stuff. So I'm not importing the data so far. I am just doing some simple stuff. So I'm saying Scoop list databases connect JDBC MySQL localhost training underscore DB username root password root. I am just checking the list of databases. When I run this, Scoop is running and it says yes, there are 4 databases in MySQL: information schema, test, MySQL, and training underscore DB. Oh, let me verify this for you, okay, so that this is clear. MySQL hyphen u root show databases. 4 databases, 4 databases. That means Scoop is good. Next thing I do is I say show me the tables within training DB. Instead of list databases, I'm saying list tables. So it says there is one table user underscore log. So why don't we see it here? Use training underscore DB show tables. It is indeed user underscore log. So looks like everything is good. Can we now import the data? Can we now import the data using Scoop? Before that, let me show you a snapshot here. HDFS DFS LS as of now has 3 folders, and I'm going to delete all of them so that it's very, very clear to you. HDFS DFS LS, it's blank. Oops, sorry. So HDFS DFS LS is completely blank. Let's do our main thing right now. We will use Scoop and we'll say Scoop import connect to this training DB, username, password, and I'll say that the table that I want is user underscore log. Fields should be terminated by by tab. Now Scoop internally will generate a map reduce job, and what I want is I just want it to run one mapper. It's a small setup, so I just want to have, it's a small setup, so all I just want to do is I just want to make one connection to RDBMS. I don't want to make multiple connections. By default, Scoop will make 4 connections. I just want to have one connection. Okay. So I'll say table user underscore log fields terminated by tab. Okay, and -m1, and I say bang, it is running. Let me prove it here. We have nothing in HDFS DFS LS, so it's submitting a map reduce job. So the job is done. Carefully look at it. It got 50,000 records. It got 50,000 records. So let's match everything. I say select count of star from user underscore log 50,000. HDFS DFS LS. Oh, user log is created. Within that, I see one output file, which is, this is the output. But let's carefully understand what I'm trying to do. HDFS DFS cat. I want to count the number of records. So that's WC, so number of lines in a file. WC -L, and it's 50,000. You're free to do a cat to see this 50,000 records, and you are free to do a select star from user underscore log. So we've successfully got our data from MySQL to Hadoop. So that's our demonstration one. Now I'm sure that the feeling would be that probably, oh yeah, this is very basic. Yes, of course, today's idea is to be having it basic, because as I said, today level 1 of course is completing. It is just to introduce you to the whole thing. It's just to introduce you to the whole thing, and you go very, very deep into each one of them. Okay, but that's the general idea of scope. Okay, now with that, now that we've got our data in scoop, I want to write a SQL query on top of it. Okay, so Hive will let you create tables and basically let you perform analysis on it. Okay, so now we will look at how to write SQL queries in Hadoop. But how Hive internally works, we will go very, very deep in the next week. So just stay parked, stay put. Everything that we see, we will have a lot of details on it. The next part of our introduction is Hive. Okay, can we write SQL queries on the same data? Can we write SQL queries on the same data? So what I'm trying to say is HDFS DFS LS, I see user log. Now on user log, at user log, I see this part M000 stuff, which is the file. Now, can I create a table on top of it and write my SQL query? Can I create a table on top of it and write my SQL query? See, what I'm trying to get to is, guys, this is a normal text file. On text file, I cannot say select star. So Hive will let you do that. Right now, the point is, oh, I have got some data and I am unfortunately not good at Java. So I don't know how to write MapReduce code. Can I do some magic so that this file that I got, which is, let's say, 50,000 records, I want to perform some analysis, but I'm very good at SQL. So the tool I will use is Hive. The tool that I will use is Hive. And now we are going to see how will Hive do that. How will Hive do that? Okay. And how is internally this whole thing is working, how this whole setup is there, next week is all for that. And we will go very deep into Hive. Okay. So this is like the setup part that you'll be doing on your VM. Okay. Now, all we need to do is we need to go to Hive. Okay. Wow. So I'm on Hive prompt and I say show tables. Oops, there is only one dummy table. Let's drop that. Sorry. It's drop table dummy. So now when I say show tables, Hive does not show me any tables. Okay. My agenda is that the file that I got from Scoop, can I write a SQL query on that? Right now, that's my agenda. And we will do that right now. Okay. Right now, we will just look at the usage. So think of it this way. I am right now explaining features of a car and how to drive a car. Okay. Right now, just look at, oh, how to drive a car and just enjoy that part. So let's jump. Now what we do is, I run a simple create statement. So what I do is I say in Hive, let me exit, say Hive. Now carefully look at it, guys. I say create table user underscore log, where the first field is country and that happens to be string. The second field is IP address and that happens to be string. Each row is a single record, so we say row format delimited fields terminated by very important tab. The data that we got from Scoop, we only said that the data should be delimited by tab. That's why I have to respect that delimiter in Hive also, that the data that came is tab delimited. Had I made it comma here, I should have been putting a comma here because the data is delimited that way. So now I am saying yes, the data is in, and yes, It is separated by tab and it is very well stored as text file. Wow. So I have created my table. This looks perfect. This looks perfect. So the table is created. I say show tables and I say user log table is there. But I have just created a table. I have not loaded the data. Select star from user underscore log. It says there are 0 records there. So why don't we load the data? So let's load the data. Now for data we are loading exactly the same file that we got using Scoop. I am just loading exactly same file. I am saying load data in path user training user underscore log part m, okay, into table user underscore log. So I'm loading this data. So the data is loaded. Let's run some queries. Select star from user underscore log. This shows the whole thing. Let's get the count by country. Select country comma count of 1. It's as good as count of star from user underscore log group by country. So it submits a MapReduce job in the background. So I don't have to learn Java. It is converted to MapReduce. So the job is running. And this gives you count by country. So this data was country and IP address. You're simply getting country comma the count of the requests. The assignment is about a data that pertains to movies. A data that pertains to movies. So the data is called movie lens. Okay. And here you are supposed to create a table, load the data and perform joins. Now this data is already what you call given to you on LMS. So this is your data ML100K. Just to explain this data,
Just a quick info, guys. Test your knowledge of big data by answering this question. Which of the following are incorrect big data technology? A. Apache Hadoop. B. Apache Spark. C. Apache Kafka. D. Apache PyTorch. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
this ML100K is basically bunch of files which are there. They have different delimiters and all that. So your job is to first create the tables, load them and perform the analysis. So I'm going to run you through the steps and this is your assignment. Okay. Create table u underscore data blah blah blah. Then load it, but this time you're loading it from a local file. So give the correct path wherever you are putting it in. Then you are creating another table called as u underscore log user. Load it. Then you practice joins and whatever is required. So that's your assignment. That's your assignment. Okay. So this was a quick introduction to Hive. We've done introduction to Hive. We've seen how to get data from MySQL to Hadoop. We've seen how to query that, what you call in Hive. So let's see what hands-on document will say for us. So we are done with Hive, okay, on through the week. Now Pig is another way to do things instead of Hive, but Pig is more expressive. It is more like PLSQL, okay. Scoop and Flume is like E, Hive is like L, that's where you load, and transformation will happen in Pig, okay. So you install Pig. Now the way this assignment will work for you is, just to give an example, I have written 6 codes for you. I have written 6 Pig programs for you, and you have an assignment to do the 7th one. You have an assignment to do 7th one, okay. So now there are a couple of programs on Pig. We will directly walk through the code because there is nothing else to explain. Pig is just like gets converted to MapReduce, just that it's more expressive. So I've given you some programs. You are supposed to do one assignment over the weekend. Okay. So let's carefully look at it. So on your what you call e-learning site, you will get this. I extract my Pig programs here. So we've written 6 Pig programs. Okay, they are very, very simple. Let's look at a couple of them. Okay. So let's say we will look at the first one, Pig with schema. Here what we are doing is we are initializing. Let me see if I can find a way to increase the font size. How do I increase font size? Preferences, fonts. Where is the size? More space 10. Okay. 16 would be good. Yeah, nice. Let's go very comfortably and look at it. So I'm saying that I want to have my first, think of it like a variable. Again, we'll go very deep into it in the sessions to come. Today is just a starting. We say weblogs load user training weblogs webstar using Pig storage. It's using a delimiter called as tab. Now in my data, I am specifying that there are, let's say, 18 fields, and I'm kind of declaring them. That my first field is this, second is this, third is this, fourth is this, and then I can perform any operation. In this first example, I'm just taking that data and dumping it on screen. Okay. So this is Pig with schema, where I'm defining a schema and I'm dumping it. Let's say if I want to do something else. Let's say I want to filter it. So I'll use something called Pig with schema and filter. So what I'm going to do is I will load the data, but I will write a code which says career visitors filter weblogs by URI is equal to careers, and then dump it on screen. So I can either call it as dump and store. All you need to look at is that a Hive is more like SQL and this is more like PLSQL, or more expressive. This is very close to what scripting would look like. Okay, so I can filter. I can also do a group by. So I'm saying group by something and generate the count. So basically Pig is more like PLSQL, and we will have good 6 hours of coverage on that. We will go very deep. Now let's quickly look at running one or two of it. So we will basically go very deep understanding how we are running this program, and then there is an assignment for you. So let's do that. So first thing is, let's say I want to filter all the users who are coming for careers website. Let's just say, boss, but where is the data? Oh, where is the data? What is the data? I don't even know that. So let's carefully look at it. We are saying that we expect data in a folder called as user training weblogs, and there has to be a file called web. How will it work, man? We don't even have the data. Well, it's our job to build it. Let's do that. So let's go to HDFS and say HDFS DFS ls. Do we have a folder called as weblogs? No. So it's our job to create it. So we say HDFS DFS mkdir weblogs bang. So the folder is created. We are all in good shape. But where is the data? Now the data is also given to you. Okay, it's there on the learning site. And this is your file, which is weblogs. So the file is weblogsparts.txt. We will put this file, okay, inside HDFS. So let me just copy this file to my training folder so that becomes easier for me to get it. So I'll say places. In my home folder, I'm putting this file called weblogsparts.txt. HDFS DFS put weblogsparts.txt in weblogs, the folder I just created in HDFS, and we are in good shape right now. HDFS DFS ls weblogs, and this shows me that particular file. So there are good amount of records. How does this file look like? Well, let's open it. It's a big file. So our first thing is IP address. Second is the whole date. Then for analysis, we've again broken the whole date, 3 June, all that. The time zone, okay. Get, so this was the get request. What URL did the user visit? 200 is a response code. In the web, 200 means that the request was successful. 0 is something based on the data that we have. The user came from Mozilla, he was using Windows operating system, and so on and so forth. So this is my one record. And as a developer, I have already specified pick that. My first thing is IP, second is full request, third is day, month, month number, year, hour, minute, second, time zone, verb, URI, HTTP status code, bytes returned, referrer, and user agent. So now I have decided that this is my schema. In this program, I want to filter every user who came for a URI careers. So basically the URI should basically have careers as the URL. Only then we would want to filter that. So let's run this program now. Let's run this program. It is going to be dead simple. So now where is pick programs for me right now? Pick programs is in my downloads folder. Just to simplify it, okay, I will put them in my training folder. That's my home folder. Just to simplify, okay, it's just a folder copy, nothing else. So my PWD is home training. I say pig programs, pig with schema and filter. So I want to run the pig program which will filter everything by careers. Run this job, submit some MapReduce job. Runs a big time job, let's see. Now we've said that we want output to be dumped. Okay, there is other function called store. We'll be looking at that in detail. But here is the record that came. So like this, this is our output, let's say. Couple of records, we'll just look at it. 683.41.613.5 was our IP. This was our whole date, our time zone, the date broken. It was a get request, and the URL that user came for was careers. Okay, so we've got all the requests that had careers in them. Like this, I have given you 6 programs. So you are free to run them, practice them, do what you want. And the seventh one is an assignment for you. Seventh one is an assignment for you. So you've written all the 6 programs, understood the code, which is very simple, nothing, filter, group, all that. Review all the 6 programs and write the seventh one. The seventh one should read the log file and give output as IP month, year, and visits. Okay, IP month, year, and visits for that IP address. So that is pig. Okay, can we do it? Yes. Will you do it? Generally, no. Generally, no. Okay. Again, probably I won't be able to. I wanted to show one slide to you, explain what is what you call. If I wanted to just show one diagram for pig, this is the favorite diagram that you say. I get data from multiple sources. I'll have bunch of page jobs that may validate errors, fix errors, encode values, and load it in a warehouse. In Hadoop, the warehouse is Hive. The warehouse is Hive. So let me take a screen snap of it so that I can explain what I'm trying to convey here. Okay, I take this, it's a capture, and this is E. Okay, this is T, and this is L. Now, having said that, does Pig allow me to connect to Hive tables? Yes, absolutely possible. But in real world, you will not normally see people doing that. So answer is yes. But when somebody is doing or you want to do it, ask yourself a couple of times in production level that, do I really need to do that? That's the point I'm making. But yes, it's possible. Don't worry about that. Hive and Pig are like SQL and PL SQL. They'll have bunch of their own libraries. Okay, and there is community which will have a lot of defined function. But let's say something is not being done for you. Let's say be it Hive or Pig, you don't have a function to calculate a shipping cost. I can write that in Java and Python. You can call that as a user-defined function. You can call that as a user-defined function. So what I'm trying to say is, be it Hive or be it Pig. Okay, let's just put it this way. Let's say Pig has, for example, 100 functions, and from web you can get another library with another 10,000 functions. So that's, I think you'll easily find something called as piggybank.jar. So this will have basically some more functions for you in Pig. Same is the case with, let's say, Hive. Just like SQL, it has some functions ready-made for you. Just call them. But let's say your organization has a peculiar use case which has to be done, Okay. So, for example, you would want to pass a code, and based on that, you are supposed to get a full value, for example, that your organization only knows. Take a simple example. Your organization has device codes where you get device code and then I'll tell you the actual device, for example. So let's say Ravi will code something like a pig UDF for device name.java, .jar, and I will expose a function to you called as get device, for example. So whenever you're transforming, you pass one record, I will code that in Java and give you the output, just like a service. So this is called as user defined function. Same will be for Hive. What you're doing is using Snowflake. You're loading that HDFS in Hive and writing. Is that clear? Very straightforward exercise, completely self-explanatory. So if you look at exercise 5, it's you have MySQL where there is some data. It's fine. You are getting that data out using Scoop and dumping it to Hadoop file system. Fantastic. Once you get that data in Hadoop file system, you are using Hive to basically load that data in Hive and what do you call, query that data using SQL queries. Okay. Now, it's a self-explanatory exercise. You would not need help. Steps are fairly clear. What I would like to know from you is, do this exercise and answer a few questions for me. Okay. So, question is, okay, we successfully got data from MySQL to Hadoop, and from MySQL, data is stored in Hadoop at which folder? You need to tell me the path where the data is getting stored in HDFS. Second thing you need to answer is, okay, we got data from MySQL. We got data from MySQL, and we found that there were X number of rows in MySQL table. What is? So get started. Just one thing before you start, please run this command. The command is not in PDF. It's sudo service mysqld start, and go on and complete exercise. Alright, so all you're doing is from MySQL, you are using Scoop and getting data by HDFS, then you're writing Hive queries, and you will be able to run queries on top. Now the only thing I want to know after the exercise is, you guys tell me, you got data successfully, which folder does it get stored in HDFS? First thing. Okay. When you got the data from MySQL, how much number of rows are there in that particular data? And before you start, please run this command. This is very critical. You have 30 minutes to complete the exercise. So get started.
So the question is like, what is Pig and is it something similar to Hive? I have heard a lot about Pig. So where it is used, where it is not used. The first thing I'm going to tell about Pig is that, so this might be a little bit confusing, but still, Pig and Hive were invented almost at the same time to solve the same problem, meaning both these tools were invented almost at the same time, and both these tools allow you to solve the same problem. Well, almost the same problem, I can say. In most of the cases where you can use Pig, Hive can also be used. There are some situations where you cannot, but mostly. So you may be asking then, why did you just invent one tool? Why did you invent two tools? If Pig and Hive are almost the same, then why do you have two tools? See, the answer is very simple. Remember the use case of Hive? So Facebook was dealing with massive amount of structured data, and they were running most of their queries and all on Oracle with hand-coded Python, and that was the stage set for the invention of Hive, right? So Facebook had to move to Hadoop, and they had to query the data, and they didn't know what to do. So they practically invented something called Hive. At the same time, Yahoo was facing the same problem, but in a different way. So you see, Yahoo is the company who practically kind of invented Hadoop. They did not invent Hadoop. They basically acquired the Nuts project, actually, but the first stable release of Hadoop actually spun out of Yahoo, right? So when Yahoo had Hadoop, okay, the same problem was there. All right, I want to work with the data in Hadoop, but the only way is MapReduce. That means I have to force my employees to learn Java, then write MapReduce code. What should I do? But Yahoo thought it in a different way, actually. What Yahoo thought was, right, all right, let's create a scripting tool. Let's create a scripting tool which is very easy to learn so that people will just install it, write their script, and just run it. And the scripting tool is going to convert the script into a series of MapReduce programs. And that is your Apache Pig. So even though Yahoo invented it later, they contributed that to Apache, and it became a top level project. And you will be surprised to know that somewhere around 2013 and 2014, I think around 70 to 80% of ad hoc jobs in the world of Hadoop were achieved only using Pig. Pig is so popular, actually, one of the most popular tool. Well, not very recently, after the invention of Spark, in fact, Pig's popularity is not as we see today, but yes, still Pig is one of the best choice for all the programmers and analyst folks, right? So what exactly is Pig? We will see. So to give you the backdrop, this was invented by Yahoo at the same time when Hive was invented by Facebook. The only problem, these two companies did not talk to each other, right? So they didn't know that they was trying to solve the same problem and ended up inventing two tools. What is Pig? So it's basically a scripting language used for exploring large data sets. Now it is a new language, which means you will get some time to use to it. So the learning curve of Pig is higher than that of Hive. To put it in another way, if somebody has to learn Hive, it will be much easier since Hive follows SQL and most of us know SQL. You can just get a Hive CLI and start exploring right away. But when you start with Pig, Pig has its own language called Pig Latin. So Pig's language is called Pig Latin, and Pig Latin is a new language. So the syntax, how you use it, all are new. So you'll take some time to get familiar with Pig, but that's all fine. I'm gonna help you to figure out how to learn Pig and how to work with that. That's not a big deal, actually. So components of Pig. So actually Pig comes as a package in which you have something called a Pig engine, which runs on top of your Hadoop and converts your code into MapReduce. The language is actually called Pig Latin. Pig Latin is your language which you're supposed to learn. Now, what are the advantages of Pig? It removes the need of users to tune Hadoop, in the sense like if you're writing a custom MapReduce program, then you might have to fine tune the program, but Pig by default optimizes your code. You can turn on and off the optimization, but by default code optimization is turned on by Pig. So that means Pig will create the best optimized MapReduce code for you, and it insulates the users from Hadoop interface. So you don't have to practically learn MapReduce or Hadoop or anything. So if you're supposed to write some 200 lines of Java code, you can write the same thing in 10 lines of Pig Latin. And the same way, if you try to develop a Java-based MapReduce code in 4 hours, the same can be done in 15 minutes approximately in Pig Latin. So it opens the system to non-Java programmers. Now this we have practically seen. So whenever we are writing a Pig code, it's quite, how do I say, fast and easy to work with. Now it's a common way for every scripting language, right? So whether you are into Python or say Ruby or to shell scripting, all scripting languages gives you a couple of more advantages. All scripting languages are short and sweet. They have a lot of built-in functions to use. For example, if you look at Python, n number of packages and functions are available, right? Python codes can be very, very small. It's a scripting language, right? So the same way, Pig also acts like a scripting language. But it's not like your SQL, okay? So SQL is more or less like a query. So there, maybe if I want to pull the certain results from a table, I can write a single complex query and run it and get the result. But here, you might have to write it as a script to interact with Pig. So the next is Pig Latin data flow language. So it actually allows you, regular data types. So you can use long, float, char array, int, etc. So that is all possible. Pig also supports complex data types, which I will come in a moment. It is extensible and supports user-defined functions. So that means if you want to add some functionality to Pig, what you can do is that you can write it in something like Java, right, and call it inside Pig. So that is called user-defined function. I will show you an example of UDF or user-defined function. So you can write your own functions in your language, say Java, and package it as a jar file and register that with Pig so that Pig can use that UDF actually. Pig doesn't need metadata. It can work without metadata, without type declarations or anything. But if you provide Pig with metadata, it will work the same way. But Hive is not like that. If I'm working with Hive, my metastore service must be running. I cannot say that, okay, create a table, now don't use any metadata. It doesn't work that way. Either I have to use my own metadata service or something like hcatalog. But metadata is required. For Pig, you don't have to use metadata, but it can use when it is available. It can even share the metadata with other tools like Hive through hcatalog. It operates on files in HDFS. We know that. Provides common operations like join, group, filter, sort. So Pig has a lot of built-in functions. So provides common operators like join, group, filter, sort. So the power of Pig actually comes from these built-in operators. That means whenever you want to perform any operation, so you want to do a join operation, you can call the join operator and it will do the join operation for you, right? So this is actually from where the power of Pig comes into help us, right? What are the usage scenarios? So one thing might be web log processing. I will show you a Pig program which actually takes a web log and process it. Now, Pig is very good at string operations as well as regex, your regular expressions. So this can be extremely helpful in situations like web logs. So imagine you have a web server running and it produces a lot of log files. Now the log files will be kind of unstructured. It doesn't follow a particular pattern as such. You can call it semi-structured, but I would like to put it like unstructured data. And if you want to extract something, you can use Pig. So Pig is very good at trim, substring operations, regular expressions, etc., etc. Data processing for web search platforms, ad hoc queries across large data sets. Even Hive can be used for ad hoc queries across large data set. Rapid prototyping of algorithms for processing large data sets. So who all uses Pig? Yahoo, one of the heaviest users of Hadoop, runs 40% of its jobs in Pig. Twitter is also another well-known user of Pig. So Pig is kind of like one of the most widely used ecosystem tool that is available to us. Pig versus Hive. Where Pig and Hive looks exactly the same, right? Then why do you need, or is there a difference actually between them? Yes, there are differences, right? So if I just have to relate this, the major difference might be starting with this, okay? This is so maybe the first point is that Pig is just a client-side application. So there is no Pig server or something, right? So that means, so Hive can have an optional thrift server, and we have seen a Hive server 1, Hive server 2, etc., and where you will be using what, right? But when you look at Pig, Pig is just a client-side application. So there is no Pig server or something. And why is that so? Because Pig is not a data warehouse, and Hive is a data warehouse where you need to create connections for accessing and storing data. Well, Pig doesn't have to have. And one more thing here is there is no JDBC ODBC connectivity, and here it supports connectivity. So that means
Just a quick info, guys. Intellipaat provides online big data Hadoop training in partnership with IBM. The course link of which is given in the description below. Now, let's continue with the session.
either using the Beeline client or from your regular SQL clients, you can always connect to a Hive table, right? So Hive actually supports JDBC drivers, right? So you can directly connect to Hive and do whatever you want to do. But since Pig doesn't work on tables and doesn't work on storage, there is no JDBC or DBC connectivity. So if Pig has to get some data, the data should be in Hadoop, in a folder or somewhere. And it reads the data, transforms the data, and stores it back into Hadoop. That is what it does. There is no table or something inside Pig, right? And Pig is actually used by developers mostly. And here it is used by analyst folks mostly, right? So I mean, it's up to you, but again, mostly Pig is by developers and Hive used by analysts. And here schema is not mandatory. And here schema is mandatory. You need a schema, right? When you create a Hive table, you need to have some sort of a schema at least, right? And also Pig doesn't have a web server. Here you can have an optional web server, a web interface for your Hive. That is possible.
Just a quick info, guys. Check your knowledge of Hadoop by answering this question. Which of the following are the core components of a Hadoop? A. HDFS, B. MapReduce, C. HBase, D. Both A and B. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So I think these are the obvious differences actually. There can be much more, but some of the points that you need to consider, right? Where does actually Pig fit in the scenario, right? So let's say you have a Hadoop cluster. I have a MySQL database maybe, and I have a web server here, and I might have an app server here. So what I can do is that maybe I'm collecting data. So maybe I can bring in Scoop here, which can bring my data from MySQL into a Hadoop, right? And from web server, maybe I will pull the log files using Flume or something. So I'm getting all the logs from here. And here also I'm pulling some logs. So you see, I'm trying to collect multiple types of data, mostly structured and semi-structured. I dump all this data in a folder. Okay, so this is my folder in Hadoop. So what am I doing? I'm collecting data from my RDBMS systems, from my web server logs, maybe from my data warehouses, from multiple places. And then I dump them in a folder in Hadoop. Okay, so now the data is there. Now you may ask me, can I send this data to Hive? Yes, you can, but usually what we do is that once it is in this folder, I will run Pig, which will read the data from here and transform the data and send it back to Hadoop. So maybe, here is my data, right? And this transformed data will be accessed by Hive for reporting purpose. So Pig is actually used as a data factory operator or something which can clean your data. So what happens when you get raw data from the web server logs or from your databases? You may want to clean the data. So the ETL guys can correlate this very well more than that, right? You may have unwanted, information, unwanted marks and traces and cookie related information, robot scrolling information, etc. A lot in the data. So in that case, I may not be in a position to dump this data into Hive, because Hive is my final destination where everything gets stored and my reporting tools can directly connect to Hive table. So what I do, I use Pig for transforming my data, cleaning my data. And once Pig cleans the data, I give the structure to the data, and then that data can be stored in a Hive table. So you see, Pig is not storing anything. It is reading the data, transforming it the data, and storing it back to Hadoop. Another example is this sensor data, weather data, So if you're collecting data from this weather sensors like temperature, etc., etc., I will again show you an example. What happens is that the weather data usually comes in a very specific string format, which is very difficult to decode. So when I have my whole weather data in a folder, we can easily get the data, use some string operations to get whatever information you are interested, and then that structured data is stored in another folder so that your Hive can access. So pig is used as your cleaning operator or data factory operator to give structure to your data and so that it can be stored in Hive. This is the original concept. Now these days, whatever pig can do, most of the things Hive can also do. Hive can also work as an ETL tool sometimes, but yeah, so pig can be considered as a typical ETL on top of your Hadoop. Where pig and Hive fit in the system, right? Where not to use pig? Well, pig is not really good at pure unstructured data. For example, you have audio, video, images, etc. In such cases, pig might not be the right fit. It may not be able to process. So pig is the best fit use case in terms of structured and semi-structured data. And the next point I wanted to discuss, how come you have a weird name, pig, for this tool? The guys in Apache are really funny, I believe. I mean, there is something called the philosophy of pig. If you want, you can read it. The Apache pig philosophy, wherein Apache explains how they gave the name pig to this tool. So what Apache says is that, first of all, the animal pig can eat anything. Same way, your Apache pig can also eat any type of data, mostly structured, semi-structured, and some sort of unstructured. So that means pig will not say no. Anything you give, it will eat, just like the animal. The second point is that the animal pig is easily domesticated, meaning I can have my pig in the house, pig in my farm. So pig is a creature which can fit into any place. Same way, this Apache pig is also a tool which can very well work with different platforms. And Apache also says pigs will fly. So in the sense, like, you can write scripts on the fly. So that is the pig philosophy. So this is Apache pig's philosophy. See, pig eat anything, right? Pig lives anywhere. Pigs are domestic animals and pigs fly. So check out the pig's philosophy and understands why it is called as pig. A pig actually supports something called complex data types. So it supports your regular data types and it also supports a complex data type. So what do you mean by complex data type? There are three of them. One is called a tuple. Tuple is very common even outside the world of pig. Tuple is an ordered set of fields. Think about tuple like a row from a table, and tuples are usually represented like this. For example, 19,2, this is a tuple. Then there is something called bag. A bag is a collection of tuples. Well, the definition is not so correct actually, because a bag can contain tuples. A bag can also contain other bags actually. So bag is an unordered collection. So a bag is a complex data type which can contain tuple or it can even contain other bags. Map is a key value pair. How to start working with pig? So first things first, you have to understand the data that I'm working on. Otherwise, there is no point, right? So first thing you have to understand is the data. Now it is very common in any big data scenarios. You have to understand your data, then only you can start working with the data. So let me show you the data that I'll be working on. So now we have the data to work with. So there are two set of files. Okay, this is called New York Stock Exchange daily data. This has certain columns. For example, the first column is the exchange name, which is New York Stock Exchange. The second column is called a symbol or ticker. This is the stock name that we are monitoring. Then we have the date. So this is the date column. Then you have opening value, closing value, high, low, total trade volume, and another value, right? So basically this is stock data. So every stock will have opening value, closing value, high, low, total volume sold, etc. And this is a real good piece of data set. It's a public data set because you can do a lot of operations on this data. So this is one data set. The second data set is this. It is a similar data set but with only 4 columns. So this has first the exchange name, NYSE, second the symbol or ticker, third the date, and the last column is dividend. So there are 4 columns. So these are the 2 data sets we will be using initially to understand pig. Now if I go to my desktop, both these data sets are available in my desktop. You can see here NYSE daily and NYSE dividends. So both the data sets are available on my desktop. The first thing you need to understand about pig is that pig can run in 2 modes. One, local mode. 2, MapReduce mode. In this mode, pig will read the data from local file system, transform it, and store it back to local file system. Okay, in this mode, pig will read the data from HDFS file system, transform it, and then what? Store it back to HDFS file system. So, which means you can run pig in 2 modes. There is local mode and MapReduce mode. Local mode means if you start pig in the local mode, it's going to start it and it will take data from your Linux machine. Basically, it will expect the data from your Linux machine. It will read the data from your Linux machine, right? And it will do whatever transformation you ask it to do and store it back onto Linux machine, meaning it will not touch Hadoop in the local mode. In the MapReduce mode, the same concept, but it reads the data from HDFS, that is Hadoop, transforms it, stores it back into Hadoop. So MapReduce mode is something we use in production. Local mode is for testing. For example, if you want to create a pig script and see how it works, what you can do, you can run pig in the local mode on your laptop. It'll read data from your laptop's hard disk, transform it, store it back on the hard disk. So you'll just experience how pig works using the local mode, right? You can also do this in the MapReduce mode. So the first thing I'm going to show you is local mode. That means how pig can read and transform the data and store it in the local file system, right? So in order to start pig in the local mode, all you need to do is just type pig-x local. Yeah, in local mode, it has nothing to do with Hadoop. And local mode we just use for testing, right? So now I have started the local mode of pig. How do I know? I see this prompt called grunt. So grunt is the pig prompt actually, meaning this is the prompt of pig, right? So here I can type my first pig command. So this is how a pig line will look like to you. A line of code, a line of pig script will look like this to you. So what did I write? First of all, you can see that I have written something called dividends, and there is an equal to symbol, this symbol. So whenever you see this symbol It means it is a relation. Pig works on something called relation. How do you identify a relation? When you see this equal to symbol, that's a relation. So here I am declaring a relation. I'm saying dividends equals load, this is the file, as exchange symbol date dividend. Now this dividends can be anything. Okay, I just called it as dividends. Okay, you can give any name to that. For example, I can say Raghu equals this. Works. So here what you gave doesn't really matter. I mean, it should be something which you remember. By the way, it is not a variable. Pig doesn't have a concept of variable. This is called a relation, not a variable. So now we say Raghu equals load this file. So does that mean there is some data which is getting loaded? No. Load is an operator in Pig, or a function you can call it. What load actually does is that it will create a pointer to the file. Meaning, now I am saying that whenever I call Raghu, Raghu means this file. And this file has 4 columns. I'm naming the columns exchange, symbol, date, and dividend. And you see, I'm not giving any schema, meaning the data type. All I'm telling Pig is that, Pig, if I call Raghu, give me this file. And I have 4 columns in the file. These are the headers for 4 columns. That's all I'm doing. Now there are multiple ways to write a relation actually, but remember this, you have to start with a relation to work with Pig. So first step in every Pig script is actually loading the data or pointing to the data, because without the data, how do you work? How do you work without the data? Not possible, right? So now I have created a relation called Raghu, which points to this data, right? And you could have also noticed that when I created the relation, nothing happened. I said Raghu equals to load this. Well, that's fine, right? But did something happen? No. Nothing happened, because we call Pig as the lazy operator. Pig, just like the animal pig, is very lazy, right? So to give you an example, let's say you're sitting at home, you with your wife, okay? But imagine you are sitting at home with your wife or with your girlfriend, right? Now your wife comes to you and say that, tomorrow evening, today evening, you have to go out and get something. And she creates a list of things that you have to do. For example, you have to go to the supermarket and buy something. And you have to go to the telephone exchange and pay the bill, maybe. You have to go to the milkman and get the milk. But will you be doing that now? No. Because you are just creating a list of things that you're supposed to do. You are just sitting at your home and your wife says you have to do something, right? So what do? You create a list of things you have to do, right? You will say, okay, milkman, go and get 2 liters of milk. After that, what? Supermarket, go and get groceries. After that, what? Telephone exchange, go and go get this. X, you create a list of things you to do. But when it is time to do, when it is time to actually go, what you do, you just go out and execute them one by one. That is exactly how Pig will work. So here I'm saying Raghu equals load this data, and I hit enter and nothing happened. Why nothing happened? Because this is like I'm creating a list of to-do things. I'm telling Pig that, hey Pig, this is the data called Raghu. So Pig is going to ask me, so what? So what? If this is the data, what should I do? I'm not going to do anything, right? So just for the sake of argument, we'll keep it as dividends. Okay, so you can change it like this. So see, the declarations are completely dynamic, right? So I change from Raghu to dividend. So now this will be reading it as dividends. So first I declare my relation. Now I don't want you to pay attention to the to the syntax, but I tell a pig, pig, group dividends by symbol. So dividends is my previous relation. I want to group that by symbol column and store it in another relation called grouped. So now what happened, there is a second statement which correlates with the first statement. And still is pig doing anything? No, it is not doing anything. It is very lazy. It sits idle. Okay. Then I say for each group, that is a previous relation, generate the group number, calculate the average of dividend, store it in a relation called AVG. So I have typed 3 commands here. These are the 3. Or in pig's terms, 3 relations. And nothing has happened. Why nothing has happened? Each line is read and pig will look at it and see whether it has to do something. Yes, it has to do something, but are you asking for the output? No. Unless you ask for the output, pig will not do anything. Pig will sit lazy. So in the first line, I will say, okay, load the data. Second line, I will say, okay, group it by the symbol column. In the third line, I will say, calculate the average of every dividend. Fine. But finally, what should I see? I should see the average, like a print statement in Java, right? So finally you say system.out.println. That is where you see the output, right? So I have not done a print statement for pig. How do I do a print statement for pig? I will say dump avg. So dump is a keyword in pig, which basically says execute this relation. Dump means you're asking pig to do it or print it or show me the output. Now when you say dump avg, it's going to read this line. It says avg is collected to grouped. So it'll go to this grouped. This is related to dividends. So it'll go to dividends. So it starts executing line by line and show you the result. If I hit enter, a MapReduce job will be fired. Pig executes it line by line and will show me the average. And you do have the average here. All the entire stock average is written. This is how pig works. I mean, I don't want you to understand the syntax right now, but just the feel of pig actually. You first create a relation called dividends. Then on that relation you do grouping. On the grouping you calculate average. Then you will say dump average. This is one way of doing that, right? So, but there is a problem with this. The problem is that you're typing the commands line by line. You're typing the commands line by line. And the last line says dump avg. Dump is a keyword which we use to show the result on the screen. And avg is your previous relation, right? So if you don't want to do this, you can just quit from here. You can write it as a script. So what I can do, I can create a new file. I will call this file as testing.pig. So what is the name of the file? Testing.pig. So this is how you create a pig script. You can give it any name, .pig. And inside this file, I can just write my commands. So let me just copy paste them. So I just created a file called testing.pig. And if I open the file, it has the same 4 statements we had, but written like this, right? Now what I can do, I can say pig-x local. This means I'm running pig in the local mode, meaning the file will be read from my desktop. My desktop already has the file. And then run the script called testing.pig. If I hit enter, it should execute that. Same thing. And you get your prompt back. right? So either you can work interactively with pig by launching the shell where you have to type in line by line the commands, or if you are an expert, if you're very good at pig, you just put all the commands that has to run in a .pig file and run it. Both ways it is fine, right? So what did we learn? We learned that pig can work in the local mode, right? That means it is reading the data from your local machine and storing it also. Now another thing, if I open this thing, so one problem with this script is that the script will read the data, find the average and show me the result, but it is not storing the result anywhere. If you want to store the result, instead of dump, you can say store average into, then you give a folder name, say April 8. So what am I saying? I'm saying execute the 3 lines and then store avg into a folder called April 8. Now if I run the script, it should run the same way, but should store the result in a folder on my machine. Done, right? So now if I do an ls, there is a new directory called April 8. And if I go to April 8, there is a file called part R. If I open the part R file, here is the result. So either you can ask pig to show the result on the screen, or you can ask pig to save the result in a file. Both ways it will work. April 8 will be the folder name it will be creating. Inside the folder, the part R file will be there. Look at here. See, I'm inside the April 8 folder, right? There is also the map reduce mode of pig, right? So in map reduce mode of pig, what pig will do? It will read the data from HDFS, do the transformation, store the data back. In order to demonstrate that, I will use the same example, but my data will be in Hadoop. So let me show you that the same data is available in Hadoop first. So this is my Hadoop, right, Hue, and you see this NYSE daily and NYSE dividends are already available in Hadoop, right? So all I need to do, if I want to run pig in the map reduce mode, just type pig and hit enter. Remember previously you used to type pig-x local. Now you have to say just pig, and you see the same grunt prompt. But there will be a difference. For example, the same command I can say, I will write it again. I have to say load /user /cloudera / so I have to give the Hadoop path here. I have to give the Hadoop path here, right? Now if I want to store, I can say store dividend into, I can say /user /cloudera / a folder name April 8. So this will start the MapReduce job. It's going to store the file into Hadoop to a folder. So you can see that it is creating the jar file and running the MapReduce job, etc., etc. So the MapReduce launcher is done here. You can see it is 0% complete. So it's a proper MapReduce job because you are running in the MapReduce mode. Done. So you see the result, right? And if you go to my Hue, if I go to my Hue, just go back to the same directory again, it should have created a folder called April 8. Here is April 8, and here is the result file. So my point is that running pig, the commands and all are same in local mode and MapReduce mode, right? If you want to run pig, it's same, right, in local mode or MapReduce mode, right? Only difference is that, you know, in local mode, you have to give the input path from your Linux and output path in Linux. In MapReduce mode, give the input path in Hadoop, output path in Hadoop. That is the only difference, right? So now we can look at the schema. Look at what I'm doing. If you carefully observe, you will understand what is happening. So first, let me start pig in the interactive mode, the local mode. I'm going to start pig in the local mode. That means I have the file in my desktop. I want to read it and do something, right? So I started in the local mode, and what I'm going to do is two things. So first thing is this. I'm going to say dividends equals load the data as exchange char array, symbol char array, date char array, dividend float. So this is explicit data type declaration, meaning this is usually how you work with pig, because you will have the data and you will know the columns and you will know what data type you want. So what you do is that you will tell pig, hey pig, load this data called NYSE dividends, which has 4 columns, and these are the data types of all 4 columns. If you do this, pig will stick with whatever data type you have provided, just like any other programming language. So here I'm saying that these are the data types I want. And how do you know the data type of a relation? You say describe. Describe dividends.
Just a quick info, guys. Test your knowledge of big data by answering this question. Which of the following are incorrect big data technology? A. Apache Hadoop. B. Apache Spark. C. Apache Kafka. D. Apache PyTorch. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So when you say describe dividends, it will say that dividends has 4 columns, and these are the columns. Now, let me do now dividends. Describe here. What I did, I loaded the data saying explicit data type. I said these are the columns, these are the data types. Then I said describe dividends, which will show me the data type for dividends, and it says these are the what, data types that we have. Then I said dividends equals load NYSE underscore dividends. Let me just, or you can say daily. Okay, so let's take another example. Or you can say this, and you can say describe daily. So I'm just saying that load the file. I'm not giving any schema. So then if I say a describe, what it is going to tell me? So pig will say schema for daily unknown, because you are not mentioning any schema, right? So now the question is, if I'm just loading the file like this without describing the schema, can I perform some operation on the file? Yes, you can do that. That is the real advantage of pig. And I think no other tools have this advantage. Very less tools have this advantage. I'm going to show you that. So now what I did, I just loaded the file called New York Stock Exchange Daily, It has like 8 columns. I did not even give the column names or data types or anything. And then I just said describe daily, and Pig tells me that schema is unknown. But you can transform the data. So I loaded the data, and then I'm saying for each daily. So what is daily? Daily is this data, right? Generate $7 by 1000. So $7 is 8th column. So we represent column with numbers $0, $1, $2. So I am asking Pig to divide every number in the 8th column by 1000. Again, I am asking Pig to multiply every element in the 4th column by 100.0. Then I'm asking Pig to extract the first character from the first column. I am also asking Pig to subtract the 7th and 4th column elements in every row. Now leave the syntax. So it is using an operator called for each generate. But basically what I'm asking Pig is that, hey Pig, look at this thing called daily, right? And it has 8 columns. You have not given any column name, that's fine. But it has 8 columns, right? So obviously when you load the data, if the data is tab separated, Pig can read. So Pig expects the data which is tab separated. So every column should be separated by tab. If your data is not tab separated, you can give an argument like comma or whatever you have. But by default, my data is tab separated. So when I say load NYSE daily, Pig will automatically identify every column. It's going to name every column like $0, $1, $2, $3. Then I'm saying for $7 by 1000, that means I want every element in the 8th column to be divided by 1000. Every element in the 4th column to be multiplied by 100.0. And substring operation means from $0, that is the first column, I want a substring 0 to 1, first character. And I also want for every row subtract $6 minus $3. That means 7th column minus 4th column. Now what I am trying to tell you is that you are asking Pig to divide every element in the 8th column by 1000. So when you ask somebody to divide something by 1000, that means that number should be an integer. So Pig will automatically cast it as integer, the 7th column. Again, for the 4th column, you are asking it to multiply by 100.0. So when you say 100.0, multiply something by 100.0, Pig will assume and cast the column as double, data type double. And when you say substring, it will automatically understand that you want to extract characters. So it's gonna understand that this is char array, right? But when you say minus $6 minus $3, there can be a confusion because you are asking Pig to do a subtract operation. Now, the subtract operation can be between integers, can be double, can be floating point, right? So for precision, Pig will assume both are floating point and will do the subtraction. Now, if I do a dump of this calcs, you can see it will show the result. See, even without giving any schema, it is able to understand your schema. So the first column is integer because you're asking to divide by 1000. The second column is casted as double. The third is char array. The fourth is again a floating point, right? So I will show you this calc relation once more. Now look at the result, you will understand. So this is what will happen if you do not mention the schema. Ideally, you should mention the schema. So that is another thing. Ideally, for pig to work on, you should mention the schema. I mean, that is what we do. But in some cases where you don't have the schema as well, you can quickly load the data and transform. For example, imagine you're getting a text file with some 10 columns. All are whole numbers, integer. You can just load it and do all the operations. You don't have to declare any data type. Because, you know, when you say, okay, divide by 1000, it'll understand it is integer by looking at by what number you are dividing and cast it as integer. Let us look at the operators or the syntax in writing. Operators in detail. Right? Now, what is the load operator? The load operator will, like I said, create a relation which will point to your data. So if you look at my data that I was using, it is this NYSE underscore dividends or NYSE. So if I open this data, you see this data is tab separated. The separator is tab. And by default, Pig will understand your data if you're using the tab separator. But what if your data is not having the tab separator? What if your data has comma, right? So what you can do is, if you look at this data, this is the Olympic data set, and this is comma separated data. This is the comma separated data. Now, what can I do with this data if I want to load it? Very simple. All you need to do is, in Pig, you say A equals load, say Olympic using Pig storage. Now I'm saying load Olympic. This is my file.
Just a quick info, guys. Intellipaat provides online big data Hadoop training in partnership with IBM. The course link of which is given in the description below. Now, let's continue with the session.
Using Pig storage, comma. So you have to say this Pig storage if you're having another type of data. Now I can simply, so this is the load operator. So if I say load Olympic only, it will expect the data to have tab separated values. If I say load Olympic using Pig storage, comma, that means it expects the data with comma. So this is very good if you have CSV files or comma separated values, etc. This is how you can load the data. And just to see whether the data is loaded, do we have a schema? No, there is no schema because we have not mentioned. You can say what? Dump A. It should dump the data. And you can see the data. So you see the data is perfectly loaded. So you have to see this using when you are using the load operator. And we also know this store operator, right? If you want to store the result, so this is the load data, then I can say store A into Hadoop folder name, whatever. So you have to create a folder here and it will store. Dump will show you the result on the screen and store will store the data in a folder. So either you can use the load store operator or the dump operator. Dump operator will show on the screen, which is not so good. If you're having like 1 million lines, it's going to throw all the 1 million line on your screen. Rather you say store, it's going to store someplace. In Hadoop, you can give any folder name which you have access to. Relational operators. Okay, we have something called relational operators, right? So now let me show you a couple of examples for this. So I'm going to load another one. I'm going to create a relation here. I'm going to say load NYSE daily as, I'm just giving the column names here. Exchange, symbol, date, open, high, low, close, volume, ADJ, close, right? So I'm going to load that. Now, the first operator you have to be familiar in Pig is the for each operator. So how your for each operator works is that it is going to take every row and apply an operation you are mentioning. So here I'm saying close minus open. So there is a column called close, another column called open, right? So it's kind of like a SQL loop, right? So it's going to apply something like a SQL loop. It's going to go iterate through every record and subtract. What if I want to see whether this is working? What should I do? So I have to dump the operator called gain. So I will say relation called dump gain. And that's it. I can also do much more things. Okay. So now what I did this, right? I can also say C equals prices. I can say for each prices, generate $0, $1. And now let me do a dump of C. Did you see what I did just now? I said for each prices generate $0, $1. Right? That means you are just extracting 2 columns. And when I did a dump, what did I get? Exactly 2 columns. So how easy it is to filter, right? I just want 2 columns or 3 columns, you know. You don't have to even cast it. You don't have to say the data type. You just say load for each. That's it. You get. And store it as a separate file. That's it. So this is data transformation. So that is what I'm saying. It is very easy to transform your data. Is this relations case sensitive? That means, okay, A equals load is not same as A equals load. Here I'm saying A equals load abc.txt. And I'm also saying capital A equal load. So small a and capital A are different. So relation names are case sensitive. But I can say either this or this. So the operators like load or for each, either you can use small letters or capital letters, but the relation names are very specific. Now you can also do this. For each operator can be used for mentioning a range. So again, I'm loading the same data, prices, right? And I can do these things. You can say for each prices generate dot open. That means it produces exchange symbol date open, all the columns till open. Or you can say open dot close. That will be open, high, low, close. Or you can say volume dot. That means volume and adj underscore close. So you can mention a range of columns like this. So I say I created a relation called divs. Okay, and I'm loading the same one. And I can say, okay, so here I'm creating a relation, right? And how many columns we have in this relation? Well, it's not called columns in what you say pig. It's called a record. Sorry, it's called a field actually, not a record. How many fields we have in the divs relation? 4. Exchange, symbol, date, and dividends. So we have 4 fields, right? And look at what I'm doing. I'm saying here a new relation in underscore sense. For each divs, generate dividends into 100 as dividend, comma, dividends into 100.0. So this is a bit confusing the way I write it, right? So I'm saying for each divs, that is my previous relation, generate I want to multiply this field called dividends into 100 as dividend. So what do you mean by here as dividend? I have written dividends into 100.0 as dividend, again dividends into 100.0. It is the field name. See, what I'm telling to Pig is, multiply every element in dividends column or dividends, what you say, field, right? And store it as something called dividend. So I'm creating a new column or a new field called dividend. But on the second relation, what I'm doing, I'm saying multiply every element in dividends, but I'm not asking to store it as a new column. So what will automatically happen? A dollar will be created. So if I do describe, see, it has a column called dividend, which is double. The second column is just double. There is no column name, and you will be able to access it by $1. Did you understand that? That means whenever you're performing any operation, you have to say as some column name, right? Otherwise, it will create a column with a dollar notation. Okay, let's go to filter. So in filter operator, I will just load the data first. So it says load dividends as exchange carry, symbol carry, date carry, and dividends float. Okay, and I can say filter divs by dividends greater than, I don't know what's the data we have. See, what did I do? First, I loaded the data. So data is loaded like this. NYSE dividends as exchange, symbol, date, and dividend. Then I can say filter divs. Divs is my previous relation by dividends column greater than 0.14. I want all the rows where, so you can say some column greater than some value, less than some value, equal to some value. And then I did a dump of D. It will dump D and show me all the records where this column is greater than 0.14. So filter operator will take a condition. Filter will say that filter the relation where the column value can be greater than, less than, something, something. Now that will work for integer, floating number, etc. If you are having characters, for example, in this example, first two columns are characters, right? Third is date, leave it. But first two are strings, right? So what I can also do is that I can say what? Filter divs by symbol, which is my column name, matches cm dot star. So that is like matching with an expression. So I want all the records where in the symbol column it starts with cm. If I do a dump, see, all CMO, CMA, CMS, CMI, CMK. All you need to do is that filter a column, either a regular expression or you can say greater than, less than something. That is the filter operator, right? So that's the filter operator. Now you also have a very important operator called grouping operator. Okay, So this grouping operator is very, very, very important in case of pig. Just see, there are so many operators actually. Let's look at grouping first. Anyway, so first let me load the data. Now you can also load the data like this. Look at here. I'm saying, load NYSE daily as exchange and stock, meaning I'm just using only 2 columns. I'm just using only 2 columns. So it will load only 2 columns, right? I will say group daily by stock. So grouping is a very common operation. We see grouping in SQL, grouping in many places, but grouping works in a very different way in your pig. So all I'm seeing here is that I want to group the previous relation, which is my data actually, by stock name. So you will expect all the stock names will come together. Yes, it will come together, but in a very specific format. If I do a dump of grpd, okay, so this is the grouping result. Or let me see whether I can get any other data set. So I can say A equals load Olympic, okay, using pig storage, comma. This is the Olympic data set. And since I did not mention any schema, it's going to load with default schema. Okay. Now I want to access, let's say 0, 1, 2. So I can say B equals group A by 2. So what I'm saying, group A by $2. So what is $2? $2 is the country. I want to group the data based on country. When I say dump B, this is what you will be getting, and this is probably what I want to show you as well. Yeah, so look at this. You have the country name. So let's see a country where there are very less athletes actually. So it's easy for us to identify, right? Look at here. This is one record of grouping operation. This is one record. So here it will have 2 parts. One is the grouping key, which is the country. So I'm looking at the country called Dominican Republic. Second part is all the records which belong to Dominican Republic. Look at here. So there is one guy who is in Dominican Republic, and there is another guy, there is another guy, there is another guy. So this is how the grouping result will happen. So my point is, when you do grouping operation, the result is like a key value pair. The key will be your grouping key, in this case the country, in my record Dominican Republic. The value will be a bag which contains all the records matching with Dominican Republic. Same way you have Trinidad and Tobago. If you look at here, another country, right? And these are all the values of Trinidad and Tobago. So look at the first element, Trinidad and Tobago. That is the grouping key. Then in a bag, you have all the athletes who are in Trinidad and Tobago. So this is one record, one athlete here, right, from Trinidad, then another athlete here, etc., etc. So what I can then do is, for each B, generate group, I can say something like this, and count, let's say A equals load Olympics. Then I said, where is B? B equals to group this, Then I can say C equals for each B generate group comma. Then here we are basically what we are doing is actually counting the data. Count. Then I can say dump C. So this statement means we are just loading the data. Fine. Then what did we did? I said group A, which is my original data, by $2. $2 is what? My country column. Then in C, for each B, generate the group name. So I want the country name and count A. So what will be A? A will be my original data, right? A is where I'm loading every record. So it's going to count. So basically, this is going to give me a count of every country. See, New Zealand, there are 51 records. North Korea, there are 21 people. So grouping is very useful in doing things like this. Grouping is very useful in, and for NYSE, you can do the same thing. You can say load NYSE daily as exchange and stock. That means I'm loading exchange and stock. Group the relation called daily by stock. Then I can say for each group generate, so previous relation group, and then count the daily. So it will count how many are there. So this is how we do the grouping operator. You can also say order by. I say daily equals to load this, right? And I can say order daily by date. So what this will do, it will look at the date column and order that. By default, it will be in the ascending order. You can say descending as well, right? So, so by default, it will be in the ascending order, okay? You can also do multi-column ordering. I can say order daily by date, comma, symbol. If you want, you can do that also. Okay. And you can say order daily by close descending, comma, open. So this close field will be descending, other will be ascending. Yeah, so here is join operator. So if you want to do join, you can simply load the data and you say divs load as exchange. You can say join daily by simple date, divs by simple date. You can do single column join or multi-column join. Let me just show you this. So I will load the data called daily first, and then I will load the data called divs, and then I can do a join. So this will be normal join, right? You can also do left outer, right outer, full outer, whatever type of join you want. So here I'm saying join daily by symbol comma date, divs by symbol comma date. If I dump JND, it should have the multi-column join result. See? So this is the join operator. You can also say limits. Okay, so I can say load the data. So here I'm saying load the data. I'm not giving any schema. I can say limit. I can say limit divs 10. Okay, now if I dump first 10, what's going to happen? It's going to show me only 10. So what did I do? Limit divs 10. So the limit operator will limit how many records will be shown. How do I say? Random selection. You cannot say which to limit. So the limit operator actually limits your data, right? What a word count program. Now the first thing I'm going to do is that I'm going to run the word count program, right? And just ensure that it can actually do the word count. We will look at the script later. First we will run the script, and see whether we are getting the result. So I have the script. This is the script actually, which will do the word count for us. And I will explain the script later. As of now, we just have to run the word count program and see what is going to happen. This is the script which has this word count.pig, and all I need to give is
Just a quick info, guys. Check your knowledge of Hadoop by answering this question. Which of the following are the core components of a Hadoop? A. HDFS, B. MapReduce, C. HBase, D. Both A and B. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
the file name, and the file which will be analyzed is this file. This is the file which will be analyzed. Mary had a little lamb, its fleece was white as the snow, and everywhere that Mary went, lamb was sure to go. This is a nursery rhyme, right? So we will do the word count on Mary had a little lamb. So this is the sample data that I have for analysis. So in my script, I have to give this data. So what I'm going to do, I'm going to open my script and I'm going to say that this is what I want to load. And then I'm going to run this first. I'm going to say pig-x local word count.pig. So this is how you run the script. So I'm just going to say that, hey, pig, run this for me, word count.pig, and just show me what it is there, right? I'm just going to hit enter and see whether we are getting the expected result. And we are able to do the word count very well with the script. So it is just a 4-line script that we have, and it actually does the word count. Now compare this with your Java program, the MapReduce program, which was doing word count. It was very complicated to write, right? So this is quite easy to do it. So now, all right. So now let's see what is going to happen. I'm going to just explain the script. Rather than explaining the script, what I will do is that I will run it line by line. If I just run the script, you will not understand anything. So what I'm going to do, I'm going to run it line by line. So to do that, I'm just going to start. Let's analyze the script. This is the first line in my script, and I don't think it needs any explanation. All I'm doing is that I'm loading the data as a single column, a single field. So I'm calling this entire 4 lines of data as a single column or a single field. The name of my column is line. The name of my column is line. Now I'm not mentioning any data type or anything, because since it is a word count, I really don't know what will be the data that I'm getting in. I don't know. So I'll just say that load this data as line. So line is my column name. What is line here? It's a column name, basically, right? Then what I do is I do this. So I will create another relation called words. For each A, that means for every line in my data, generate tokenize the line. So what is line here? Line is the column. So line means, the column which represents your data. Tokenize is a function or an operator in pig which will extract every word. So basically what tokenize will do, it will pick every word. Flatten means it will create a row for every word. So basically when you say for each A generate flatten tokenized line, what it is going to do is that it's going to read every line, extract every word, and for every word it's going to form a row. So basically it will arrange all the individual words in a single column. As word means that will be my column header. So think about them like column header. Here line is your column header for your original data, and this is the column header for the transformed data. Now if I do a dump of words, so I'm dumping this relation, okay? So if I'm dumping this is what you get. So what that flat tokenized flatten will do, it's gonna pick every word and arrange them in a column like this. So now I have all the words that I want to count, but I know that Mary is repeating here. So here is Mary in the first row, and again Mary is here. So Mary is repeating 2 times. So if I want to count Mary, I should group them. So the next step will be grouping my data. So I will say that GRPD group words by word. Words is my relation, word is the column name. Okay, now don't get confused. Words is my relation, word is the column name or column header. So I'm saying that group the relation called words by the column word. Now the column word has all the data. What data? This data. So this is the column which contain word actually. So remember the grouping operator in pig. So I know that this is my data, I mean the previous relation, and I know that I'm doing grouping. I know that I'm doing grouping, but being a pig developer, what you should know is how the output of grouping will look like. So to do that, I will do a dump of this relation called GRPD. I'll take a dump of this, and this is how it looks like. Look at an element called Mary. Now this element or this record called Mary has 2 columns. First column is the grouping key, which is Mary. Second column is a bag which contains a tuple, I mean not a tuple, the repetitions of Mary. Right? So first is the grouping key. Second is the actual number of repetitions of Mary. Same with lamp and snow, sure, they just repeat only once, right? But this is what you need to understand. Now what I need to do is I have to say for each GRPD. So GRPD is my previous relation. For each GRPD, generate group. Generate group. So what is group here? Group will be this first column. And count words. What is words? Words will be this column. So if I apply this, what is going to happen is that it will generate group called Mary and then count 1, 2. 2 times Mary is repeating. Now remember that words is your original relation, right? So this is words, the column called words, remember, so that is where the column which contains all this, data, right? And I grouped it. Then I'm saying that count these words. So basically these words, this Mary is actually part of words, right? So I just want to count this 1, 2, right? And this is group. So if you look at here, see, group words by word, right? For each generate group. So generate group means it will generate the grouping key and count it. Right now, if you do a dump of CNTD, you have the final result. Right? So always remember the result of a grouping operation has 2 parts. One part is the grouping key. The second part is the elements that are repeating. So in this case, Mary will become the grouping key and Mary, Mary will be the result. So all you need to do is that, for each generate the group and then count that relation. So it will count how many times it is happened. So this is how you write a word count program in Pig, weather data analysis using Pig. So basically this is string operations actually what we are going to do. Now let me first show you the data, then I'm going to explain what we'll be doing. So this is the data which we are going to analyze. And it doesn't look nice. The data doesn't look nice. Why it doesn't look nice is because it is the weather data. So what do you mean by weather data? So these are the type of data that we get from sensors and all. So this data basically has temperature readings and lot more than that, but we are actually interested in temperature readings, right? Now, if you look at the data, you may think it doesn't have a structure, but it does have a structure, right? But you know, you cannot really put it into a column format and all as of now, because you know the way it is given is kind of like very funny, right? So what we are going to do from this data is, this is kind of like unstructured data, semi to unstructured data. We are going to use pig to extract the information that we want. So I just started pig in the local mode. And if I look at the commands that I'm doing, okay, so first thing that I'm doing is that, so what's the file name that we have? Let me just check. It is weatherpig.txt. So first thing I'm going to do is that I'm going to load the data. I'm going to say A equals load this data using text loader as data and char array. So basically I'm going to declare this as char array because I want to perform the substring operation. I want to perform the substring operation. So I'm going to declare this as char array for the time being. All right. So then what I'm going to do, I'm going to say for each A generate trim. So trim is an operator which you can use in pig basically to trim, and then you can say substring from this column called data 6 to 14, 38 to 45, 46 to 53. So what does this mean? So basically I want to extract character position 6 to 14. So where is that? 6 to 14. 0, 1, 2, 3, 4, 5, 6. 6 to 14 will be this data. So since I'm loading it as char array, you know what it will do is that it's gonna get this, right? And this is going to be the date column. So this is the date actually. You can see it is 2013 January 1. Same way I'm gonna extract from 38 to 45, which is minimum temperature, 46 to 53, which is maximum temperature. Now you might naturally ask me, how do you know that this is the data? You have to ask the guy who is giving you the data to understand the data structure, right? So, you know, once I extract that, basically, you know, I can actually dump off this and see how it looked like. Dump AF. And this is how my data looks like now. So now the data is extracted into the date. So date is there, comma, minimum temperature, comma, maximum temperature. So I have this format now for my data, but this is not I want to do. So my use case is different. So what I'm going to do now, I'm going to store this data. So I will say store the data into a folder, right? So how do I know whether a folder is created? So if I do an ls, there is a new folder called data9, right? If I go to this folder called data9, do an ls, there is a part m file. If I cat into this part m file, I have the data. So basically I stored the data in a folder. Okay, so once your data is stored in a folder, what you can do is you can give structure to your data. I can say that Possibly this will be data 9. I can say load this data which we just extracted using pick storage comma, because the data is comma separated, as date, minimum, maximum. Now you are creating schema for this data and loading it into the relation called S. So now this relation called S will have 3 columns which you have extracted from the raw data, and these 3 columns are even having specific data types like char array, double, right? So now I have the date, the maximum temperature and the minimum temperature. And what I can do, very simple. If I want to find the hot days, what I can do, I can say x equals filter s by max greater than 25. So I'm saying that filter the previous relation, okay, by the column called max greater than 25. So I'm assuming that any day which is having a temperature of more than 25 is a hot day. So now if I dump x, I will get all my hot days. So look at this. On the last column, all are more than 25, the max temperature. You can also say min less than 0. You can find the cold days actually. So I can say x equals filter s. S is my previous relation by min column less than 0. Now if I do a dump of x, I should be able to see. So you see the second column in this result, right? All are less than 0, right? So basically that is the condition I have given, right? You can also do a lot of other things. Now these are more towards the statistic stuff, right? This is more towards the statistic stuff. So basically if you want to find out the hottest day, what you do is that you do a group S all. So I will say, so normally you say group S by the date column, by the minimum column, by the maximum column. But here I'm saying group S all. This is a very special grouping I'm doing. See here. So this is what I want to show you. I'm saying group S all. So normally you say group by. So now if I take a dump of H1, the result will be very interesting. So this is the result. See, group S by all actually means it will create only one result. The key here will be all. Can you see this? The key is going to be all. The values are the entire data that you have. So when you say group S all, so you are asking to group by everything, which is kind of like impossible. So what Pig will do, it will create a key value combination in which the grouping key will be all. All means everything. And the value part will be every element in your relation. See, so this is what happens. And then what I'm doing, I'm saying, for each H1, so that is my previous relation. For each H1, generate max S dot max as maximum. So I'm declaring a new column here. So that is why I'm saying as maximum. I'm using the max function. Okay, S dot max. That means in this, I'm going to find the maximum. So then if I do a dump of this relation, I should see the max value. So that is 34.1. This is the max value that I'm getting. Now, so I'm finding the hottest day. So then all I need to do is that I have to say filter S. S is my original relation by max, that is a column, equals I dot maximum. So I dot maximum will be this. So basically finding the maximum and filtering the data. I want the record where this 34.1 occurs. So that is basically if I do. So if I do a dump of X, this will show me the hottest day. This is the hottest day. 2013, 12th June. maybe. It's a bit complicated to understand, but I guess you got the grip of it. So first I will group S by everything. Then I'll say for each H1 generate maximum, you know, S dot max as maximum. Hmm? So this will give me the max value. Then I will say filter the S by max equals I dot maximum. So it will show me only that. Same way you can find the coldest day as well. So same way you can find the coldest day as well. Okay, you can just say max of the column and then do the filtering also. Here I wanted to show you this group as all, so that is why I used it this way. Okay, so you can also, say that instead of doing this, you can say for each, S, generate max of the max column and filter that by I dot maximum. That will also work. S dot max actually means S dot max means in the relation S, the max column. In the relation S, the max column. So what the only thing here we are doing is group S all. This will create a result wherein the grouping key will be all and the values will be everything in your S. So S is your basic data, right? And then I'm saying for each H1 generate the max. Max is my operator. S dot max. S dot max is my column as maximum, right? Then I'm saying that filter S by max equals I dot maximum, right? So this is the way I have written. I suggest you to try a little bit different also and see how it gives you the result. What is the requirement of Hive? You have this guy called RDBMS, right? So let's say you are using MySQL and you are also using, let's say, MS SQL, that is Microsoft SQL, right? And you are also having Oracle. So your organization, let's say, uses 3 databases, right? Now, why are you using 3 of them? I don't know. Maybe you're using Oracle for transactional data, payment, etc., etc. Maybe you're using MySQL to store product catalogs, etc. Maybe you're using Microsoft SQL for some other purpose. So, but just assume that you are having 3 databases, right? Real-time databases. Now, these guys are called RDBMS or database, right? And we also call them a name called OLTP. They are online transaction processing systems. Now, I know that this is too basic, but I'm just trying to give you an idea. So every organization has multiple OLTP systems, maybe single OLTP systems deployed across the world. Now, your manager comes to you and says that, hey, so let's say I'm the employee, so my name is Raghu. Hey, Raghu, we want to do something. You know what? We want to just collect the data from all these databases, and I want to create a nice report and show to my CEO so that I can get a free holiday. So I can impress my CEO with my nice report and all, so I can get a free holiday. Maybe you get a salary hike also. So why don't we pull all the data from these systems and put it into a place and practically create a report out of it? Now, you have guys known as business intelligence guys, BI. So business intelligence is a part wherein you get data and you make sense out of the data. Given any type of data, you can create nice charts, pie diagrams and reports, etc. using business intelligence.
Just a quick info, guys. Intellipaat provides online big data Hadoop training in partnership with IBM. The course link of which is given in the description below. Now, let's continue with the session.
There are a lot of BI tools available in the market. For example, we have Pentaho BI, many tools are available, right? So I thought like, all right, so let me do one thing. Let me take a business intelligence tool, which can create nice reports and all, and let me install it on my Oracle. Let me also install the tool on Microsoft SQL and MySQL, all 3 databases. But this doesn't make any sense. Why it doesn't make any sense is because you see all these databases are real-time databases. That is why we call them as OLTP. And they are serving your customers in real time. I don't want any unnecessary load on these databases, right? So if I install a reporting tool on top of it and start digging the data, it may impact the performance of these databases. So I don't want to do that, right? So what I do is I bring in the elephant in the room, and that is my friends.
Just a quick info, guys. Test your knowledge of big data by answering this question. Which of the following are incorrect big data technology? A. Apache Hadoop. B. Apache Spark. C. Apache Kafka. D. Apache PyTorch. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Your data warehouse. We call it as DW. You can also call it as OLAP, Online Analytical Processing System. So using ETL, you bring data from your RDBMS systems into your data warehouse. So technically what is happening is that using ETL tools, ETL is extract, transform, load, right? You can take data from your RDBMS systems and dump it into a place called a data warehouse. Now, data warehouse is a fancy term actually. It's not a fancy term, it's a technical term. What is a data warehouse is nothing. Data warehouse is a place where you store, first of all, massive amount of data. Point number one. Point number two, this data is ready to be accessed, ready to be reporting. So if I have a BI tool, my BI tool can be directly installed on my data warehouse and it can produce nice reports, etc., etc. And a data warehouse is internal to your company. You don't have public access, because this is your private storage. I'm collecting all the data and dumping into this guy so that this guy holds the whole data, and now I can do whatever I want with my data. Very simple. Organizations were doing this for quite some time. If you go to any enterprise organization, what they do is that they will have multiple OLTP systems. They keep on collecting the data, nightly cron jobs or whatever you want, and then dump it into a data warehouse, right? Now the data warehouse will hold historical data. So this guy has historical data, meaning it will have this year data, last year data, last to last year data, a lot of data, right? And on this data, you can do whatever analysis you want. Very simple. So data warehouse is a place where you store massive amount of data ready for analysis, and you do not typically have what you say public access to this thing, right? And that is. Now, if you look at the players in data warehouse, you have many companies who are doing this. There is somebody called Teradata, which is a major player actually. You also have Oracle Exadata. These are all data warehousing companies, okay? You have SAP HANA, you have Netezza, Greenplum, etc., etc. These are all data warehousing companies. So in your organization, if you want to implement a data warehouse, what you do is that you go to, let's say, Teradata and say that, hey, Teradata, you know what? I want to implement a data warehouse in my company. So Teradata says, all righty, take this and go. So they will give you practically an appliance, like a box, which you install in your company, and then you can load it with data. It stores, you analyze the data. So the question is, why am I talking about this? What is the big deal about this? See, there is no big deal about this, but so far, whatever I was discussing is how the world was working. Now, everything seems nice here. Okay, nice. We have OLTP systems. We take ETL. We dump the data to data warehouse. We produce reports. Nice and happy. But only one major problem. And the problem is this. Dollar, dollar, dollar. Money, money. Okay. The problem is cost aspect. Data warehousing is a costly affair, to be honest with you. Right? For example, if you want to implement a Teradata solution, it will cost you millions of dollars, practically speaking. It is not so easy. Also, it is not so cheap. People who are working in the data warehousing background will be able to comment on this, but data warehousing is a costly affair, right? So that is the backdrop. That is the history that we are talking about. Now enters Hadoop. So here is your Hadoop cluster. So what is this? Your organization has a Hadoop cluster. Now imagine your organization already has a Hadoop cluster. Fine. What is the problem? In a Hadoop cluster, obviously you can store big data. Right. But what happened was that somewhere in 2006, the company called Facebook got interested in Hadoop. So Facebook was dealing with this big data problem. So basically, Facebook was in the growing stage in 2005, 2006, etc. And Facebook was getting a lot of users at that point in time. And Facebook was thinking that, what, everything is working fine, but we really don't have a solution for storing big data and analyzing big data. And Facebook was running completely on Oracle. Oracle was their prime backend actually, and Python. Python plus Oracle, that was Facebook's initial architecture, right? Now, somewhere in 2006, somebody told Facebook that, hey, you know what? Why are you so worried about storage of data? There is something new in the market called Hadoop. And if you implement a Hadoop cluster, you can store unlimited data practically, because Hadoop is naturally the solution for big data, right? So Facebook got interested in this idea and they immediately implemented a Hadoop cluster. So practically speaking, the entire data that Facebook was storing and analyzing, they moved into Hadoop. But what was the problem? Back in 2006, we were at Hadoop version 1, or the old Hadoop, or the original Hadoop. And you know what? The original Hadoop had only MapReduce. That means if you want to interact with the data in a Hadoop cluster, the only way was that you must write a MapReduce program. Right? You have to write a MapReduce program. This became a problem for Facebook because every day Facebook needed to fire 70,000 queries, SQL queries. The requirement of Facebook was that every day they had to fire 70,000 SQL queries on their data. And this was working when they were having Oracle. Even though it was slow, they were able to somehow manage, because Oracle is a typical RDBMS. You can easily write 70,000 queries. Now what happened? All of a sudden, the whole data is moved into Hadoop. No more Oracle. So the developers at Facebook faced a serious problem. The problem was that now the entire data is in Hadoop. And Hadoop doesn't understand SQL. Hadoop never understands SQL. What Hadoop understands? Hadoop understands MapReduce. And if you want to write a MapReduce program, you have to learn Java, you have to write your program, you have to compile it, create a jar file, deploy it. It's not easy. If you're a SQL developer, trust me, learning Java is not going to be so fun for you, right? Because SQL developers, we tend to be, more towards the SQL side of the spectrum. We don't really are not programmers, right? So all of a sudden, all the employees in Facebook started complaining. They said that till yesterday, our SQL queries were working on the data. Today, when I write a SQL query, I'm not able to run the query. What happened? So Facebook said, guys, we just moved everything into Hadoop. Well, that's not justice. That's not just, right? So in Hadoop, you cannot run SQL query, or you were not able to run SQL queries. Then what was the alternative? The alternative was to write a MapReduce program for a SQL query. And that's practically madness, because for a simple select count star query, you have to write 100 lines of code in Java and compile it. And imagine 70,000 queries. So what Facebook did is that they thought, all right, we need a solution for this. We have a lot of structured data in Hadoop, but unfortunately, our developers are not able to access the data. So what we can do? And thus, Hive was born. Hive was created by Facebook. Later, they donated Hive to Apache as a top-level project, but the first Hive version rolled out from Facebook. So the next big question, what exactly is Hive? Imagine you are storing some data in Hadoop, storing structured data. Let's say you're storing a data called sales.txt, a text file called sales.txt. Imagine. And imagine this text file has a structure like, comma separated values, imagine, so they're having order number, product ID, blah, blah, blah. It's a very big file actually. You store it in Hadoop. Now, if you want to analyze this file, you can write a MapReduce program. Or what you can do, you install Hive right? Now Hive will give you a shell or a command line. You write SQL on the Hive's command line, right? You say select count star from this table. You write a SQL on Hive's command line, hit return, meaning run the query. What Hive will do, it will convert your query into a MapReduce program, run it in the cluster, and show you the result. That is Hive. Hive is a SQL interface on Hadoop, and it is the default data warehousing framework on top of Apache Hadoop. So what is a data warehouse? A data warehouse is nothing, a huge storage with a SQL interface. Data warehouse is huge storage with SQL interface. Now you already have Hadoop, which is huge storage. You install Hive, you get a SQL interface. You practically create a data warehouse with zero investment. That is the advantage of Hive. Hive is free. You just install it. You can start writing SQL and you can access structured data using SQL. You can do all your regular operations, creation of tables, left outer join, right outer join, group by queries, blah, blah, blah. That is Hive. Now, what is the difference between Hive and HBase? Now, Hive is what we are seeing right now. HBase is your default NoSQL database on top of Hadoop. But remember, HBase is the default Apache NoSQL database on top of Hadoop, right? The real question is that why somebody should use Hive? You should use Hive. Say, for example, I don't want to learn Java. I don't want to learn MapReduce. I'm not a programmer. I know SQL. Then Hive is your choice because it just understands SQL and it will automatically convert that into MapReduce so that you don't have to sit and learn Java and MapReduce. You write your logic in SQL and it works. Imagine you have what you say an Android mobile phone, right? Now what happens is that in the Android mobile phone, when you're buying a mobile phone, obviously, right, you get a default, what you say, calling option, messaging option, etc. You can call people, you can text people, you can do a lot of things with an Android mobile phone. But you can also download apps. For example, if I want to catch a taxi, I will download and install Uber. If I want to check WhatsApp, I will download and install WhatsApp. Similarly, Hive is a tool which you have to install on top of Hadoop. So that is why it is called as an ecosystem tool. Ecosystem tool means tools which can be installed on top of Hadoop. Think about Hadoop like your Android operating system and Hive like Uber app you're installing on top of that, right? So Hive can talk to Hadoop. It gets installed on top of Hadoop. Point number one, right? Now, another point, where is Hive, right? So the first question is, where is Hive getting installed? Is it inside the cluster? Is it outside the cluster? Is it on top of my head? I don't know, right? Where are you installing Hive? So I have a Hadoop cluster, right? Now the point you have to understand is that Hive doesn't have any storage. Hive doesn't have any storage. For example, let's say you're copying a data. So I'm copying a data called, let's say, transaction dot XLS. It's a spreadsheet. I'm copying a file called transaction.xls. Now what happens in my Hadoop, this gets divided into blocks in data nodes. We are all familiar with this, right? When you copy the data, what happens? The data gets divided into blocks on my Hadoop, right? So in Hive, when you say create a table and load the data, Hive will refer to this data which is lying as blocks on your data nodes. It doesn't have its own storage. Very important point. So Hive is just giving you a projection of your data. Your original data is lying as blocks in data nodes. And when in Hive you say create a table, you're just giving a structure to the data so that you can see the data in the form of a table. Clear? So Hive doesn't use any storage, right? The second point you need to understand is that if I am sitting here, okay, and I have a laptop or a desktop, Hive is a client-side application. For the time being, I will explain more about this. meaning Hive gets installed on your laptop, not in the Hadoop cluster. Now there is a slight variation to this, but for the time being, let's assume like this. That means, and your laptop is obviously connected to the cluster. You will have Hadoop client libraries, so your laptop can access the Hadoop cluster. So Hive is a client-side application. That means you install Hive on your laptop, open the Hive shell, you will say create table, and you will give some schema, whatever schema you want. Okay, then you will say insert the data into the table. Now, what is this data you are inserting? This data is these blocks. That's what I'm saying. You are not inserting anything. When you say insert the data, Hive will just refer to these blocks in your Hadoop. And then you say, do a group by query or some SQL query. What Hive will do, it will generate the jar file, right, and send it to the Hadoop cluster. So for Hadoop, there is nothing called Hive. For Hadoop, it is just a MapReduce program. Let's understand that Hive is a client-side application. That means you install Hive on your laptop. And why are you installing Hive on your laptop? Because you don't know MapReduce. And you are a SQL developer. And you know that there is structured data in Hadoop. You want to create a table out of the data and do the queries. So you install Hive on your laptop, say create a table, load the data, write your query, hit enter. Hive will automatically write the equivalent MapReduce program, create a jar file, send it to the cluster. So from the point of view of the Hadoop cluster, it is a regular MapReduce program. It's not Hive. Hadoop doesn't understand Hive. Hadoop understands MapReduce. So either you can write MapReduce, create a jar, say run. Or you write in Hive, Hive is also going to create a jar and say run, same thing. That means Hive doesn't have its own storage or anything. It is just accessing the data in Hadoop and giving a projection. So that it is easy for you to work with. Now, you cannot work on blocks or data nodes and all. If you can see your whole data in a table, it's easy for you to write queries, right? And that is Hive giving you. It is giving you a projection of structured data stored in Hadoop. That's it. So Hive understands your SQL, even though Hive's language is called Hive Query Language, or we call it as HQL. It is pretty much similar to SQL. So that means if you're a SQL developer, you know SQL queries, you can easily start working on Hive. Introduction of Hive. Hive is a data warehouse infrastructure that is built on top of Hadoop. Hive provides a mechanism to project structure on the data using SQL-like language called HiveQL. Hive uses MapReduce and HDFS for processing and storage retrieval of data. Now that we understand, the data is in HDFS, processing is done by MapReduce. Now there is a small point here. It's not exactly MapReduce, right? But for the time being, let's keep it as MapReduce. The advantages of using Hive, it can be used as an ETL tool in the sense you can bring data to a Hive table, modify the data, store it as permanently. It provides capability of querying and analysis. So Hive is actually used by the analyst community who is very good at SQL, can handle large data sets, and you can do filters, join, group by, all these SQL queries on top of map and reduce. Now, if you ask me, can I see the MapReduce code created by Hive? No, you cannot see. So the MapReduce code created by Hive is not visible. You will just get a jar file. You won't even see the jar file. You will see the jar file running, right? Now, the most important point you have to remember is that Hive is expected to be slow. It is slow because ultimately it is MapReduce. It's not like your Oracle or MySQL or something, because in any RDBMS systems, typically when you write a query, you will expect the results within microsecond. In Hive, when you write a query, sometimes I have seen queries taking 4 hours, 5 hours. Why? Because, it's just an illusion. Where not to use Hive. So this is a very important point. Where you should not be using Hive. Hive should not be used if the data does not cross gigabytes. That means if you are not having big data, why are you using Hive? right? You can stick with your traditional tools. If we don't find schema or bringing in schema is difficult or not possible. Now the point is that when you access Hive, you have to create a table. Hive works on the concept of databases and tables, right? And whenever you're defining a table, the table should have a schema. Now, if your data cannot fit into the table, there is no point in loading the data. Let's say you're getting some type of data. Let's say you're getting text data, raw text data, right? Now, in that data, you're not able to find a structure to the data. Imagine, and I'm just saying you imagine. Imagine you're getting raw data, plain free-form text, right? So in free-form text data, how do you find a structure? You cannot find a structure. That means you cannot use Hive on top of that data. So you have to use Hive where you can find some structure to the data. Maybe you have comma separated values, space separated values, column separated values, something, or JSON files, XML files, even semi-structured data. They can all fit into Hive. Now the next case is if we need response in seconds and low latency applications. I told you Hive is expected to be slow. And if you are looking for a faster solution, don't use Hive. If RDBMS can solve, don't invest time in Hive. Very important point. Hive is not a replacement for RDBMS or something. Okay, because RDBMS systems are real-time systems and Hive is not something which can replace them. If your RDBMS can solve most of your problems, then don't use Hive. Hive is specifically for huge amount of structured data. Say you want to create a table, size of the table is 3 terabytes. Very good. Do it in Hive. Query the table. Your SQL will be very easy. Even though it takes some time, you will get the result. That is where your Hive's use case will come. So think about Hive like a translator. It's a translator. You write SQL, it speak MapReduce to Hadoop, right? And Hadoop gives the result, it shows as a table to you. So for you, the developer, everything is SQL and table. For Hadoop, everything is MapReduce, and Hive stands in the middle. Now, what is the similarity with SQL and difference from SQL? Hive is very similar to SQL-like queries. It is based on actually SQL 92 framework, and it is safe to say that its functions are mostly same. What is the difference from SQL? The major difference is that Hive query executes on Hadoop rather than traditional database. That means you cannot install Hive outside Hadoop. It works only on HDFS. This allows Hive to scale to handle huge data sets, which cannot be done by RDBMS. The internal execution of a Hive query is via a series of automatically generated MapReduce jobs. Right? So the next question naturally you will have is that, oh, I understand Hive, but can I fine tune Hive? What about performance? Can I improve the performance? Can I do something with Hive? Yes, you can do. Now all Hive queries will be converted to MapReduce job. So why can't we write MapReduce ourselves? So this is one question people ask. See, Hive is converting everything into MapReduce. So why don't you just write MapReduce for God's sake, right? Why are you using Hive? Understanding the internals of Hadoop framework is must to write MapReduce. SQL engineers can quickly write Hive scripts. Now, if you want to write MapReduce, right, you have to learn Java or Python or Ruby or C#, right? Then you have to implement your logic or using MapReduce framework. You have to write your custom mapper, custom reducer, package it as a jar file, resolve all the complexities, errors. Now here, you don't have to do any debugging, anything. Create a table, write your query, and it just works. That is how it works. So the next point is that now talking about the real world. Okay, so let's suppose you learn Hive in our Intellipaat course and you master Hive. And what did I teach you? I taught you that Hive is a SQL interface to Hadoop. Fine, you understand that, right? And then you go to a real world project, okay? And then you go to the project and say that, you know what, I'm an expert in Hive. An expert in Hive. I know Hive really well. You want to say to your project. And these guys are gonna tell you that, you know what, you can use Hive, or you can use Hive plus this, you can use Impala, you can use Spark SQL, you can use Phoenix. What did I just do? I just blew your mind out of proportion. So when you go to a real project, in a real world project, and you ask them, okay, I have data on Hadoop, give me a SQL tool, they will either give you Hive, or give you Hive plus this, or give you Impala, or give you Spark SQL, or give you Phoenix. And you are like, oh my God, there is only Hive that is a SQL interface. Now I am in a dilemma because these guys are talking about this, Impala, Spark SQL, Phoenix. And trust me, if you write a SQL query, it will be executed the same way in all these platforms. You write a group by query, Hive will execute it, Hive plus Thais will execute it, Impala will execute it, Spark SQL will execute it, Phoenix will also execute it. So the real question is, what are these different tools? Right? So this is some real world info to you guys, right? See, Hive is the original tool. This came first, right? So Hive is the first Avenger. So this is the first Avenger. So this is the first guy who came into the world, right? So when Hive came, everybody was happy. So people said, all right, fantastic. Now I got SQL interface. I can write a query, and you know what? The query executes nice. But over a period of time, people didn't really like Hive. People said like, all right, Hive is great. But the problem is that the queries are damn slow. You know, the other day I wrote a query, it took a day to give me the result. I don't really like Hive. We need something else. That is when the company called Hortonworks started proposing Hive and Thais. Now what happens here is that if you access a Hortonworks Hadoop cluster, and you write a Hive query, say execute, the Hive query will be converted into Thais, not MapReduce. So original Hive is Hive plus MapReduce. Hortonworks Hive is Hive plus Thais. So what is Thais? Thais is a framework, Apache framework. Probably if you're interested, you dig deeper. Well, Thais is created to make MapReduce faster. So I don't want to get into details of Thais. I'm just giving you some extra information. For the time being, understand that Thais is a framework which is built to overcome the problems in MapReduce. MapReduce is ideally slow. MapReduce is normally slow, right? So some guys built something called Thais, and Thais also uses mappers and reducers and all, but Thais is much faster than your MapReduce, right? So Thais is a Hindi word. It stands for speed, and it is created by Indians. It is the next level of MapReduce, you can say. So what Hortonworks did, they said, see, what Hortonworks did, they said, why don't we club Hive and Thais so that queries are faster? Are you getting the point? So if you are on a Hortonworks cluster, you write a Hive query, say execute, you will see a Thais job firing. You will never see a MapReduce job firing because Hortonworks promotes Thais. Even though Thais is Apache open source, Hortonworks says they promote Thais, and they say that's their queries are faster. So your first Avenger, original Hive, is damn slow. Now Hive plus Thais, this guy is interactive. Interactive query means it is faster but not real time. So if you are writing a Hive query on a Hortonworks cluster, it uses Thais as an execution engine, and it is faster, but it's not real time or something. It's kind of like faster. So when Hortonworks started this, even before that, there is another company called Cloudera. There is a company called Cloudera. Cloudera, what they did, They invented something called Impala. Impala is again built on top of Hive. Impala is a SQL interface, but what happens if you write a SQL query on top of Impala, it will run it using a daemon called Impala D. It doesn't use MapReduce, it doesn't use Thais, it uses a proprietary Impala D to run. So this is promoted by Cloudera, and this is also interactive. Now Hortonworks will say that Hive plus this is faster. Cloudera will say Impala is faster. That is a war going on for like past 4 years. Nobody knows. Both are same. But whether it is Hive plus this or Impala, it's again a SQL interface for you. Only difference, if you're on a Hortonworks cluster, the execution is done by Thais. If you're on a Cloudera cluster, execution is done by a daemon called Impala. And there is somebody called Spark. Spark has a SQL interface that's called Spark SQL. If you write a query on Spark SQL, again same SQL, this will be converted into Spark, and this is almost real time. So this is faster. Look at this, look at this. Hive Thais, SQL, Hive, Thais. But in Hortonworks, you can also say that I don't want Thais, I want MapReduce. They can switch the engine. So these are all additional information, extra information, but good to know things, right? So Phoenix is SQL interface on top of NoSQL. That means HBase is your NoSQL database, right? And HBase doesn't understand SQL. So if you do not know the language of HBase, you install Phoenix, you write your SQL query, it's going to convert in the language of HBase, show you the result. Original Hive plus MapReduce is batch processing, very, very slow. Thais and Impala are similar, interactive, but Thais is Hortonworks, Impala is Cloudera. That means you will never see Thais on Cloudera and Impala on Hortonworks. Spark SQL is again on Spark Framework. Phoenix is on HBase. Difference between different Hive. For example, you have something called Hive. Then you have something called Hive Server 1. Then you have something called Hive Server 2 plus Beeline. So what are these terms? What is pure Hive? What do you mean by Hive Server 1? What do you mean by Hive Server 2 plus Beeline? See, so this is something which you have to understand from the technical point of view. Originally, only Hive was there. And this is just a client-side application with an interactive shell, meaning the original Hive, what you call the pure Hive, is just a client-side application. That means if you are a developer, you take your laptop, install Hive, you get a command line. In the command line, you say create a table, drop a table, do the query, blah, blah, blah. It just works. There is no server, only client. And that is what I was explaining in my picture also, right? I drew a picture where I was telling you that, Hive is just a client-side application.
Just a quick info, guys. Check your knowledge of Hadoop by answering this question. Which of the following are the core components of a Hadoop? A. HDFS, B. MapReduce, C. HBase, D. Both A and B. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So when Hive was invented, people were really happy. They said, oh my God, that's really great. So we can get a shell and we can write commands and we can work with Hive. That is nice. But later, people started thinking, so how do you connect your database? Can you tell me? You have an Oracle database. The Oracle database is sitting in some place. How do you connect with the Oracle database or Microsoft SQL database? What do you use to connect? You need a client-side tool, something like MySQL Workbench or something, right? You need a client-side tool to connect using JDBC or ODBC, right? JDBC, ODBC connections can be made, but for that, yeah, you will have a server where Oracle is running. You need an Oracle client, some SQL client, right? So what people thought is like, okay, everything is nice about Hive, but I cannot connect to Hive from my SQL clients. Why? Because Hive was just a command line. Look at here. That is when Hive Server 1 came. This guy will allow JDBC or ODBC connections from your regular SQL clients. That means Hive Server 1 means there will be a server running in a Hadoop cluster. Clear? Hive Server 1 is a server which is running in the Hadoop cluster. You in your laptop, if you install Hive, you can open the command prompt and type queries, or you can use your regular SQL client tools to connect to the Hive server and perform all the activities, right? So Hive Server 1, the option is that you can create JDBC connections from your SQL client directly to Hive. So you can insert into a table, you can do whatever queries you want, you can directly run in your client. Very easy. You don't have to use a command prompt. You can use a command prompt also. So people were really happy. Hey, great, we have Hive server, we can connect, we can run queries, blah, blah, blah. But this lacked concurrency, meaning there was no concurrency or consistency in Hive server 1. That means if multiple users create sessions to Hive, it was impossible to handle the sessions. Data persistence, data concurrency issues were there. That is where Hive Server 2 came. Hive Server 2, first of all, it also allows your JDBC, ODBC connections. It provides concurrency, and it has a new client-side command line tool called Beeline. That is Hive Server 2. So Hive Server 2 is kind of like an upgrade to Hive Server 1. The basic difference is that it also allows JDBC, ODBC, but it provides concurrency. That means multiple JDBC, ODBC connections are possible. You can work with Hive, but they have redesigned the CLI of Hive, and the new CLI is called Beeline. Still, it supports the old CLI, and the new CLI is called Beeline. Beeline is actually a client which you can install, like SQL client. So I can go to a computer, install Beeline client. From there, I can make a connection request to the Hive Server 2 and start working in the Hive. So the Hive server will be installed inside your cluster. The architecture of Hive. Now you can see a person, okay, and he is using the Hive query language. Now you can, if you are a person, either you can interact with Hive through CLI. That is what I'm saying. CLI means it can be the Beeline client or regular command line, Hive shell. I will show you the Hive shell. It's an interactive shell. Or JDBC, ODBC. That means you are having a SQL client. From there you can connect. Or a web UI. Hive also provides a web UI. And whatever ways, look at the arrow. If you are using the CLI, directly you will be hitting Hive. That means hitting Hive in the sense, if you're using the CLI, you will be directly creating tables, etc., etc. But if you are using the JDBC, ODBC, these sessions are handled by Hive Server 2. So we are having Hive Server 2. So the main purpose of Hive Server 2 is to handle this multiple sessions that are created by users through JDBC, ODBC. That is why there is a difference in the arrow. CLI means you are directly invoking Hive. JDBC, ODBC means you're connecting through the Hive server. So either you use CLI or you use JDBC, ODBC. Now, where will I install Hive Server 2? It is not necessary that you have to install it inside a Hadoop cluster, right? It can be outside the Hadoop cluster also. See this picture? Your Hive Server 2 is outside the Hadoop cluster in this picture. Now, so like I explained, if you use CLI, directly it is Hive. If you use JDBC, ODBC, it goes through Hive Server. But again, the sessions are handled by Hive Server, but it is ultimately Hive, right? Now, in the picture, it is very clearly shown that the Hadoop cluster is separate. That means Hive Server need not be installed inside a Hadoop cluster. It can be outside. In most of the cases, it is installed outside as well, right? Now, inside the Hive architecture, you can see compiler, optimizer, executor. But how does Hive know where is the data? Or in other words, what about metadata? See, for any database or data warehouse or any system, you need to store metadata. What about the metadata? So in Hive, what happens? There is something called Metastore service. What is Metastore service? It is a service running to handle metadata. What is metadata? The definition of your table, the definition of your database, the schema of your table, all this is metadata. So you need to store the metadata somewhere, right? So that is what is handled by this Metastore service. By default, Hive uses something called embedded Metastore. This means it stores the metadata in built-in Derby database. So what happens is that by default, if you are downloading and installing Hive, it comes with a database called Derby. Apache Derby. Apache Derby is a database, and it will use this Derby database to store the metadata. Clear? So that is called embedded Metastore. Embedded Metastore means by default, if you just download and install Hive, Hive will need some place to store the metadata.
Just a quick info, guys. Intellipaat provides online big data Hadoop training in partnership with IBM. The course link of which is given in the description below. Now, let's continue with the session.
So it by default comes with this Apache Derby database, and it starts using Derby to store the metadata. You don't have to do anything. It will be all configured. Okay, so this embedded Metastore is good because you're saying that if I'm downloading and installing Hive, right, it will come with a database and it will store the metadata in the database. This is all good. But this Derby has a drawback. The Derby database is a single instance database. That means it will allow only one connection at a time. That means if you are using the embedded Metastore of Hive, only one person can access Hive. So that is a drawback. So what you can do is that you can configure your own database as metadata storage for Hive. Example, MySQL. So this is what we do in production. Meaning in production, what we do is that we will download and install Hive. Now we know that Hive will start working automatically because it will use Derby to store the metadata. But when it is using Derby to store the metadata, right, what happens is that it will allow only one connection at a time. Because Derby will allow only one connection. So we don't do that. What we do is that we will configure something like MySQL and ask Hive to store the metadata in MySQL so that multiple people can access Hive. The latest version of Hive allows updates, but All other versions of Hive by default does not allow updates, because remember, it is Hadoop. Hadoop is a write once, read many system. In Hadoop, there is no update process, right? You copy the data, you delete the data, you again copy the data. It is all writing the data and reading many times. But the latest version of Hive allows you to do that. It selectively can update it. Okay, it can refer to the position of the block in the data node. So Hive can by default talk to Hadoop. It can understand where is your data, and accordingly it can do. So what you need to understand is that if you are practicing Hive on the Cloudera VM, if you are practicing Hive on the Cloudera VM, you are using embedded metastore. That means there is a Derby inside, and that is storing all your metadata. Very simple. But if you go to a company and start working on Hive, right, then the metadata will be stored in a separate database like MySQL. That is the difference. So two types of metadata storages are possible. So if a user write a query, the query will be accepted by somebody called a driver. The driver is not shown in the picture, but there is a driver. And the driver will pass it to somebody called compiler. Compiler will check with the metastore to get the metadata and compile your query. Then optimizer will optimize it and give to executor. Executor is your MapReduce, and MapReduce will run your query in the cluster. So step number 1, user writes the query, and the query comes to Hive. Okay, and first step is compiling the query. Now you won't simply compile the query because you need the metadata. So you will check with the metadata store about the metadata. Once you get the metadata, you compile the query, and there is a component called optimizer. It will optimize your MapReduce code so that it can perform better, and then give it to another component called executor. Executor is normally your MapReduce program. I mean MapReduce engine, and that will execute your query and show the result. There are two situations. Okay, again, this is coming mostly from the practical aspect. If you're having a small Hadoop cluster, let's say you're having only 3 servers, I mean 3 data nodes, 4 data nodes, etc. And so it's a very small cluster, right? And normally this cluster will be accessed by only a couple of guys. So if you're sitting here, you have a computer, entire Hive will be installed here. Your Hive server will be running, everything will be running here. Why? Because it's a small cluster. There is no point in installing here and then connecting. You can install Hive, but usually, so I'm talking different use cases. I'm talking different use cases. In small Hadoop clusters, where you're having 3 to 4 data nodes and all, you will not do any heavy lifting. Why are you creating small Hadoop clusters? It might be for proof of concept. You're not actually running any production workload. So that means in this case, there is no Hive component in the Hadoop cluster. Entire Hive package is on your machine. Hive server, Hive CLI, whatever you call, anything starting with Hive is on your computer. Nothing is there in the cluster. Are you getting my point? Why? Why? Because either you or only your friend will be accessing this. And you don't need a separate client server and all, right? Because it's a very small cluster. So you install all the package on your computer, and then you can also install SQL client on your computer and create a JDBC connection. From here it will connect, etc., etc. But everything will be on your computer because it is a small Hadoop cluster. Now, what if it is a very big Hadoop cluster? In a very large Hadoop cluster, so this is a large Hadoop cluster, say thousands of data nodes. You will have something called a gateway node. Have you guys heard about this? What is a gateway node? Have you guys heard about this? No, I think. What is a gateway node? This guy will have connectivity with Hadoop. And it's a Linux machine. Imagine it's a Linux machine. Here, you will install everything. You will have your Hadoop client here. You will be having your, Hive server here, and maybe Pig. Everything will be installed here. And what you do is that if you're sitting here, if you're sitting here, right, you have a laptop. You don't install here. Maybe on your laptop, this is your laptop, right? So this guy is sitting here. This guy is sitting here. What he can do is that he can do multiple things. He can SSH to this machine, connect to this machine. So he log into this machine, and from here he can type Hive. He get a command prompt, start working on the cluster. Now another guy is sitting here. He has a laptop, okay, and here he has installed, let's say, SQL workbench, SQL client. Now, if you open the SQL workbench, it will connect to this, and from here it will connect to this, right? So what is the gateway node? Gateway node is nothing but is a server, okay? It acts like an intermediate between you and Hadoop cluster. In large Hadoop clusters, you will not be directly logging onto the cluster. You will never even see your cluster. It is strictly prohibited. You cannot access your cluster. All you do is that you connect to this gateway node. From here, you can do anything. So if you prefer the CLI, what you do is that you log on to this gateway node using SSH. From there, you are on the gateway node. You type Hive CLI, you get Hive CLI. Or if you're having a SQL client, okay, you give the details of this gateway, and this will connect to the gateway. From there, it will connect to the large cluster. Right? So all the client packages are actually installed in the gateway node. That is my point. So you have two options. Either you log on to the gateway node. So now you log into the gateway node and open the command prompt and say hit Hive, you will see the Hive shell. You start working. Or if you're having a SQL workbench, your Hive server will be running on this gateway node. Okay, SQL workbench will connect to Hive server and to your cluster. Interface of Hive. Just type Hive and hit enter. And this is the Hive shell. So this is the command line interface of Hive, the interactive shell of Hive. What you see is Hive shell. Now, once you are in the Hive shell, most of the commands that you type need no introduction because the commands are SQL commands, and most of you are familiar with SQL, right? For example, I can say first command probably, if you log on to any of these systems, the first command you will probably type is show databases. You can see all the databases that got created. Now, the best way to understand Hive is to start working with Hive. So what I'm going to do, I'm going to say create database, let's say Dell, and if I do a show databases, it will be there. There is a database called Dell. Now, if you want to use it, just say use Dell. So when you say use Dell, the database has changed. So now you're using the database called Dell. Fine. So far, so good. Now, these are regular things, right? Now, let's take a sample scenario and see how we can use Hive to solve a problem. Rather than just speaking about Hive, right? Let's take a sample scenario. So let me show you the data that I'll be working with. Yeah, so on my desktop, I have a file called transactions. Can you see this file? It is called txns1. It's a transaction data. If I open this file, this is how the data looks like. Just to give you an idea, right? Now, if I have to explain this data, let's pick one record. So this is one record so that I can explain to you. As you can see, every record is comma separated values. So this has some structure. The first column, so this is a transaction data from a sports store or a retail store. So first column is transaction ID. which is 4. Then you have date of transaction, 17th December 2011. Then you have something called customer ID, 4002613. That is the customer ID or the customer number. Then the amount spent, which is $98.81. And then the category, team sports, the item, field hockey, city, Nashville, and the state of Tennessee, it's a credit transaction. So this is how your transaction data looks like, line by line. Multiple customers have purchased items from a sports store. That's it. So it's a very big data actually. I mean, there are a lot of lines in this data, right? So this is one file. Now, I also have another file here called customers. So if I open this file, this is my customer data. For example, if I pick one line or one record at a time, first column is customer ID, okay, which is 400015. Then you have first name and last name, Julia Desai, aged 49, profession is musician. So we are having two set of data. One data is the transaction done by the customers. The second data is the data about the customer. Their name, customer ID, age, and profession. So I'm having two set of data. And as you can see, the customer ID is common in both the data set, right? Now what I want to do is, I want to analyze this data. What sort of an analysis? What I practically want to do is that I want to understand how much money is spent by youngsters in my store and how much total amount is spent by middle-aged people in my store and how much amount is spent by old-aged people at my store. So basically, I want to classify the customers into 3 groups, say 20 to 30, one group, 30 to 50, another group, 50 above, another group, and I want to calculate the sum of amount spent by them. I want to use Hive for this. So let's look at how we can do this. So as a first step, what I'm going to do is that I'm going to create a table. This is the syntax to create a table. And this should not be a surprise to you if you already know SQL. I'm saying create table called, this is my table name, transaction records. And this is my schema. Very simple. Transaction number, date, customer number, amount, category, product, city, state, spent by. And Hive imposes schema, which is very similar to, and the data types and all are very similar to what you deal in day-to-day life. Like it supports in, string, double, float, everything almost, right? So I have given the schema to my data, right? Then I say row format. I am expecting my data in row format. That means by default, Hive will identify a row and using new line character, it is going to separate every record. Delimited fields terminated by comma, meaning my individual fields are comma separated. If you give semicolon here, your input data should be having semicolon. Then I say stored as text file. By default, Hive stores the data as text file. Now you can say sequence file or any other format also if you want, but if you don't type text file also, it is going to store it as text file. This is the for syntax. If I hit enter, Hive says OK, which proves the data is created, right? I mean the table has been created. Now the next point, I have the table. How do I load the data to the table? Now there are multiple ways to load the data to a Hive table. I'm going to first show you the common way. That is what everybody does. So where is the data? The data is on the desktop of my Linux machine. I mean, the data is in my local file system. So what you can do is load data local in path.
Just a quick info, guys. Test your knowledge of big data by answering this question. Which of the following are incorrect big data technology? A. Apache Hadoop. B. Apache Spark. C. Apache Kafka. D. Apache PyTorch. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
/home Cloudera. So this is the path. Desktop. Into table px. That is how you load the data. You can actually do insert, right? But typically in data warehousing, you get bulk data to load. So you will be getting huge amount of tables and text files which you want to load it into this place. So usually you will not say insert. Usually you will dump the data like this. So what I'm saying load data local in path. This means my data is in my local file system, and this is the path of my data into the table transaction records. That's it. So now if I do a select star from the table, say limit of 20 or something, I should be able to see the data. See, I'm able to see the data because I have loaded the data to the table, right? So now the data is also in the table, but what is happening in Hadoop? Behind the scenes, what is happening? That is one question, right? I will show you what is happening behind the scenes. Whenever you install Hive on any platform, what Hive does is that it will create a folder called warehouse in HDFS. So if I do an HDFS DFS-ls, you see this? Whenever you install Hive, Hive will automatically create this folder called warehouse in Hadoop or HDFS. The folder name is warehouse. Now, if you check what is inside this warehouse folder, you see all the databases you have created. So this is our database, del.db, right? So whatever databases you are creating is actually stored inside this warehouse directory. Whenever you create a database, okay, the database gets created in this path, user hive warehouse, and then the DB, what you create. Now, the DB is just a folder in Hadoop. DB is just a folder in Hadoop. Hue is a web interface to your Hadoop, nothing else. So in Hue, I can just go to browser and I can just see, rather than typing HDFS, DFS, I can just come here and see what is the files in Hadoop. When you install Hive, it creates a folder called warehouse. So this is the warehouse folder, right? Can you see the warehouse folder? So it creates a folder called warehouse. Inside this warehouse folder, if you open this warehouse folder, you can see all the databases you have created. So this database called del.db is nothing but a folder in Hadoop. You created a database and you think it is a database. It's not a database, it's just a folder. See del.db. If I open this folder, what you see? Another folder called transaction records. The transaction records table you created is just a folder. And if I open this, can you tell me what you see here? The file that I copied. So look at the table structure. Look at here. Your database del.db is just a folder. Transaction records is another folder. Inside that you have the file. This is what is happening in Hadoop. So when you are loading the data into a Hive table, it is just copying the data from Linux to this folder in Hadoop. Is this clear to you or not? Of course, you use a command load data local in path, but what is happening behind the scenes is that the data that you are inserting into the table is just copied into this location in HDFS. And if this data was very big, it will be divided into blocks and all, just like regular Hadoop file. This is where your data gets stored. So I can also show this from command line. So if I do warehouse, then del.db, what will I see? I see another folder called transaction records. And if I again say txn records, I will see the file. So that is why I'm saying Hive is just giving you a projection. The actual data is just lying in Hadoop, right? Now what I will do is that, okay, I will create one more table because we have the customer data to be stored. I will say create a table called customer, and this is having customer number, first name, last name, etc. So another table, and we will load the data. So the data is into the table called customer. Right? So now the data is loaded into customer, but you will be wondering, so far I have not seen any MapReduce program, right? So I was telling you that if you query the data, you will see the MapReduce job and all, but so far I have not seen anything because you have not actually ran a query. So let's say select count star from transaction records. So this is a proper query. So I'm doing a select count star from the table. So basically I want to know how many rows are there. If I hit enter, it's going to fire a MapReduce job. Can you see this? Because it's a proper query, it cannot just show the result. It's going to launch a job and create a jar file. And here is the result, 50,000. So the answer is 50,000. The result of the query is 50,000. How did I do it? I just wrote my query and hit enter in Hive, and it automatically launches an equivalent MapReduce job to show me the result. And I get the result here. Now let's analyze this further. So what I want to do is that I'll be creating one more table. So I'm going to create a table called out1. Okay, this table has customer number, first name, age, profession, amount, and product. So basically my idea is to do a join operation. I have a customer data, I have a transaction data. Both the data has a common column called customer ID. So my idea is to do a join operation, a simple inner join operation. And the results of the join operation has to be stored on a table. So I have created a table already. So this table is called out1. And how do you do a join operation in Hive? Very simple. Insert overwrite table out1. So out1 is the new table we have created. Select a.customer, a.first name, a.age. So if you look at the syntax of the join operation, it is exactly same as your normal SQL join operation, right? If I hit enter, it's going to launch a MapReduce job. So now the join is over, and if I do a select star from out1, this is the result of our join. And if I do a limit of 20 or something, see, this is the result of the new table. In the new table, if you see, this is the result of the join operation. So you see, you have customer related data and transaction related data. This is very simple, okay? I'm just following the same logic of SQL. Only difference here is that, it is converting it into MapReduce job, right? Now what I can do is that after this, I will create one more table. I'm creating a table called out2. Now what I want to do is, see, now I have done the join operation, but I want to classify my customers, right? My customers are having different age. So I'm having a column called age, and I want to classify my customers. How can I do that? Very simple. If you look at here, insert overwrite table out2. That means the result will be in this table, which we created in the last step. Select star comma case. You see, I'm opening a case here. And what is the case? When age is less than 30, then it will be marked as low. When age is between 30 and 50, middle. Greater than 50, old, else others, end. So what this query will do, it will pick all the rows from my previous table, look at the age column, and based on my criteria, it will mark every record as low, middle, old. You hit enter, it's going to fire a MapReduce job again. So every query will fire a MapReduce job. You don't have to worry about that. So you can see the map 0, reduce 0, etc. And now it's over. So if I do now the query is over. If I do a select star from out2, if I do a limit of 20 or something, you see every record is now having a category: old, middle, old, etc. Right? So now I am able to classify the customers. Now all I need to do is very simple. I will create one more table. I will do a group by query. So what I'm doing here is very simple, guys. I'm saying insert override table out3. So out3 is the latest table I have created. Select level. So the level column will have low, middle, that age classification. Sum of amount from out2, group by level. So it's a very simple group by query. The result of this query will have your final answer. So the table name is out3. And the query is over. If I do a select star from that, I will have the final answer. See, this is your final answer. So the youngsters are spending this much amount, middle-aged people are spending this much amount, old-aged people are spending this much amount. So this is how you start working on Hive. There are two types of tables in Hive. There is something called managed table. There is something called external table. And by default, any table that you create is a managed table. So I will tell you what is the difference, okay? But there are two types of tables in Hive which you can create. I mean, two types of tables. There is something called managed table and there is something called external table. Now, what are these things? By default, any table you create is called a managed table. So what is that? How do you know that? If you go to Hive, you can say show tables. And we have a table called transaction records. If I say describe formatted txn records, if I type this command, describe the table, it says it's a managed table. table type is managed, and look at the location of the table. Managed table means the table is managed by Hive. That means this table is stored under user Hive warehouse, and you cannot change that as well. That is called a managed table. So if that is managed table, what is an external table? In Hive, I can say, what I can do is this. I can say create external table. So when you want to create an external table, I will tell you what is an external table. You have to say create external table. Well, the syntax is not correct. Let me add one more thing. Location / user / Cloudera / user Cloudera. I think it is user Cloudera. Then I can say my customer, something like this. Okay, let me type this first, then you will understand. Yeah, so this is the proper syntax, guys. So what am I doing here? I'm saying create external table. So whenever you're creating an external table, you have to specifically mention that it is an external table. Otherwise, you just say create table, it's going to be a managed table. So I say create external table, and this is the table name. And if you look at the schema and row formats, they are all same. There is no difference in the schema or the format or anything. Only difference, I'm saying location user Cloudera my customer, meaning this is the location in Hadoop. How do you know that? So once you create this table, if you go to your Hue, you go to user Cloudera, there is a table created called my customer. Can you see this? This table is just created and there is no data inside this. Now what is the advantage is that, so now I created a external table. If I do a select star from this table, TXN records 2, there is no data because I just created a table. I didn't fill it with data. If you want to fill it with data, all you need to do is very simple. Go to the folder mentioned in the external table, that is my customer, copy the data to that folder. Now I just uploaded this data to this my customer folder. Can you see this? In the my customer folder in Hadoop, I just uploaded this data. Now if I come back here, again I do a select star, do a limit of 20, I have the data. So what is the difference between a managed table and external table? In managed table, which is the default table by the way, when you create a table, the table is always created in user Hive warehouse, that location. And then you manually load the data to the table. External table means when you create an external table, you are mentioning the location of your data. Look at this line. You say that the data will come from this folder, and whatever data you dump in this folder will be visible in your table. Very simple. What exactly is the difference between a managed table and an external table? Is the difference only the location? Yes, the difference is only location, but the real question is, where will you be using a managed table and where will you be using the external table? Now I can show you practically. Have a look at here, guys. Now, if I do a show tables, there is a table called transaction records. This is a managed table. I can say drop table TXN records. So what am I doing? I'm dropping the table called transaction records. That's a managed table. What will happen to the data in this managed table? It will be deleted. Why it will be deleted? Because when you drop a table, that folder is deleted from Hadoop. Remember the folder structure. The data is inside that, right? So that means if you drop a managed table, the data is gone. But if I do a drop table TXN records 2, that is an external table, the table is gone, but Cloudera and the folder is my customer, the data remains there. This is the difference. This is the difference. If you drop a managed table, the table goes, the data also goes. If you drop an external table, only the table goes, the data remains the same. So if you want to share your table with others, let's say you're working in a project, okay, you create a table and you think that you want to share the table with others, and you suspect accidentally somebody may delete your table, create an external table, because if somebody accidentally drop your table, still your data will be safe. Otherwise, create a managed table. How to use how to use a Beeline. So Beeline is the new CLI, and by default, if you are using Cloudera VM, it will have Hive Server 2 running, and the default port number it is 10,000. You can check the documentation to ensure that. Now, if you want to connect with Beeline, all you need to do is you have to start Beeline first. Okay. This is how you start Beeline. You will say user live hive bin Beeline. Basically, this is a location where Beeline is installed. It may differ in different distributions, but in Cloudera Hadoop, it is always right. So now you see the Beeline CLI, but here if I say show tables, it's going to throw an error. When I say show tables in Beeline, it's going to throw an error. It says no connection. Remember, Beeline is a client. It need to connect with Hive server. Beeline is a client. Now you see the difference, right? When I'm opening Hive, if I just hit Hive, I am accessing the Hive entire package. It's not a client only. But when I say Beeline, it's a client. So in Beeline, when I say show table, it says no connection. I can't connect to the server. If you want to connect to the server, what you need to do is this, guys. This is the connection string. You can use the same in your JDBC or ODBC or whatever you have. This is your connection string. Connect JDBC Hive 2. Hive 2 stands for Hive server, right? Localhost, that's the port number. Username, password by default, nothing because I'm running locally, and JDBC Hive driver. So it will connect, right? So now I am inside this. Right now, if I say show tables, show databases, it will list all the databases. So this is how you start Beeline. So you will say user lib hive Beeline. So that will start Beeline. Beeline is your client. And when you say show tables, it won't show anything because it need a server connectivity. And this is the connection string. So you will say connect with JDBC Hive server 2, localhost running in localhost, and the port number, username, password, hit enter, it will connect. Okay. Once it is connected, you can type your regular commands. So I am typing, where is the command? Where is the command? Show databases. So this is the command I type, and here is the list of the databases. And the command line is pretty much similar to your Hive CLI. So this is how you start working on Beeline. This is Beeline. Okay. Now, if you want to quit Beeline, just say exclamatory mark Q. This is the command to quit. Very important. Exclamatory mark Q will quit Beeline. So now I am back. Right. So that is how you connect from Beeline client to Hive server 2. You can also download Beeline client on your desktop or something and make a connection to the Hive server. Now, if you don't want to type all the commands and all, you hate the commands of creating a table and all, what you can do is come to Hue. Okay, then what I'm going to do is that let me show you the data I'll be working on. Here, okay, there is a data called healthcare sample data. Now this has patient ID, patient name, patient mobile number, date of birth, hospital data, email address, social security number, the disease, diabetes, fever, cold, blah, blah, blah. So this is a sample data that I'm using. What if I want to upload this data into Hive and query the data? Basically, I want to get a list of all the people who are having cold. So if I want to do that, you can of course use the command line, but you can also use the GUI. Let me show you that. Go to Hue, go to this data browsers. There is something called Metastore table. Click on this. Once you click on Metastore table, okay, it will allow you to select the database. So I'm going to select our database. I can select this database. I can say create a table from a file. I can give a table name, test table. Okay. And then I can say select the file from where you want to create a table. So which is this healthcare data. Say next. It's going to automatically look at the data. It will ask you, hey, is this how your data looks like? Yes. I will say next. And it is also automatically going to select the data type. I'm going to say create table. So this will create a table from the file that I have uploaded to Hadoop. No need to type any statement or anything. Right? So going to create a table. Now once the table is created, you can query the table from the GUI. You don't have to use CLI. Let me show you that. What you can do is you can go to this query editors. There is something called Hive. Can you see here? You can go to Hive. In Hive, you have to use the database. I have a database called test table. I can select this table, right? So there's a table. So I can say select star from test table where column number 7 equals cold, and then execute the query. So this will run the query in the GUI and show me the result. Can you see this? Right? And I can create nice charts and all if I want. Right? I can create like, charts and all. See, stacks and groups and everything I can create if I want. Basically, what I'm telling you is that you can run queries from the GUI also.
Just a quick info, guys. Intellipaat provides online big data Hadoop training in partnership with IBM. The course link of which is given in the description below. Now, let's continue with the session.
Partitions in Hive. So what exactly is partitions in Hive, and why are we doing this, right? What's the idea behind partitions in Hive and what we are supposed to do? So just imagine that you are working in a project which uses Hive. Okay, so you are in a project which uses, of course, Apache Hive, and you're happy you're working on Hive and everything is going fine. Now what happens is that, let's imagine that your manager comes to you and say that, hey, Raghu, do one thing, create a table for me in your Hive in which I want to upload all my sales data. So what I did, I created a table, create table, sales data. I created a table called sales data because my manager says he has to upload some data related to sales. So I created a table called sales data with some schema, some columns and all, whatever we have. Now Imagine you are working on a managed table. So for the time being, we assume that we are on a managed table, and by default, what happens is that if you create this table, the table will be stored in user, Hive, warehouse, and let's say our database is called newdb/sales data. If you create a table called sales data, this will be the location by default. So this is the basic stuff, right? So whenever you're creating a managed table, the table's location will be this. Now what happened is that your manager told you that, hey Raghu, do one thing. I have some data. Why don't you load the data to the table? So your manager gives you a file and asks you to load that into the sales data table. No big deal, because usually you know how to load the data. You will say load data local in path and then load the data. When you loaded the data, so the manager says, hey, this is January month data. So you loaded a file called january.txt. Very simple. I have created a table called sales data. I have loaded a file called january.txt. This contains all the sales transactions in the month of January. Very simple. So you are happy. Your manager is also happy, right? Yeah. So then what happened is that, you keep on working in the project, and the next month your manager comes to you and say that, hey Raghu, we have some more data, so this data is from the month of February. Why don't you load the data to the table? So you end up having, so now the file is february.txt because this is the February month data. However, since this is getting loaded into the same table, this will be the structure. Now inside the sales data folder, now you have two files, January and February, right? So probably I will write it like this so that it's easy for you to understand. I will say like this. And then your manager says, hey Raghu, I have some more data. I have some more data. March.txt comes. Then what happens? April.txt comes. Then what happens? May.txt comes. And June.txt comes. So what is happening here? Every month you are getting the data, right? Every month you are getting the data, and you're loading the data to the table because you have a table called sales data. But if you look at the way in which the data is stored, what you can see is that these all different files, January, February, March, April, May, June, all are inside the same folder called sales data because that is your table name, right? So, okay, so you might think that that's fine, but what is the problem? Now imagine, okay, you are writing a query like this, okay? Just imagine that you want to write a query something like this. Select star from sales data table where month equals, let's say, April. I'm just giving you an example, okay? So let's say you want to query the table. You want to query the table. So what is the query? You say select star from the table where month equals to April. Means you want to see all the data from April month. Now look at the problem you have. Hive by default doesn't know where is April month data. So what Hive will do, it will come to this folder called sales data. It will first scan this entire January.txt, then scan this entire February.txt, then March.txt, then April.txt, it finds some match, again May.txt, again June.txt. Meaning your entire data is scanned for this single query, and your queries will be really, really, really slow. So the problem we have is we have a table. So table in Hadoop is like a folder, right? And you keep on loading the data. Every time you load the data, it's going to store as a file. So that means inside a single file, now I have inside a single folder, now I'm having 6 files. January, February, March, April, May, June. And if you write a query, Hive doesn't know where is the data. It is going to scan all the 6 files. It is going to go through all the 6 files to show you the final result. And so you imagine you keep on adding files every month, data every month. If your table has, let's say, 100 different files, Hive has to scan this entire files before showing you the output of the query result. And obviously your queries will be really slow. So you are not actually saying where is the data. So that is a simple problem. And Hive has to scan the entire files to produce result. So ideally your queries will be slow. It will be really slow. So the question is, what can I do in such a situation? I don't want my queries to be slow. I want my queries to be faster. That is where your concept of partitions come into picture. So there is something called partitions in Hive. So what exactly is partitions? Partitions means you tell Hive to divide the data based on a column.
Just a quick info, guys. Check your knowledge of Hadoop by answering this question. Which of the following are the core components of a Hadoop? A. HDFS, B. MapReduce, C. HBase, D. Both A and B. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
What is a partition? You're telling Hive to divide your data or segregate your data based on a column. For example, what I can say here is that I can say, hey Hive, look at what I'm writing. Partition my table based on the month column. So this is what you can tell to Hive. So I can tell Hive, hey Hive, do one thing. Partition my table, okay, based on the month column. If you tell this, what Hive will do is that it is gonna look at, now once you write this, it is gonna look at the whole data first. Then it is gonna look at the month column in the whole data, right? Now obviously in your January.txt file, the month column will be what? January. What I will do, it will create a folder called Jan and place this file inside that. Accordingly, it's going to create something called Feb and place it here, and March, place it here, sorry, and April, place it here, May, place it here, June, place it here. So when you tell Hive that, hey Hive, I want to create partitions and I want to create partitions based on the month column, what Hive will do is that it's going to pick the column from the whole data and understand how many values are there. In my example, there are 6 months data. It's going to automatically create 6 folders: Jan, Feb, March, April, May, June. All the January month data will be copied into this folder. All the February month data will be copied into this folder, etc. So now if you write the same query, select star from sales data where month equal to April, Hive will scan only this folder because it knows April month data is inside a folder called APR. Your queries will be much faster. This is called partitioning in Hive. A partition is nothing, it is a division on your table actually. So when you are saying create partitions, what is happening is very simple. Based on the partition column, those many folders will be created, and whatever criteria matching with that folder, that data will be moved into that folder. Very simple. You have to understand one more thing. So I will show you the data maybe, so then it is easy for you to understand. This is the data that I will be using for partitioning. If you take one record of this data, you will understand what is this data. So let me show you what is the data first, and then I will explain what I'm going to do. First, let's analyze the data. Look at here. This is one record. This is one record. So first name Gerardo, last name Vodka, then 69206 Jackson Avenue, that is the address, Australia, that is the country, then the state, primary phone number, secondary phone number, email address, and website. That is the data. Now if I scroll down, let's say this data. Look at here, Angelicia Lovero, that is the name. The address is 689 S Steel Street, 1887 CA, California. I think California, right? And so then you have the other details. So basically, the data actually contains users' names. Okay, so I will just show you the last part of the data. Let me just show you the last part of the data. Yeah, this is US. So if you look at here, Gilma Luco and the address US, again for primary phone number, secondary phone number, email address, website. So that is the data that we are going to do. Now, there are two types of partitions. There is something called static partitioning. Static partitioning, and there is something called dynamic partitioning. Now, what is static partitioning? What is dynamic partitioning? In static partitioning, you have to manually create the partition and load the data. In dynamic partitioning, Hive will automatically detect your data and create the partition. So you will naturally think where this is applicable, because dynamic partitioning seems to be really good, because in dynamic partitioning, Hive is automatically going to create my partitions. Then why should I use static partitioning, right? So let's say you have a data like this, Raghu, comma, the phone number, and then you have email address. Then you also have Ram, something. Okay, ram@abc.com. Okay, now you also have some more data. Let's say Tina, some phone number, tina@abc.com. Now then you have Ajay. Okay, some phone number for Ajay, ajay@abc.com, comma. So let's suppose you are having this data. Now Raghu and Ram are in India, and Tina and Ajay are living in USA. But you do not have a strict column for India and USA in the data. See, in the data, all I have is name, then phone number, then email address, and website. I don't have a country. But I know that Raghu and Ram belong to India and Tina and Ajay belong to USA. In this case, what I do is that I will manually create two partitions. And partitions will be India and USA, and load the first two files in India and last two files in USA. This is static partitioning. Did you understand the use case of static partitioning? Static partitioning means you are getting the data, you know that the data is segregated, you know that half of this data is belonging to country India and half of the data belonging to country US, but that information is not present in the data, right? So what you do is that you create static partitions. Static partitions means when you are loading the data, you will ask Hive, create a partition called India, put this data there. Create a partition called USA, put this data there. Then you can query the data saying select star from my table where country equal to India. It will definitely query this partition. So this is like you're defining a column while loading the data. Now I will show you partitioning. That will be the best way to do this. So what I'm going to do is that I'm going to connect to the VM first. Okay, then let's see how partitioning is done. So now what I'm going to do is that, okay, I'm going to launch Hive first. Okay, first thing I'm going to do is that I'm going to launch Hive. So, and we have the data. I just showed you the data, right? So the first thing I'm going to do, I'm going to demonstrate static partitioning right now, right? Show databases. We have to take a database. Okay, so remember, Hue is your web interface, right? So first thing I'm going to show you is how my folder structure looks on Hadoop. Now, so I'm going to go to my root directory and user directory, and we have the Hive directory. There is the warehouse, and there is the Dell DB, and inside the Dell DB I have these folders. Now what I'm going to do is I'm going to say create a table called partitioned user. Now you can give any table name, and look at how I'm creating a partition table. This is my schema. Okay. After the schema, I'm saying partition by country and state. Look at here. So whatever columns you are using for partitioning should be outside your schema definition. So when you are creating the table, you say create a table, give the schema, no problem, that's all fine. But I'm saying partitioned by country and state. That means I'm telling Hive that, hey Hive, I'm creating a table and this is my schema, and I'm going to partition using two columns, country and state. If you hit enter, it will create a table. But look at here. If I refresh my Hue, this is the table we created, partitioned user. If I go inside the table, there is no partition. There is no partition. So when you create a partitioned table, there is no divisions. It's a normal table only. Can you see this? I just opened this table. This is the table partitioned user. If you open this, there is nothing inside that. Now, how do you create static partitions? Very simple. In order to create static partitions, what you need to do is, let me show you the data. I will duplicate this session. Root sudo su cloudera. Okay, I'm going to use this file called static. Let me show you the file. Now this file has 3 rows of data, and I am going to load this file into my table and create partitions. Now I completely understand that this file, is copied from the original file that we had, but this is the file which I will be using for demonstrating partitions, right? If you look at here, it has only 3 records as of now, right? So you have the name, then you have the address, right? And then you have the phone number and email address, website. That's it. So what I'm going to do is, I'm going to say load data local in path. So I'm going to load this folder into this table, partition country equal to US, state equal to California. This is how you're creating static partition. I already have a table, and that table has all the schema. Now I'm saying load this file, but while loading this file, create a folder called US. Inside that, create a folder called California, then put the data. Now US is my country, California is my state, the file will be inside that. I created the table here, then I loaded the data where I said country is US and state is California, right? Now I will show you how the folder looks like in Hue. If I refresh my Hue, if I go to Dell DB, there is this partitioned user. Inside that, there is a folder called Country America. Inside that, there is a folder called State California. Inside that, my data is there. And this is the data. Now, if you look at the data, there is no country column, there is no state column in the data, but I created this so that it falls here. Now, if I query the data, I will write a query where country equal to US and state equal to California. It will land on this data and query this so that it will be faster. So these are the commands are used. First, you create the table, give the schema. Define your partition columns outside the schema. So this is what I'm doing, right? Define the partition columns outside the schema. Then you load the data. While loading the data, okay, the data you should say this data is belonging to which country, which state. Very simple. You have to give a country name and a state name. Okay, now let's discuss dynamic partitioning so that you guys are familiar with this, right? Now, what I want to do is, before you do dynamic partitioning, you have to do a couple of things. First of all, you have to enable dynamic partitioning. Now, I will show you how to do dynamic partitioning. So what am I doing here? See, by default, Hive has static partitioning enabled. That means Hive will not allow you to do dynamic partitioning. So that is why I'm typing this command, set Hive execute dynamic partition true. That means it will enable dynamic partitioning. I am also saying that maximum dynamic partitions per node is 1000. That means maximum partitions created will be 1000. You can give more numbers if you want. It is up to you. I just use 1000 so that it sounds good. Okay. You are also saying that the partition mode is non-strict. Okay. You are having something called strict mode and non-strict mode. Okay. So I'm just saying that, you know, partition mode non-strict. Now, in order to do dynamic partitioning, like what I'm going to do is that I'm going to show you dynamic partitioning with the same set of data. Hive will allow both static and dynamic partitions. As of now, I have enabled dynamic partitions. By default, it has only static partitions. Okay. Now let's look at what I'm going to do. It's very simple, right? I'm going to create a temporary table. Now the temporary table concept in Hive is exactly similar to your normal temporary table. Okay, so how do you create a temporary table? Temporary tables are valid only till the session last. You say create temporary table, and this time I'm not doing any partitioning. You see, I'm giving the complete schema. Look at here. I'm creating a normal temporary table. No partition, nothing. Just a simple temporary table, and this table is called temp underscore user. So I'm creating a table called temp underscore user, normal temporary table, no partitioning, nothing. Once I create the temporary table, I want to load the data. So let me load the data. Now this time, what data am I loading? I'm loading this file called customer data.txt, and that is this file. This file has country and state column. We are working on this file. This file has a column for country and state. Okay, so I'm creating a file. Then I'm creating a table, a temporary table. Then I loaded my data into the temporary table. Now, as the first step, I just want to write a query and see whether my query is taking time or not. So what I will do, I will write a very simple query. I will say select first name comma phone 1, comma city from the temporary table, where country equal to US and state equal to California, order by city, limit 5. It's a very simple query, but the only condition is that I'm using country and state just to see or just to demonstrate how much time it will take if I'm not partitioning my table. So right now there are no partitions. Okay, so let's run the query, and the query runs, of course, and let's see how much time it is taking. Okay, so this time the MapReduce job is over and it took 85 seconds. So we will see whether it is faster. Now there is also one more setting. I'm running it on a VM, and even if I do partitioning, it may not have much of an impact, but let's see. Now let me show you how to create dynamic partitions. If I go to my hue, I go to this del DB, okay, and okay, so this is my del DB, right? Now what I want to do is I want to create a partition table. So what I will do, create table called partitioned user 1, okay, and this is the schema of my table, right? Partition by country and state and stored as sequence file. Now this is optional. You can store it as text file or sequence file or anything, that is optional. But this is the same command we used for creating static partition. When I was creating a static partitioning table also, I use the same command. But here the difference is that the data already contains the state and country column. Now see what I'm going to do. So I created a table called partitioned user, right? Now see what I'm going to do. I'm going to say insert into table partition underscore user 1 partition country comma state. So what I'm telling Hive is that, hey Hive, I want you to copy all the data from my temporary table and load it into this new table and partition it with country and state. I'm not going to tell you which country, which state, you decide, because already the columns are present. Now let's see what is going to happen. So see, now what Hive is doing, it will take the data from your temporary table, look it into the country state columns, identify the countries, identify the states, create those many folders and put the data accordingly. I will show you this now. Look at your screen very carefully. You will be able to see Hive creating these folders. So now it is creating the partitions. You will see that right now. Just wait for a moment for that to pop up. Can you see the loading partitions, loading partitions, loading partitions? Can you see that? Country, country, state, country, state. Can you see it creating these files and folders? And done. Now if I look at my hue, the table is called partitioned underscore user 1. If I open this table, there are 5 countries: Australia, Canada, UK, US. Okay, I mean last one you leave it, there are 4 countries. If I open the folder called country US, all the states are created wherever you had the data. If you open any of these states, you will have a file that will have only that state data. Of course, you are not able to see the file in the proper format because it is storing it as a sequence file. But this has the state related data only if that is matching with here. So now you can see that, you know, it is creating countries, and then inside country it is creating states also. And inside that the file is created. So this is dynamic partition. Now we will just see whether the query is faster right now. Okay, so what I will do, I will write the same query on the partition table, see whether it is running faster. So I'm writing the same query we ran last time. It took 85 seconds in the last time. Now the same query but on the new table, see what is going to happen. It might not be that much difference, but I guess there will be some difference. See, time taken 41 seconds. Can you see this? Last time without partitioning it was 85 seconds. Now your query is taking only 41 seconds. That is the impact on the query time when you are using partitioning.
So now let's see how do these two differ. So batch processing is an efficient way of processing high volumes of data such as a group of transactions which is collected over a period of time. Hadoop focuses on batch processing, but as you can see over here, there is a time lag in processing this data. So the data which is generated on day 1 is processed on day 2. Similarly, the data which is generated on day 2 is processed on day 3. And on the other hand, real-time processing involves a continual input, process, and output of data. So it provides an organization the ability to take immediate action in times when acting within seconds or minutes is significant. So Spark helps in achieving this real-time processing. So again, as we can see over here in this figure, the data which is generated on day 1 is processed on day 1 itself, and there is no time lag in processing. So that's the major difference between Hadoop and Spark. So now let us understand about Spark briefly. So Spark is a cluster computing framework for real-time processing. It was Hadoop's sub-project introduced in the UC Berkeley R&D lab in the year 2009, and it became open source in 2010. And then 2013, it was donated to Apache Software Foundation. So Spark provides an interface for programming multiple clusters with implicit data parallelism and fault tolerance. So now that we know what is Spark, let's actually have a look at some of its features. So Spark is real time. That is, it provides real-time computation and low latency because of in-memory computation. And Spark is also 100 times faster for large-scale data processing. And Spark is also polyglot. That is, you can write Spark applications in multiple languages such as Java, Scala, Python, R, and SQL. Spark also has a simple programming layer which provides powerful caching and disk persistence capabilities. And Spark also has multiple deployment modes, so it can be deployed through Mesos, Hadoop via Yarn, or Spark's own cluster manager. So now, let us look at some domain scenarios of Spark. So from small startups to Fortune 500s, almost every single company is adopting Apache Spark to build, scale, and innovate their big data applications. So let us see some industries where Spark is used widely these days.
Just a quick info, guys. Test your knowledge of big data by answering this question. Which of the following are incorrect big data technology? A. Apache Hadoop. B. Apache Spark. C. Apache Kafka. D. Apache PyTorch. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So industries like healthcare, media, finance, e-commerce, and travel are extensively using Spark to add value to their business. So now let's understand how are Hadoop and Spark used together. So Hadoop alone provided limited predictive capabilities as organizations were finding it difficult to predict customer needs and emerging market requirements. But with a combination of Hadoop and Spark, companies can now process billions of events every day at an analytical speed of 40 milliseconds per event. Companies can also enhance their storage and processing capabilities by working together with Hadoop and Spark to reduce costs by almost 40%. And by deploying a big data platform in the cloud, organizations can avoid duplication by unifying clusters into one, which basically supports both Hadoop and Spark. So now many organizations are already using Hadoop and Spark together. Yahoo, Amazon, NASA, and eBay run Apache Spark inside their Hadoop clusters. Hortonworks and Cloudera Hadoop distributions come bundled with Apache Spark. Altiscale uses Spark on Hadoop to provide big data as a cloud service. And Uber also uses Spark and Hadoop together to optimize customer experience.
So the first thing that you need to understand is Spark is comparatively a newcomer in the big data world. When you say newcomer, see Hadoop came in 2005, and then if you look at the other projects like Hive or Pig or HBase, they all came somewhere in 2007 or 2008, etc. Spark was developed in 2010. So if you look at the history of Spark, Spark was created in 2010, 2009 or 2010, you can say, at University of Berkeley. So Spark was created as a research project. So a group of researchers at the University of Berkeley, they had a project called AMP Lab project. The project is still there, and they were just trying to create uh, a distributed processing engine, and thus they created Spark. And you also have to remember that in 2010, MapReduce was the popular big data processing engine, right? Because MapReduce came in 2005, and it was, very popular at that point in time. So when Spark was created, one of the what you say goal was to create a big data execution engine, which is probably better than MapReduce. So if you really ask me where Spark fits in our Hadoop world, I would say that it actually sort of like replaces MapReduce. Even though Spark can do much more than that, but if somebody asks you like, okay, on Hadoop, uh, where do we see Spark? Or when you compare Hadoop and Spark, where do you see it? My answer will be Spark is an execution engine very similar to MapReduce and probably better than MapReduce. So I will see Spark probably as a replacement for MapReduce, right? As a better execution engine. But like I said, that's not the complete story. Spark can do many more things, and we will get into that eventually. So, in 2010, when Spark was created, it was kind of like a university project, and like I said, it was an execution engine, big data execution engine. Very soon, people found that Spark is much, much faster than MapReduce. So then what happened? The Spark project was contributed to Apache. It became an open source project. I think somewhere in 2012 or 13, it became part of Apache open source project. But again, I think it took couple of more years. People started using Spark in the industry by around 2015 or 16. This is my personal experience. As far as I know, it became popular somewhere around 2016, I would say, or 15, which means it is comparatively new, right? Because Hadoop came in 2005, and it was popular. But Spark is like in 2016. But from there onwards, it was a roller coaster ride. As of now, Spark is the most contributed and most widely used big data open source execution engine. So Spark holds many records actually. At one point in time, it has the highest ever number of committers in Apache open source projects. And today, even if you look at the industry, there is no big data project without Spark. So it's probably the most widely used big data project. Uh, Around 70% of workloads uh, in around the globe, if you look at big data workloads, are handled only by Spark. So it's probably the most popular open source project right now when it comes to big data, right? Spark is specifically designed for big data. You cannot use it for other kind of case studies. In the sense, the real advantage of using Spark is if you have huge amount of data. Like If you want to process maybe 1 GB of data, probably Spark is not the right choice. You can have other execution engines as well, right? So that is a brief history of Spark, but then the real question that people usually ask is, why should I use Spark? And this is a question that probably people need answer to. Like, yeah, Spark is probably the most used project, but why should I do it? Why should I go for it? So obviously, it's a big data processing engine. So naturally, you can think about all the use cases where big data is involved. I'm quite sure that you have gone through many case studies and all in big data, and you were probably learning that using MapReduce. So wherever you find a big data problem and MapReduce as a solution, you can replace that with Spark. Spark will fit anywhere. But what are some of the other unique features of Spark? So if I go to the website of Spark, the first thing is, let's go to the official website of Spark, which is nothing but spark.apache.org. So you can make a note of this website, because this website provides the up-to-date information, also a very nice documentation related to Spark. So the site is spark.apache.org. This is the website. And by the way, I almost forgot, the original founders of Spark. There are people like Mate Zaharia, Bill Chambers, the people who created Spark, right? These people, they went ahead and started a company called Databricks. So Databricks is the company which is created by the original founders of Spark. And Databricks basically sells Spark. So you can just go to Databricks and ask for Spark. Um, they have a proprietary platform. It's not open source. Okay. Also, they don't sell only Spark. It's kind of like a platform, but Spark is the what you say, brain or heart or whatever of their platform. And Databricks is the leader in the industry when it comes to Spark, because these are the people who created Spark, right? So we will be using the Databricks platform for some of our hands-on. So Databricks provides a free platform for practicing Spark. Uh, you may not be able to do everything there, like all the hands-on, but some of the hands-on, we will switch to the Databricks platform and experience it there. Okay. Um, Now, when you go to the official website of Spark, you can see the definition. It says Apache Spark is a unified analytics engine for large scale data processing. Yeah, that's the definition. We'll come to the definition. And the advantages are already written in the website. First thing you see here is speed.
Just a quick info, guys. Intellipaat provides online big data Hadoop training in partnership with IBM, the course link of which is given in the description below. Now, let's continue with the session.
So Spark can run your workloads 100 times faster. 100 times faster means what? In comparison with MapReduce. So this is not always true. I mean, these are what you say benchmark numbers. There were cases where they took a benchmark and Spark ran 100 times faster than MapReduce. That's true, right? But don't think like in the industry, every time you're running Spark, it's gonna be like 100 times faster than MapReduce. But yeah, it's fairly faster than MapReduce. I mean, you cannot compare them. On an average, my experience is if a MapReduce program takes, say, 1 hour, Spark will do it in 2 to 3 minutes, probably, maybe in seconds. So it's like nowhere near to Spark. So speed is definitely uh, one of the what you say, advantages of using Spark and how Spark programs are faster. So Spark does something called in-memory execution. So in-memory execution basically means, when you read the data, you keep all the data in memory. In memory means in the RAM. So as long as you're processing the data, the whole data is kept in the RAM or the main memory, and only the final result will be written back to the hard disk. When you go to MapReduce, this is different because in MapReduce, you have a mapper, then reducer. So after the mapper phase, whatever um, output is there, the intermediate output is going to be returned to the hard disk. So for a map reduce, it uses the intermediate output. It will write and then read. So it is kind of like slower. But when it comes to Spark, it is faster. So speed is definitely one of the advantages. Second thing is ease of use. Write applications quickly in Java, Scala, Python, R, and SQL. So, um, if you talk about the programming languages supported by Spark, these are the ones: Java, Scala, Python, R. Now, among them, we are using Scala because Spark itself is written in Scala. It's one of the most widely used language when it comes to Spark. There are a lot of companies, for example, JP Morgan Chase, right? They use Spark with Java. The reason for that is more or less the developers or the workforce. So if you're working in a company and let's say you have a lot of Java developers, then it makes sense to, how do I say, go to Spark and then develop programs using Java, right? And especially if you are a person coming from machine learning, data science, deep learning, you're probably going to use Python or R. So for machine learning people, Python or R are their primary languages. So Spark supports that also. However, it does not really matter which language you are using. If you write a Spark program in Scala or Java or Python, it will run exactly the same. There is no difference, right? It just depends on what background you're coming from and which languages you are comfortable. Spark also supports SQL, so SQL, right? And SQL is probably most widely used with Spark now. So you can use Scala or Java and Python. However, more than them, Spark SQL is the library which is being used a lot. And we will get eventually there, and I will talk about what is Spark SQL and all these languages and all. So ease of use in the sense you just need to learn one language, maybe like Scala, and you can work with Spark, or maybe Scala or SQL, any of this, right? Now, the next thing that I want to talk about is something called runs everywhere. And this is, I think, a question that many people have. So people may be wondering, hey, where can I run Spark? I mean, where do I install Spark, right? Spark is practically platform independent. You can install it wherever you want. All you need is a cluster. So one popular option is you can run Spark on Hadoop. And this is a widely used option. So you can take Hadoop, install Spark on top of Hadoop, and then Spark can run on top of Hadoop. And one thing you need to understand is Spark doesn't come with storage. and many people have this confusion, right? There is no storage for Spark. Spark is like MapReduce. Does MapReduce have storage? No. MapReduce is just the processing engine, right? Very similar to that, Spark is just a processing engine. All Spark says is, okay, you store the data wherever you want, give me the data, I will process it. So when you say you are running Spark on Hadoop, um, HDFS will be the primary storage on Hadoop. Yarn will be your cluster manager. Spark will be the execution engine. You can also run Spark on top of something called Mesos. Mesos is another cluster manager like Yarn. So what I can do, I can take a bunch of machines and maybe I don't want to install Hadoop. Okay, so I can take a bunch of machines, install Mesos on top of them. So Mesos becomes like Yarn, your cluster manager. Then install Spark on top of that. In fact, the original Spark came on Mesos. You can also install on top of Kubernetes. This is, how do I say, container orchestration, microservices and all. So if you are aware of technologies like Dockers and containers and all, Spark very well works on top of that. Or in the cloud, so many of the cloud vendors like Amazon or Azure have their own implementation of Spark. You can go to them, they will set up Spark on a cluster and allow you to use it. Or there is a mode called standalone. Standalone mode basically means you install Spark uh, on a bunch of machines, and Spark will come with its own cluster manager. So what I'm trying to tell you here is, let me take a pen thing so I can talk about it. Yeah, so what I'm trying to tell you is Spark requires two things. One is storage and one is resource management. So if you're installing on top of Hadoop, what happens? You will get HDFS. This is the storage, correct? On top of that, you will get what? Yarn. Yarn is your cluster manager. On top of that, you install what? Spark. This is one option, and this is very common because many companies might already have a Hadoop cluster and they probably want to install Spark. So this is your storage, right? And this is your cluster manager, and this is Spark. The second option is you take a bunch of machines. So here I will just say machines. You take a group of machines and let them be your local storage. You bring up this cluster manager, which is called Mesos, and then you install Spark on top of that. Third option, again, you take a bunch of machines, and there is something called Spark standalone, and then you install Spark on top of this. So what I'm trying to tell you is all these are same. There is absolutely no difference in terms of execution, I'm saying. So Spark just says it needs to be installed somewhere. So you need to provide storage, a cluster manager for Spark to work. So one option will be I go to Hadoop. So their HDFS is my storage. Yarn is the cluster manager. Or I take a bunch of machines, create a cluster, and use something called Mesos. Mesos is another cluster manager. Or I take a bunch of machines and use something called Spark standalone. Spark standalone is where Spark will come with its own cluster manager. You are not using Mesos or Yarn or anything. Spark will have a Spark master, its own cluster manager, and gets installed in the cluster. So all three options are equally good. It's not like one is better, one is bad, or it's just your use case. That's all, right? So these are the common options you have. On top of this, you can install Spark on Spark in the cloud, as well as on top of Kubernetes and many other options, right? The other point I want to clarify is once you install Spark, so let's say you have installed Spark. One of the speciality of Spark is that it can read and write data from almost any platform. And this is, in fact, I think a great feature when you talk about the big data requirements and all. Because normally, when you look at the big data requirements, one challenge is okay, you might have data, but the data may be in different places. So Spark is capable of reading the data from, let's say, any RDBMS platform. So this can be Oracle, MySQL, Microsoft SQL, any of this. Or if your data is on top of any data warehouse. So this is like Teradata, Greenplum, Netiza, any of these data warehouses. If your data is there, Spark can read. Or you have your data on top of any NoSQL database. For example, your data might be on MongoDB, Cassandra, DynamoDB, Spark can read it. Or the data might be in any of the cloud stores, Amazon, Microsoft, Google, uh, any of these cloud, right? Or it can be even in other systems. For example, Spark can read from SAP. There is an SAP connector. Spark can read from mainframe. There is a connector. Spark can read from, if I remember correct, it can also read from Salesforce. There is a connector. Spark can also connect with almost all the BI tools. So, for example, Tableau, Informatica, Spotfire. So you see, this tool is not what we are thinking, right? Look at the connectivity options. You are saying that you can connect to almost any platform. I have listed almost everything that I know. RDBMS, data warehouse, NoSQL, cloud, SAP, business intelligence, ETL. Almost any tool you bring in, Spark will be able to read and write the data. Accordingly, Spark is being used as an ETL tool now. So there are many organizations who use Spark as an ETL tool, and an excellent one, because the challenges will be even in the big data world, you have your data lying in many different platforms. You might want to read and aggregate them, clean them, and write it into some other platform. For example, I might have data in MongoDB. I might also have data in Salesforce. I don't know. So I want to read this, combine them, write it back to, let's say, Oracle. Spark can be used. So one of the use cases of Spark is uh, connecting to a variety of data sources and bringing the data and then transforming the data. And I will show you an example of how Spark can be used as an ETL tool in our course, right? So this is another great feature of Spark. So what did we discuss? Coming back to the discussion. So I was telling you why somebody should use Spark. Why somebody should use Spark? The speed. So definitely it is faster, and the ease of use, like you can use one language and then do anything, runs everywhere. So you can bring it up on any platform, doesn't matter. Also, it allows you to read and write from any type of data source. If this is not enough, right? See, the classic problem with Hadoop is, so we always try to compare Hadoop and Spark, but The classic problem with Hadoop is if I go to Google and search for Hadoop ecosystem tools, let's say go to here. So have a look at this picture. So this picture talks about Hadoop ecosystem, or this picture talks about what is Hadoop and uh, what are the tools you can install on top of Hadoop. So as you can see, Hadoop has HDFS, then Yarn and MapReduce. Fine. So this is, oops. So this is basically the core of Hadoop. Like you have HDFS, then you have MapReduce. Now the point is when Hadoop initially came, okay, it was supposed to be a batch processing platform. Even if you look at the definition of Hadoop, you will see that Hadoop is a batch processing engine. So all Hadoop does is, okay, it takes a bunch of data and do batch processing. Now, again, for this, what happened? A lot of tools were created. So if you look at Pig was created so that MapReduce programs can be written easily. Okay, so there is a engine called Pig, right? Then some folks said, okay, Hadoop is great, but we want to do SQL on top of Hadoop. Okay, and that is how this tool called Hive was created. So Hive is basically what? SQL on top of Hadoop. Some other guy said, okay, you know what, everything is fine, but we want to use machine learning on Hadoop. So for machine learning, Mahout was invented. Then some other folks said, okay, we want tools to ingest the data. Then Scoop and Flume were invented. So the problem is this Hadoop ecosystem is ever growing. So for each type of analysis, you have one tool. For SQL, people use, let's say, Hive. For machine learning, they use Mahout. For batch processing, they use Pig. So I have to learn like, I don't know, 5, 6 different tools when I want to work with Hadoop. The advantage of Spark is when you come to Spark, this is the Spark libraries we have. You just download Spark and install it. And whatever Hadoop and all these 6 different tools were able to do, Spark alone can do it for you. So Spark comes with built-in libraries. For example, if you are interested in just batch processing, okay, you are a developer, you just want to read some big data and do some batch processing, you use something called Spark Core. So this is basically what you call, this part is what you call Spark Core, okay? Spark Core is basically the execution engine. And here you get this abstraction called RDD. I was talking about RDD, right? So one of the ways in which you can program in Spark is using this Spark Core and then RDDs. So what you're doing here is you're going to Spark and you're saying that, okay, I just want to do batch processing. That's all. And I'm a developer. So Spark will allow you to directly interact with your core library. On the other hand, you say that, okay, I'm a SQL developer, then you go to Spark SQL. So Spark SQL is where you are using your SQL library. So you can create tables, write SQL queries, do join operations, just like whatever you are familiar with SQL. If you want to do real-time data analysis, you go to Spark Streaming. So Spark Streaming is where you have real-time data analysis. And this is something I guess people might not have seen. So normally in the Hadoop world also, all the tools are created to do batch processing. There is no real-time processing. Spark provides you with a library called Spark Streaming, which can do real-time analysis. And I will explain what it is later. Now, if you want to do machine learning, there is a library called, MLlib. So MLlib is the library which allows you to do machine learning. There is even a library to do graph processing. So the real deal with Spark is it is not only faster, it is not only easy to work with, it is not only something which you can install everywhere and read from everywhere, it comes with a bunch of libraries to address any kind of workload. So in the modern day big data projects, our problem is really this, and Spark solves it. The problem in modern day projects is that I'll give you an example from my experience. Imagine you are designing a system which is going to catch credit card fraud. So credit card fraud is a very common thing, right? So, what happens? A lot of people steal the credit card, they will hack and, they do fraud, identity theft. So maybe you have a credit card, somebody will steal the number, the CVV code, then they start using it. So credit card fraud is very common. And what happens is, if I want to design a system which can catch, let's say, credit card fraud, what are the challenges? So my first challenge is this system should be real time. Real time in the sense, millions of people might be swiping their credit cards, right, during peak hours, and you want to catch it and then probably make a decision, right? So if I am getting all the credit card transactions today, if I analyze it next month, it is going to be useless because this is fraud and you have to do it in real time.
Just a quick info, guys. Check your knowledge of Hadoop by answering this question. Which of the following are the core components of a Hadoop? A. HDFS, B. MapReduce, C. HBase, D. Both A and B. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So I need a system which can process, say, 1 million transactions in a second and make a decision. So you can use Spark, and there is Spark streaming. Then in the credit card fraud system, I also want to implement machine learning, because usually when there is some sort of a prediction, like whether it is fraud or not, machine learning is heavily involved. So again, you can use MLlib in Spark. And in the credit card, what you say, fraud detection system, I probably want to use SQL, so I can use Spark SQL. So you see, using the same Spark, you are able to implement three-way approach actually. This is not possible in Hadoop. When you go to Hadoop, the problem is, for SQL, you have to install Hive. For machine learning, you need to install Mahout. For real-time processing, you need to install something called Storm. And integrating all these tools together is a challenge. But in the world of Spark, like I said, um, it comes with all these built-in libraries, so you will be able to perform uh, all these kind of analysis using a single tool. And that is the real advantage of using Spark. Um, I'll get back to your questions in a moment. Also, I think probably I spoke about it, but if you look at the versions in Spark, right? Spark has three major versions. There is something called Spark 1, or the 1 dot release, we call it. Nobody uses 1 dot release. It's pretty old. Then you have something called Spark 2 dot release. 2 dot release is what people use in the industry uh, as of now. There is also Spark 3 dot. Some of the customers started using it, but it is comparatively new. We will be using Spark version 2.3.1 in our course. So now I can quickly, refresh the slides to talk about these things, right? this is exactly the same thing that I was talking about. So if I go here, yeah, this is again the same Spark architecture we were talking about. As you can see, on top, you can see the languages, Scala, Java, Python, R. Then you can see the libraries, Spark SQL, Spark Streaming, MLlib, and Graphics, right? At the bottom, you have Spark Core. And like I said, it can read from all these platforms. So you have many platforms actually listed here. You have like Cassandra, HBase, MySQL. And I almost forgot one more thing. Okay, so I almost forgot one more thing, which is Spark is also capable of reading any file format. And I will show you an example for this. Uh, File formats are very important. So you might be aware of CSV, JSON, XML. So Spark can read all of this. On top of this, there are some big data file formats. We have ORC, Parquet, Avro. Spark will be capable of reading any of these file formats, right? And convert them from one format to another one as well. So then what we spoke about. So this is again the categories of Spark components. Again, same thing I was talking about. The programming languages you can see, the libraries you can see, but end of the day, the execution will be handled by Spark core engine. Then cluster manager can be Yarn, Mesos, or Spark scheduler or Spark standalone. Storage can be HDFS, standalone machine, cloud, or RDBMS, even NoSQL. So one more thing you need to understand is the data need not be always with Spark. For example, you might have installed Spark on top of Hadoop, but that does not mean like you have to keep all the data in Hadoop. Yeah, it can read from Hadoop, but the data may be, some of the data may be in Cassandra, some of the data may be in cloud. Still Spark can read and process it. So like I said, it's a processing engine rather than something like Hadoop. Okay. Yeah. So what we have to understand now is something called Spark architecture. So we will build on the Spark architecture. I mean, we will understand the basics, and then, you know, we will build on that knowledge, what it is. Uh, See, usually what happens is, I might have to use my pen. So usually what happens is when you create a Spark program and then submit the program, you definitely need resources to run the program. And I think this is something everybody agree, right? So you may be processing a 10 GB file, or maybe you're processing 100 GB file, or you may be processing data from different sources at the same time. So whatever you do, one thing is sure, you need resources to run the program. So one way to get this is from the yarn. Not one way, the only way. So who will give you resources? Resources will be given to you by the cluster manager. Let's say yarn. So we are assuming that Spark is running on top of Hadoop. So if that is the case, the cluster manager is yarn, and yarn is supposed to give you all the resources to run the job, right? And what happens in case of Spark, the resources are given to you in the form of something called executor. That is what you see in the picture. So there is something called executor. What is an executor? Uh, in Spark's terminology, executor is a combination of CPU and RAM. That's it. It is like a container given to you. so that you can run the program. An executor is a combination of CPU and then RAM. So you can go to Yarn and ask for as many executors as you want. Also, you can decide what is going to be the configuration of the executor, like how much RAM, how much CPU cores, all you need. And this has to happen depending on the data that you are handling, right? So depending on the data and the complexity of the program, that you're written, you can probably ask uh, for this. So typically the executors are allocated uh, um, based on the decision of Yarn. Now, this is actually a very crucial thing, but in my experience, you will not be the only person who will make this decision, right? Because let's say you created a program and you want to run the program in a cluster. Now, you may be reporting to somebody, or maybe someone else will also be responsible for running this program, right? So you are probably not the only one who thinks, okay, I can run the program. uh, Now executors can be launched on each of the machine. So if you have 100 data nodes or 50 data nodes, on each of them, executor can be launched. And there is a calculation that typically you use. To show that calculation, we need a cluster. So I'm just going to use a cluster that I know. Don't worry about this. So there is something called CloudX Lab. So I'm just going to log on to this lab so we can see what the resource policies are in this cluster. Let's try to log in. So the executors are allocated by Yarn. So you need to go to Yarn. Okay. You go to Yarn and you will be able to see some of these options here. I don't know where to find it. Let me just check in this cluster. So if I go to Yarn, non-manager, if I go to configuration, yes. So see, first thing you need to understand is if you go to what you say Yarn, you can find these requirements. There is something called memory node. Memory allocated for all Yarn containers on a node. So there will be restrictions. Okay, so in this cluster, what you see is memory allocated for all Yarn containers on a node is 9 GB. So you can see this value. This value is 9 GB. So maximum 9 GB is in this cluster. In the real world, it might be bigger. Okay, in this cluster, maximum RAM that can be allocated for an executor is 9 GB. Minimum is, okay, so that is for all Yarn containers on a node, right? And then there is a minimum container size and maximum container size. So you can set it individually. So minimum is 128, maximum is actually 5 GB, right? So all containers put together, it should not cross 9 GB total. For an individual container, right, minimum 128, maximum 5 GB is the size. So let's take these things in account so I can write it. So on a machine, maximum memory of all executors put together in this cluster I'm talking about, okay, executors is 9 GB. Minimum memory for one executor is 128 MB as per this cluster. Maximum memory for one executor, that is 5 GB as per this cluster. Okay, you also have settings for CPU. So if you scroll down, this is CPU. So you can see minimum container size is 1, maximum container size is 8. So for CPU, what they say is minimum CPU for one executor is 1. Maximum CPU for one executor equal to 8. Okay, so these are the settings. This is set by your administrator. That is why I'm showing this page. See, this is the yarn page of this cluster. So you can see the total RAM for all the executors together is 9 GB. Minimum RAM is 128, maximum is 5 GB. And minimum CPU core you can ask is 1 core, maximum is 8 core. So you need to first understand this, then only you can ask for resources. Now this may change for different clusters. And these are very small numbers because this is a training cluster. In the real world, this might be in gigabytes and very big numbers, but you need to understand this. And now if you come to this picture, what you do is typically when you are creating a Spark program, you create a Spark program, and within the program, you will be able to set all these numbers. I will show you how that can be done. But typically, when you write a Spark program, within the Spark program, you will be able to ask resources to run the program. And when you launch a Spark program, what is going to happen is, take my pen, there is something called driver program. You can see this blue box. The driver program will start on one of the machines. So I'm just assuming this is my data node 1. So remember we discussed about driver program even in Scala. What is the driver program? The driver program contains settings to run the program. So this can be, for example, the resources you are asking, the compression that you are using. All this is part of the driver program. So typically what happens is the driver program will initialize on one of the machine, and it is going to create an object called Spark context. So Spark context is basically an object. Okay, it is an object, and this will be initialized by the driver program. Now, why do you need this object? Because once this object is initialized, you can see using this object, the driver program will talk to your cluster manager. The cluster manager in this case is, let's say, Yarn. So driver program starts first. It will initialize the Spark context object. Using that object, it will connect your cluster manager Yarn, and then the driver program will negotiate resources from Yarn. So in this simple example, you can see there are two executors. So the driver program is going to Yarn, will go to Yarn and say that, hey, you know what? I need two executors. And you will also say that, let's say each executor, let it have 8 GB of RAM and 8 CPU. As an example, I'm giving. So each executor, you are assuming you have like 8 GB of RAM and 8 CPU. So the driver program will go to Yarn and say that, hey, Yarn, in this program, the developer has asked for two executors, each with 8 GB RAM, 8 CPU. So Yarn, what it is going to do, it will launch these executors. Now, you really don't have any control here. If there are no resources, right? So suppose sometimes what happens, your cluster may not have enough RAM. Then what will happen? Yarn will not launch any resource for you. your program will wait in the queue. Nothing will happen. But assume you are in the ideal environment where there are resources in the cluster. What Yarn will do? Yarn is going to launch 2 executors. Now, again, there is no control as to where these executors will be launched. Yarn can even launch both the executors on one machine. Quite possible. That depends on the discretion of Yarn. But let's assume that in this ideal example, Yarn launches one executor on each of the data nodes. So this is my data node 2, okay? And this is my data node 3. These are 3 data nodes in the cluster. So Yarn launches one executor on data node 2, one executor on data node 3, and each executor has 8 GB RAM, 8 CPU cores and all. And now your driver program will push the business logic in the form of something called task. So if you're wondering what is this task, when we write the program, I will show you. But if you write a Spark program, it will be broken down into smaller pieces of unit called task, which can be executed. So the driver program, now since it has got the resources, it starts pushing these tasks to the executors and they execute it parallelly. Once the program execution is over, the final result will be sent back to the driver program. So driver program is the one which will be getting the final result or output or whatever you call. So driver program gets the final output, right? And then the executors will be deleted. Executors are only required at runtime. You don't need them like all the time. They are only required at runtime. Once your processing job is over, executors are also deleted. Now the question will be, how do I know how many executors I need? Well, there is no hard and fast answer to this. Okay, so next question will be, okay, I got the idea. You're saying that to analyze the data, you will ask for executors. But how do you know that you need 2 executors? Or better, how do you know that each executor need 8 GB RAM? Like, what is the logic that you're using here? Well, the logic is something that probably has to come with experience. To give you an idea, if you have a 50 GB file, let's say you have a 50 GB file to process, I can ask for even a single executor with 50 GB RAM, but that is probably not a good idea. So as an example, what I'm going to do, I will launch 5 executors. This is just an example. Okay. 1, 2.
Just a quick info, guys. Intellipaat provides online big data Hadoop training in partnership with IBM. The course link of which is given in the description below. Now, let's continue with the session.
3, 4, and 5. So this is my executor 1, executor 2, executor 3, 4, and 5. So I'm going to launch 5 executors in this example. Each executor gets, let's say, 10 GB RAM. So each are going to get 10 GB RAM. Also, each executor will be getting 10 CPU cores, assume. So I'm just going to say 10 CPU core. This executor, 10 CPU core. Again here 10 CPU, 10 CPU, 10 CPU. So I have requested for 5 executors, each with 10 GB RAM and 10 CPU core. Now the problem is how this 50 GB file will be loaded in 5 separate machines or 5 executors. So Spark uses a concept called partitioning. Spark has a concept called partitioning. Partitioning is nothing but dividing your data. That's all. So when you are reading this file, 50 GB file, you can ask how many partitions you need on this file. So I'm going to say that, okay, I want to divide this file, this 50 GB file, into 50 partitions. So when you say 50 partitions, each partition will be like 1 GB. Okay. And then what is going to happen? Partition 1, then partition 2, partition 3, up to partition 10 will be loaded here. Again, partition 11, partition 12, partition 13, up to partition 20 will be loaded here. Partition 41, partition 42, all the way till partition 50 will be loaded here. That is how the processing will happen. So I think I spoke about too many things at one time, and maybe people are kind of like confused probably. So I will reiterate what I'm trying to explain. So first thing is, how do you decide the number of executors? Now there is no hard and fast number, like I said. In this example, I'm calling for 5 executors to fit 50 GB data. So rough figure will be, if you have 5 executors with 10 GB RAM, you fit 50 GB data. You can also ask for 10 executors with 5 GB RAM, right? That also works. But normally the rule is the number of executors should not be too less or too more, what you call, right? See, if the number of executors are very less, like you're calling for 1 executor, then only 1 machine will be participating in the processing, and it will be very difficult to process the data. If the number of executors are more, for example, for this 50 GB file, I can call for 50 executors. Absolutely possible. But if I call 50 executors, the problem is there will be a lot of data shuffle operation. Sometimes, say you are using Spark and you do a join operation, the data might have to travel from one executor to another executor. So if you have too many executors, that will be a problem. So I came up with a number 5.
Just a quick info, guys. Test your knowledge of big data by answering this question. Which of the following are incorrect big data technology? A. Apache Hadoop. B. Apache Spark. C. Apache Kafka. D. Apache PyTorch. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Okay, that is my golden number probably. Each executor get 10 GB RAM. So 50 GB can be accommodated there. Now the most important point here is processor. Processor. Why processor is important? First of all, processing has to happen, right? Data needs to be processed. So you need CPU. The second reason is CPUs are not easily available, meaning I can have a server with 200 GB RAM. I cannot have a server with 200 CPU. Check it out. I don't think it is possible. CPUs are limited. Okay, so when you plan your processing, you should consider CPU. It's not possible to process your data if you have only RAM. RAM cannot do processing. So that is why in this example, for each executor, I have allocated like 10 CPUs, 10 CPU core. So now the rule is you have 10 CPU core, And ideally, each processor core can process some data. That is where partitioning comes into picture. So this 50 GB file, when you're loading in these executors, you can partition them. And I will show you how to do this practically, but you can basically run a command and the file will be split or partitioned. So I decide 50 partitions so that each CPU core in an executor get one partition to process. That is ideally how you should design. So when you have a processor core or a CPU core, it has to work with one partition. And there is no golden rule as to what is the size of a partition, but 1 GB is something typically we can consider. Even it can process 2 GB or 4 GB, but in this simple example, this is what we do. Now, you don't have to break your head if you don't understand this. These are some ground rules. And also, you don't decide this on your own. You cannot go to your company and say that, okay, I learned Spark, I'm the boss, I'm deciding partition. You will be fired the next thing. So you need to take permission from people to do all this because this all affect the cluster, right? So yeah, your theory might be correct, but you need to, discuss this with other people, maybe your administrator. You ask your administrator, hey, I have 50 GB data. I'm going to launch 5 executors. Will it work? He will say, no, it's not going to work. Increase it to 7. Some reason, right? So you need to adjust all this. But end of the day, the total RAM uh, among all the executors should fit your data, and the CPU cores should process each partition. That's kind of like the rule. Okay, I'm bored with theory. Let's go to hands-on. Since we spoke so much, I thought I will do something. I will show you what. Okay, let's open the Intellipaat VM. I'm just going to open this Intellipaat VM. But I want to show you a couple of things before we get into the actual hands-on kind of thing. So I'm starting the Intellipaat VM and I am connecting with the VM. Intellipaat VM. And in order to work with Spark, there are many ways. If you want to write a Spark program, you can always use an IDE like Eclipse we have seen. So you will be able to develop your Spark program using an IDE. I will show you that. But more than that, Spark also provides us with an interactive shell. So if you want to work with Spark using Scala, all you need to do is just type this command spark-shell and hit enter. So this command spark-shell, this is going to launch something called Spark Interactive Shell using Scala as the language. So once we get the Spark shell, we will be able to type the code and execute it and see and all. So as you can see, when I type Spark shell, you can see the Spark version is, okay, it's 230, not 231. That's okay. So you see Spark has started. Version is 230. And you can see the Scala interpreter. So basically, Spark has started and I'm using this Scala language to write programs on top of Spark. So one thing I wanted to show you today was that you can just type spark-shell and then you get an interactive shell for Spark. Um, and also you see something here, it will be written Spark context web UI available at this location. So whenever you start the Spark shell, Spark also gives you a web UI. It will be available in 4040 port number. I can just copy this, go to my browser, paste it, and there you go. So this is the Spark UI. And as of now, you don't see anything in the Spark UI because, typically when you run any program or any logic, then only Spark UI will display something. As of now, the UI is completely empty. We are not going to run a program, right? And I can exit from here. Now, if you are a Python developer, there is something called PySpark. So PySpark is where you will be working with Spark using Python. So in order to get the PySpark shell, you can just type PySpark. So I'm going to just type PySpark, hit enter. And what happens here is again the Spark shell will be started. But now you can see again Spark came, but you don't have Scala here. You have Python. So now are you able to understand the connection between Spark and the languages? Spark is the execution framework and you can program in Spark using any language. So this is your PySpark. So I just typed PySpark and this started. And now I will be able to type Python commands here. They will be executed by Spark if I want to do that. Well, I think we will not be using PySpark. So I will exit here. Let me start this uh, Scala shell once again because I want to show you one more thing. So we will be working with this command called spark-shell because this will bring the Spark interactive shell in Scala. And this is where we will be spending most of our times. And I want to show you one more thing. So when I start Spark, it says that the web UI is available in 4040. You can see that the version is 2.3.0. It also says Spark context available as SC. What is this Spark context? Go back to the diagram. So Spark context is this object using that your driver program is communicating with the cluster manager. So normally when you start this Spark shell, the Spark context will be automatically created for you. So you can see Spark context available as SC. SC is the name of the Spark context object. Also, you see something interesting. It says master equal to local. What is this? There is something called local mode in Spark. What is local mode? In local mode, Spark will run only on one machine inside a single executor. So driver, executor, everything is going to be inside a single machine, single JVM. That is local mode. Why? This is good for learning, development, testing, and all. Local mode is great if you want to experiment with Spark. See, if you want to learn Spark, you don't need 100 node cluster, right? Spark will behave exactly whether you are running it on one machine or 100 machines. So by default, when you start Spark, you see it is starting in what? This local mode. Now you can do everything in Spark using local mode, but the difference here is, like I said, it is using our Intellipaat VM. Intellipaat VM is one machine, so you are not actually getting a cluster. But I wanted to show you a cluster as well. What I'm going to do, I'm going to use Google Cloud. Well, any cloud platform will do. But if you go to Google Cloud, okay, I have an account with Google Cloud. You don't have to do this, don't worry. If you go to Google Cloud, they allow you to quickly launch a Spark cluster. It's very nice. I'll show you. So you can go to Google Cloud. There is a service called Dataproc here. I go to this service called Dataproc and I can ask Google Cloud to give me a Spark cluster, Hadoop and Spark cluster. How? So it says here, Google Cloud Dataproc lets you provision Apache Hadoop clusters and connect to underlying data stores. It will come with Hadoop and Spark. So I can just say create a cluster. Okay. And I can give a name for my cluster, not required right now. And cluster type is like one master and n worker, meaning you will have one master and n number of data nodes, what you call. Scroll down, enable component gateway. I can go to configure nodes, and you can select whatever type of machines you want in the cluster. So I'm going to use this N1 machine. You get like 4 CPU, 15 GB memory. Okay. And hard disk space, I don't need like 500. I can ask for some 30, right? Then worker node also, I will say 2 worker nodes, just 30 GB hard disk space, say create. See how easy it is. So now Google Cloud is creating this cluster and this is chargeable. Don't try if you're not aware of cloud computing. This is chargeable, highly chargeable. Okay. I think for running this for an hour, they charge $10 or something, even more than that sometimes. So this is highly chargeable, but very easy to demonstrate something like this. So now what Google Cloud is doing, they're creating a cluster for us, right? So you can see the cluster is provisioning, right? And it is happening. Meanwhile, I need to check something. Let's look at Stack Overflow. Okay, anyway, go here. The cluster is running anyway. So we have the cluster running, and why I wanted this cluster is I can just go to the cluster, and in here, what I want to show you is, where is the VM instances? Let me connect with the cluster. So how do you launch the Spark shell in the cluster mode? That's basically what I wanted to show you. So in the Intellipaat VM, when I say, okay, start the Spark shell, you're getting something called local mode, right? So here, since we have a cluster, what I can do is I can say Spark shell, then I can say hyphen hyphen help. So if I take help from the Spark shell, you see a lot of interesting things here. For example, the master URL. So the default master is client, meaning by default, Spark Shell is going to start in the client mode. Okay. Sorry, local mode. Sorry. So the default is local mode for master, but you can ask for Mesos as your master, Yarn as your master, Kubernetes as your master, Spark itself as your master. So we will say start the Spark shell and we will say master is Yarn because we have a cluster. What else can you do? Look at this. Driver memory. So how much RAM or the main memory you should give for the driver? So that is the driver memory. And look at this. Executor memory. So how much RAM you can ask for the executor? Then here is the driver cores. The CPU cores you can ask for the driver. And here is executor cores. So let's try to launch Spark Shell like this. I'm going to say Spark Shell. The master is Yarn. And I'm going to say number of executors 5. I need 5 executors. Then I'm going to say executor memory 2 GB. Then I'm going to say executor cores 2. Executor cores 2. Then I'm going to say hyphen hyphen conf. Now I need to put this. Spark dynamic. Yeah. Hey, this is enabling. I will try this -conf I need to give. I think this will work. Let me just check. Give me a minute. Equal to force. I will tell you what I'm doing. So what we are doing here, we are launching a Spark shell, and we are saying that, okay, hey, go to yarn. Okay, just go to yarn and ask for 5 executors, each having 2 GB memory and two CPU cores. So I will tell you what is this dynamic resource allocation, but you can see this started. And now if I go to Spark UI, I will be able to find it. So how do I find this in the Spark UI? I can go to web interfaces. I can go to resource manager, go here. And this is the Spark shell. I open this. I go to this UI. Okay, so you got the Spark UI in the Google Cloud, and here, quite interestingly, expand this event timeline. Can you see there is something called event timeline? And if I expand, it says executor driver added. So this is your driver which started first. Then you have executor 1, 2, 3, 4, 5. So you can clearly see that we asked for 5 executors and Spark launched it. So first the driver will launch, it will negotiate with Yarn, get 1, 2, 3, 4, 5. So you're getting 5 executors here. You can also go to this executors page here, and it'll show you all the executors. If I scroll down, see, this is my driver. This first thing I'm highlighting is the driver. And below this, you can see 1, 2, 3, 4, 5 executors are there. So these are all my executors launched 1, 2, 3, 4, 5. Okay. So this is something I wanted to show you. Like practically you can see these executors and all, something I just wanted to show you. So you can clearly see here, 1 driver added, then 5 executors. So I will probably delete this cluster because otherwise this is chargeable. So I'm just going to delete this Google Cloud cluster. It's actually chargeable. The Scala programming language. Scala, what is Scala? There is a car by the name Scala, by the way, but I have never heard a Scala as a programming language. What is it? Who created this? When did it come? You know, you tell me Python, you tell me C Sharp or Java. I know this. What is Scala? I never even heard about it, and you are going to talk about it. Well, honestly speaking, Scala is a very popular programming language, but it is really popular in the big data landscape. Okay, so if you're even in the traditional world, there are projects which use Scala, but in the big data landscape, Scala is extremely popular. Now, the first question that probably I need to answer is why somebody created a language called Scala? Because there are too many programming languages in the world. Then why did you come up with another programming language? So Scala was created somewhere around, I think, 2004 or 2005, roughly around that. And the real reason for Scala was, I would say, in a way, Java. So if you look at the industry, probably around 2001, 2002, and all, the industry largely had two type of programming languages. Okay, so one type of programming languages were languages like Java. So if you look at Java, Java is, in fact, one of the most popular programming language, right? Um, and Java is platform independent. Most of you might be aware of that. You can install Java wherever you want, and Java programs are highly optimized. But the problem with Java, now I don't call it as a problem, is that it is very difficult to learn. Now, if you are a newcomer in the programming world and then you try to learn Java, then it's gonna be hard. It's not that easy to learn Java, right? So on the other hand, you had other type of languages, for example, like Python. So the advantage of Python is it is more or less like a scripting language. It's very easy to learn. Anybody can learn practically. So Python code is more or less written like you write English. So the way you can learn Python is very easy. On the other hand, Python lacks some of these optimizations which you know Java provides. So you have like two type of languages. One is probably languages like Java, which have all the benefits of platform independence, optimizations, but they are kind of like a little bit hard to learn. On the other hand, you have languages like Python, which are like super easy to learn, but Python lack a lot of optimizations that languages like Java provides. So Scala came as a language which takes the best of both worlds. So to put it in the technical terms, I would normally say that Scala was the first programming language which supported both object oriented and functional programming styles. So this is the real reason why people started using Scala. So Scala was the first programming language which started supporting something called object-oriented programming and functional programming styles. Now, object-oriented programming is not something new, right? What is object-oriented programming? Languages like Java, C++, they support object-oriented programming, right? In object-oriented programming, we represent classes and objects, or we create classes, and ideally everything should be an object, right? So this is the traditional way of programming, which is known to people, right? There is another way of programming, which is actually called functional programming. Now, I will come to what is this functional programming later. I mean, an explanation and what it is. I will come to that in detail. But functional programming is a way of programming in which you try to minimize the number of lines in your program, right? And you will be using a lot of variety of functions. Like the name suggests, it's called functional programming. So with the use of proper functions, you try to reduce the number of lines of code, uh, and that way of programming is actually called functional programming. There are a lot of more aspects to functional programming apart from this, but in a one liner, if I have to define, I would say functional programming is a way of programming which is fairly easy compared with object oriented programming. So Scala was the first language which started supporting both styles of programming, and Scala was modeled after Java. So Java was already there, and when Scala was developed, a lot of libraries in Java were reused in Scala. So if you are actually coming from a Java background, you will find a lot of similarities in Scala. However, Scala is a language which is comparatively easy to learn and easy to work with. Now, when it comes to the performance benefits of Scala, right? So first thing we need to understand is that it supports something called object-oriented and functional programming styles, which means if you are an object-oriented person, you are familiar with classes, objects, and inheritance, and all these concepts, you can definitely use Scala, no problem. You can also use it for your functional programming kind of projects. Now, the second interesting point is when you write a Scala program, okay, and then you compile it, the compiled program can be executed on top of something called JVM or Java Virtual Machine. So you remember, if you're writing a Java program, what happens? Any Java program you write, you compile the Java program, it will create something called a jar file. And the Java program requires something called JVM. Scala programs also run exactly on the same JVM. So what is this JVM or Java Virtual Machine? JVM is a platform where your programs can run. The beauty of this is JVMs can be installed on almost any kind of hardware software combination. So the real reason Java programs are platform independent is because you are able to run them on top of JVMs. So on the same line, Scala is also platform independent. So wherever you are able to run a Java program, you can run a Scala program as well. Because as long as you have a JVM, you will be able to run a Scala program. Also, the JVMs provides extraordinary performance tuning. So when it comes to the performance benefits of Scala, it is actually contributed by the JVMs. The real reason why Java programs are so optimized is because they run on top of this JVMs. So Scala programs also can benefit from the JVM architecture. So when you write a Scala program and compile it, you can basically execute it on top of a JVM. So that advantage is also there. So Scala programs, they can be written in object-oriented and functional. Scala programs usually are easy to write. Scala programs can be platform independent. You can run them on top of Windows or Linux or any platform you want because they support JVMs as the platform. Scala programs are also performance oriented because the JVMs allow you to do performance optimizations, right? And usually when you want to work with a language, any language, Scala as an example, the best way to start working with the language is that you start, doing some hands-on with the language, right? So what I'm going to do is Intellipaat has a virtual machine, right? So you will be able to install Scala on the Intellipaat VM. Now I know that some of you might have already installed Scala. In that case, it is fine. In case if you have not installed the Scala, don't worry, I will help you to install. So we will be primarily using this Intellipaat VM as our platform. So what I have done, I have already installed Scala on the Intellipaat VM. So I'm just going to connect with the Intellipaat VM. Okay, so I just logged on here and you will be able to install Scala if you run a couple of commands. I will share that with you. Once you have installed a Scala, the beauty of Scala is Scala provides an interactive shell. So if you're coming from the Java background, normally what happens, if you want to write a Java program, you always use an IDE, right? Something like Eclipse. Eclipse is an IDE for Java. Now, Scala also supports IDEs, but Scala supports this interactive shell. So I can just type Scala in the command prompt, and what will happen? You will be getting something called the Scala shell. Now, don't worry, I have a small error. Don't worry about it. But as you can see, I have just launched the Scala interactive shell. So the easiest way to get started with Scala is using the Scala interactive shell. You can just type Scala in the command prompt and it is going to start it. I will also show you the IDE for Scala. Don't worry, we will discuss about that. But we will first start with the interactive shell. Okay, so when I start the Scala shell, I want to show you something interesting. What is interesting, right? So I'm going to type something. I'm just going to type 2. So all I did is I typed the number 2 and hit enter. And what you see here is Scala says, hey, you know what? 2 is an integer. This is very interesting. This means Scala can automatically figure out the data types, right? So I never told Scala that 2 is an integer, but what happened? Scala came back to me and said that, okay, did you just type 2? Okay, so 2 is an integer. And this will work for anything. If I type, let's say, oops, sorry. If I type something like 10.3, Scala will tell me that this is a double. If I type something like A, just in single quotes, Scala will tell me it is a char data type. If I type something like Raghu, Scala will tell me that it is a string. So one of the features of Scala is what we call dynamic type inference. So this feature is actually called what? Dynamic type inference. So we are talking about dynamic type inference. What is this? Dynamic type inference means Scala is able to dynamically guess the data type. So anything that you type or feed to Scala, it is able to figure out the data type. Now you may be wondering, what is this RES0, RES1, RES2, and RES3? These are system generated variables. See, normally you will say something like A equal to 2, right? So normally when you declare a number like 2, you will assign that to a variable. Now I'm not assigning to any variable, I'm just typing 2. So Scala will create a variable called res0. It's actually called result 0, right? And assign this to me. Don't worry, in the real world, we will not be what? Declaring variables like this. We will be doing proper variable declaration, and I will show you how that works. I just wanted to show you that Scala can automatically guess the data type. Also, using the Scala shell, you can do basic mathematical operations and all. For example, I can just say 100 plus 2.
Just a quick info, guys. Check your knowledge of Hadoop by answering this question. Which of the following are the core components of a Hadoop? A. HDFS, B. MapReduce, C. HBase, D. Both A and B. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
And Scala will do the math and tell me that it is 102 and the data type is integer. So the Scala shell is very interactive. You will be able to perform a lot of operations here. And the point that I wanted to clarify here was that Scala has this dynamic type inference. Now, this is very similar to the language called Python. If you are a Python developer, right, then Python also has the same dynamic type inference. So when you go to Python, you just declare a variable and Python will also detect the data type. But there is a difference here in Scala, and I will come to that in a moment. Okay. Now, the next thing that we need to understand is about variables in Scala. So there are two types of variables in Scala. So normally in a programming language, we typically say there is only one type of a variable. But when it comes to Scala, there are two types of variables. One is what we call immutable variable, and this is represented as a VAL. Second is called mutable variable, and this guy is represented as a VAR. And this might be something which is a little bit confusing initially, but I'm quite sure all of you will really get along very well. Um, Only in Scala I have seen this. Now, I may be wrong. My experience also matters, but I have never seen this in other programming languages, because in every other language, when you want to declare a variable, you just say a equal to 100. So when you want to declare a variable, you will say something like a equal to 100. But in case of Scala, you need to say this a is a val a. It can be a val a equal to 100, or it can be a var a equal to 100. You can never say just a equal to 100. The a has to be either a val, a val, or a var. What is this val and var? So if you go back to the Scala REPL, we can try to see that. So I can try to declare a variable. I'm going to say val a equal to Intellipaat, let's say. So now this is how you define a variable in the proper way. Uh, I just said, okay, val a equal to Intellipaat, right? So as you can see, Scala is able to tell you that a is a string value. So there is dynamic type inference. Fine, no problem. And the value of a is actually Intellipaat. Now, whenever you declare something as a val or a val, it's immutable. Immutable means something which you cannot change. Meaning, if I try to do this now, if I try to say a equal to, let's say, spark or anything, what will you see? You will see error reassignment to val. So once you declare something as a val, it cannot be modified. Val is immutable, and there are certain situations where you will use them. Maybe when we start discussing Spark, I will come to more details about this. So usually people have a belief that programming means when you have variables and you should be able to modify them. And naturally, people will be having this question, hey, what is the use if I declare something that I'm never able to modify? So there are some special use cases, especially in the big data world. When we start discussing about Spark, maybe I will come to that.
Just a quick info, guys. Intellipaat provides online big data Hadoop training in partnership with IBM. The course link of which is given in the description below. Now, let's continue with the session.
But as of now, just be aware that when you say val, it is immutable. On the other hand, I can say var b equal to Hadoop, and then I can say b equal to MapReduce. So as you can see, when I declare something as a var or a var, right, I am able to modify that. So var is what we call mutable. So if you're coming from the Java background, these are very similar to Java final variables and non-final variables. Or you can consider them like constants, for example. So whenever you have a val attached, they are more or less like a constant. Whenever you have a var attached, that means you will be able to modify them. However, most people understand this. This is a concept that most of the people get it, because you just need to remember which is mutable, which is immutable. That's all you need to remember. However, there is a catch here, and I think you have to be very careful. What is the catch? The val is fine, because once you declare something as a val, you can forget about it because you are not going to change it. When it comes to var, the var, I just told you that you can modify, but it comes with terms and conditions. What do you mean by terms and conditions? See, I just said B is Hadoop. Fine. But if I try to do something like this, I will get an error. Why am I getting an error? You just told us that you can modify B. Yeah, I told you. However, there is a catch. What is the original data type of B? It is string, right? So this basically means you will be able to modify the value of B, but it has to be a string. So I was trying to assign an integer. Then what happened? I got a type mismatch error. It did not work, right? So this is what we call static typing. So this technical term for this behavior is called static typing. And sometimes people will say Scala is a statically typed language. What do you mean by that? This means once you declare a variable and assign a type, it remains the same throughout the scope. So when I declared B initially, B became a string. This means you can modify the value of B, but it has to be another string. Okay, so that is what you call static typing or statically typed programming languages. Great. So what did we learn about variables? We learned that whenever you declare a variable, there is this feature called dynamic type inference, where Scala will guess the data type. We also saw that there are two type of variables in Scala. There is like immutable and then mutable variable. And there is one more thing that probably I tell the audience, which is I can definitely declare a variable like this. So I can definitely declare a variable saying val z equal to 100, and it works. And Scala is also able to tell me that the data type is integer. But what I have seen in the production is that when you declare a variable, you don't want to, how do I say this? You don't want Scala to guess the data type. See, if you're so sure about the data type, then why do you want somebody to guess it? So a better way of writing the same code will be, you can say val z, it is integer, equal to 100. So you will be able to mention the data type rather than Scala guessing the same. It is your choice. Okay, if you just say z is 100, Scala is definitely going to guess it. I know that. And it is going to be correct. But a better practice will be like this. Now, why this is a better practice? Two reasons. One reason you are sure, right? You don't want the language to guess. If you know that z is an integer, you declare z as an integer. One reason. Second reason, if you already give the data type, then the compile time can be less. because sometimes what happens, Scala has to take a lot of time. This might be microseconds, but still it matters to figure out the data type, right? So if you're so sure about the data type, then why you want somebody to guess it, right? So you will see sometimes when you look at Scala programs, people will hard code the data type. And I think that is something which you can justify. Even I do that sometimes. Okay. Sometimes during the classes is that, hey, you just told that you will be teaching us Scala for 2 classes. Why 2 classes? Can't you teach like 5 classes of Scala, right? So that we become like experts in Scala. Honestly speaking, I don't want you to become an expert in Scala. Now, a trainer should not say this, but I really don't want you to become an expert in Scala. And this is a statement which is very dangerous. There are many reasons for that. First of all, when it comes to Spark, right? See, why are we learning Scala? We are learning Scala so that we can work with Spark, right? In Spark, when you go, you will see that the majority of programming can be done using SQL. Right. So SQL is primarily what we use in Spark. We also use Scala, but in the latest versions of Spark and all, predominantly it is SQL, not Scala. That does not mean you should not learn Scala. If you learn the basics, you're going to be just fine. The second reason is when you start working in the industry, like I said, maybe you're working in a company, they may be using Java for Spark. They may be using Python. They may be using R. So the language might change over the period of time, right? So the programming language, especially in the big data world, usually what people do, they just get a basic idea, right? And then whenever there is a necessity, you can learn if you want, right? And that is exactly the reason we spend probably only 2 days on Scala, and then we go to Spark. And when we actually start Spark programming, you will understand why I told all about this. Okay, great. One of the other reason you are learning Scala is the source code of Spark is written in Scala. The Spark framework, one of the most used big data framework in the world, itself is written in Scala. So it probably justifies somebody learning Scala and programming in Scala because Spark itself is written in that. If you go to Hadoop, right, you have this map reduce, right? And when people learn map reduce, they learn map reduce using Java. Maybe some of you have gone through map reduce classes. And have you ever wondered why you are learning map reduce using Java? One of the reason is because Hadoop itself is written in Java. So it makes sense to actually program in Java because it is more native, right? So probably this is also a similar reason. Spark itself is written in Scala. So accordingly, Scala is a very popular language among the Spark developer community. Okay, we will probably talk about it later. I will just talk about one more concept and then I will get back to your questions. I know that there are a lot of questions. There is one more interesting thing in Scala, which is what we call a block expression. And this is something I might have to show you. So in Scala, you will be able to type something like this. So I can say add equal to, let's say var a equal to 10, var b equal to 20. Then I can say a minus b. Oops, I think that might be an error. A plus b. Yeah, definitely it's an error. I'm sorry. I have to rewrite it. There is no other way. A add equal to, I'm sorry. Var a equal to 10, var b equal to 20, a minus b, let's say a plus b. Yeah. So what is this? This is what you call a block expression in Scala. And I think this is something which is very common in almost every programming language. Like maybe you are uh, talking about Java, right? Uh, or even C, right? You see this flower brackets, right? This is called a code block or a block expression, right? In Scala, when you write a block expression, you can see I'm writing it line by line. One thing that you notice here is that there are no semicolons at the end of the statements. So in most of the other languages, when you write something like this, you keep a semicolon at the end of this statement. In Scala, semicolons are optional. You don't have to use them, right? The second thing that I want you to understand is when you write a code block like this, the last expression is always evaluated and assigned to the variable. So now the last expression is a plus b, so that is 30. So that value 30 is being assigned to this variable called add. So I just want you to be aware of this. Okay, so you will find it in many places in Scala that people write a code block like this, and they will be assigning that to an entire variable. So this variable will be taking the value of this last expression that you have inside the code block. So here the last expression is a plus b. So even though it will evaluate a minus b, it is not going to assign that to anywhere. So the last expression here is a plus b, and that is what is going to be assigned to this variable called add. So you can have an entire code block, and then the value of that code block can be assigned to a variable. So this is actually what we call a block expression. This is called a block expression. And with that, we will probably come to one thing. I just wanted to discuss one more concept, okay? And probably I will, maybe I will ask you to guess the output. I'm going to write something, and what I will do. So Scala supports something called a paste mode. There is something called a paste mode. So if I want to write like 3 lines of code in one shot, I can go for a paste mode, right? So what you can do is you can just type colon paste. So when you type colon and then paste, you can see that you will get a message entering paste mode. And what I'm going to do now is I'm going to type 3 lines of code, and I want you to guess the output, just to be familiar. So what I'm going to do, I'm going to say val x equal to, I will say, I want to print a line, foo, then 10. Then I will say, I want to print bar, then I will say print x. So this is the 3 lines of code that I have written. Can you tell me if I run all these 3 lines, what is going to be the output? Now, this is a block expression, okay? And these are print line statements, which basically print line by line. 3 lines of code, right? So how do you execute these 3 lines of code, right? You can see here, it says Control D to finish. So when you are in the paste mode, if you press Control D, it will execute all 3 lines. That's how you get the output. Okay, so I will try to do a Control D. This is the output. Foo bar 10 is the output. So I think some of you like Anuradha, then Leta, they got the correct answer. It's fine. Some of you may not have got it. Now, if you're wondering how did you get this output, first thing, this is a block expression. So value of x is going to be what? 10. Value of x is going to be 10. Okay. And since there is an explicit print statement, it will print. So the rule is whether it is a block expression or not, when you have an explicit print statement, it's going to print. So first line is going to be foo because there is a print of foo. Second line is going to be bar because the print of bar. Third, you are saying print x. Okay, value of x will be what? The last part of the block expression, that is 10. So when you say print x, you're going to get 10. So the output is going to be foo bar and then 10. Okay, now this is not what I want to do. I was showing this as an example. This is not what I really want to do. I want to show you something else. So I'm going to rewrite this program in a slightly different way. Okay, so I'm again going to say paste. And instead of typing x, I'm going to say lazy val x equal to, I'm going to say print line foo. So same code I'm going to write, almost same you can say. Yeah. So if you compare this code, what I wrote just now, with the previous code, there is only one difference. The difference is previously I had this x, right? I had this x. Now I just have this lazy val x, right? I have something called lazy val x. Yeah, so if you look at here, the only difference here is between these two lines of code. Here I was declaring the variable x and it was just an x. Here it is a lazy x. So this is what you call lazy evaluation. If I run the code, you will see that the output is different because previously you were getting foo bar 10. This was my first code. Now you are getting bar foo 10. So what happened here? So Scala supports something called lazy evaluation, and that is what I just showed you. You can declare any variable as lazy. So in this particular example, I just added the lazy keyword.
Just a quick info, guys. Test your knowledge of big data by answering this question. Which of the following are incorrect big data technology? A. Apache Hadoop. B. Apache Spark. C. Apache Kafka. D. Apache PyTorch. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Before the variable x, which means the initialization of this variable will be deferred. What is the word I'm using? Deferred. So this variable initialization will be delayed or deferred, I can say. So when you say lazy x, you're basically telling Scala that, hey, Scala, this variable is lazy. Please don't run this line. It is as good as you are not running this line. So when you do something like this, Scala understands that, okay, X is lazy. I'm not going to run this line. So the first line it is going to execute is this print line bar. And that's what you get here. You get a bar. Then the moment you call this variable in the program, it will initialize it. So then you're calling print X. Now Scala will initialize this line. You will get a foo and then 10. So whenever you declare a variable as a lazy, the initialization of that variable can be deferred. Now, where will you use this? This concept is built into Spark RDDs. So when we speak more about Spark RDDs, resilient distributed data sets in Spark, I will come back to this lazy evaluation. As of now, just be aware of what is lazy evaluation. Probably you're thinking, why should I do this? Right? I will tell you why you have to do this, but you can make anything lazy. So here this X is actually lazy, which basically means this line is not getting executed. And then you have the print statement. Then whenever you call this variable in the program, it just gets started. So, I mean, it just gets initialized and then this variable is alive now, right? Okay, so that's what you call lazy evaluation. Now, so far we were working on this Scala ID, interactive shell, right? But in the real world, you don't work with the Scala interactive shell a lot. So if you are a Scala programmer and if you want to write a program, the shell doesn't support debugging the program, also correcting the program, giving you suggestions. These are all not there in the Scala shell. So typically, what we do is we go for something called uh, an IDE. Okay, so coming back to using an IDE, right? So like I said, uh, one of the ways in which you can write a Scala program, let's say you are in production, is using the help of something called an IDE or an integrated development environment. Uh, some of you might have heard about Eclipse. If you are a Java programmer, then you might have worked on something called Eclipse. Eclipse is one of the most, how do I say, used IDE, especially probably for Java programs. Now, when it comes to Scala, there are many IDEs. There is an IDE called IntelliJ, which is popular. There is also Eclipse. So let us first try Eclipse. We will also go to IntelliJ later. Now, one thing you need to understand is that if you are going to use something like Eclipse or any IDE, right, my suggestion will be install it on your laptop, not on the VM. See, the VM, anybody will do like that, right? So if you are, even if you are working in the production, right, and if you get a chance to install an IDE, the IDE will be installed in your developer machine, not on a VM. And in production, you don't have a VM also, right? So what I'm going to do, I will show you how to install this Eclipse IDE for Scala on your laptop. So this can be installed if you have a Windows or a MacBook or anything. All you need to do is just go to Google and search for Scala IDE. So just go to Google and search for Scala IDE, and the first link that comes up is Scala IDE for Eclipse. So you click on the link and directly you can see an option called download the IDE. Now the beauty of this Eclipse IDE for Scala is that once you download this IDE, you don't have to install it. It will come in a zip file. All you need to do is extract the zip file and it will work. So there is no need to install it. I think that's great. At least on Windows, there is no need. I think in MacBook also it is saying you're basically getting a zip file. So I'm using a slightly older version. Like you can see the current version is 4.7.0. I may be using a slightly older version. That's okay. So I have already downloaded this thing. And to see this, I need to check where I have downloaded it. Yeah. So I just extracted the contents to a folder called Eclipse. So here you can see there is an Eclipse folder, and there is a file. So once you extract this uh, zip file, you will be extracting the contents to a folder, right? And then you can just double click and it will start. Now, if you already have Eclipse installed for Java, you can go to this marketplace, search for Scala, install it as a plugin. That is also going to work. I mean, for uh, freshers who are not using Eclipse at all, this is what I recommend, right? But let us assume you're already using Eclipse and maybe you are using Java. What you can do is just go to the marketplace. There will be a Scala plugin, and you can just add that Scala plugin. It should work, right? So I'm just starting my Eclipse. This is like Eclipse Neon. I think it is slightly older, but it will do the job. See, normally when you write any program, the program is going to have two components. There is something called a driver, and there is something called business logic. I'm talking about a normal program. We are not talking about big data or anything. I mean, any program you write, typically we say that there is something called driver and business logic. Business logic will be the actual business logic you are writing. Maybe you want to find out the top 10 profitable products sold by your company. So you may be writing some program. So this is your actual program, the program that you're writing to find out whatever you want, right? However, in order to run this program, there is a component needed called driver. The driver is responsible for getting resources to run the program, initializing the objects, right? And all this. And typically within the driver, we declare something called a static class. Right. If you again are taking the example of Java and all, when you start writing a Java program, we will say public static void main, then arguments. What is that? So you're declaring a static class in Java, which means that is the after that you have the main method, that's the entry point, right? So a static class is needed. There can be only one instance of it. It's immutable, like most of you said, right? A static class is needed so that you instantiate the driver part of the program, which in turn will get resources called the JVM and then make your code work. And typically in any program, you start by declaring a static class. After that, you will also have something called your main method. When it comes to Scala, Scala doesn't have something called a static class. Instead of a static class, Scala uses something called singleton object. So a singleton object is nothing but a static class. It is probably just another name, but when you start writing your code in Scala, you will never find something called static class. You will find something called singleton object, whatever it is, right? Singleton object. So I will show you. So let us try to do one thing. Let's try to create a simple control structure. So when we learn new programming languages, we also talk about control structures like your for loop or if else loop. These are all called control structures. So what I'm going to do, I'm going to go to my Eclipse. So I just started Eclipse. And the first thing you normally do when you start something like Eclipse is that you go to File and you will say New, and then you will say Scala Project. So first thing that you do is you go to File, New, Scala Project. Okay. So you select this, you select your Scala project. Okay. And you're supposed to give a name for your project. So I'm just going to call it as, I don't know, So first thing that you need to do is you're supposed to create a project within your Eclipse. And within this project, you see a source folder. You can definitely have a package and all inside this, but I'm not getting into those details right now. What I'm going to do is I'm going to right click this source thing. And there is an option called new, and I can say here Scala object. So the first thing that I'm going to do is I'm going to create something called a Scala object. What is this Scala object? This is your singleton object or the static class. So I'm going to give a name. Let's call it as if else. Any name will do. I'm just going to call it as if underscore else. So you can see in my code, it is object if underscore else. This is equal to typing static class, whatever class name that you want. Okay. And below this, so once you declare your singleton object, the first thing that you do is you define your main method. So you can say def, you can say main, and the main method can take arguments as an array of string values by default. You can change it. Okay, the default is your program will be able to take arguments as an array of string values. And now you will be able to type your code. So this is like the bare minimum boilerplate code you need to write a Scala program. You need a singleton object, or call it as a static class if you wish. You need a main method, right? Main method will mark the entry of your program execution. These two are actually your driver. These two are actually your driver. They are not part of your business logic, but they are required to run the program. For example, if you want to pass some runtime arguments, you use this argument option, right? Same like that. Now let's try to create a simple if-else loop. I don't know what if-else loop I will create. So let's say there is a variable called fruit and the value is apple. If I say, I'll say if fruit is apple, println red, else println no color. I don't know what this is, but this is my loop. So probably this is not the best program that somebody can write, but I think you got the idea. Simple control structure or if else loop. So I have a variable called fruit. The value is apple. I'm saying that if the value is apple, just print red. Otherwise, print no color. Okay. And how do you run this? You can save it. Just right click, say run as Scala application, and you get red. No surprises there. You are going to get red. So Scala supports a regular if-else loop. And there is no magic in this. If-else loops are same across almost all the programming languages. You can even go to a else if condition. So this is like you are validating only one condition. I had another example. Let me check. Yeah, this one. So here you can see this program. Yeah. So this is a program to calculate the grade of a student based on the mark. You can see the student has got just 10 marks. So the variable x is the mark. And then you're saying that if the mark is more than 80, then print grade A. Else if the mark is between 65 and 80, grade B, 50 and 65, grade C, 35 and 50, grade D, finally fail. So if you have a series of statements to evaluate, you can use a combination of else if statements, right? And if I try to run this, what will happen? You see the student is failed because he got only 10 marks, right? So all these type of else if conditions are supported in Scala. Yeah, so this is how you write a simple Scala program. Let's try for a while loop. I just wanted to show you a while loop and a for loop before we wind up. So how do you write a while loop? I'm just going to create one more program. So you say new Scala project, call it as my while loop, and I'll copy this main method probably. There is a shortcut I can use, but I like it this way. So you can say var I equal to 10. And how do you write a while loop? You write a while condition. The condition is, let's say I greater than 0. You want to print something. Hello plus I equal to I minus 1. So what is a while loop? It basically checks for a condition and then execute the statement. You can see I have a variable I, the value is 10. And then I say, as I is more than 0, just print hello and the value of I. So this is basically string concatenation. So when you say hello plus I, this is actually a string. It'll add the value of I here. Then in each iteration, you are subtracting 1 from I. So eventually it will reach 0 and the condition will be broken. Simple while loop, right? And if I try to save it and then run it, you can see that I'm getting the hello 1098 up to 1. So while loops are also very common, and in Scala also there is no speciality the way the while loop execute. Let's try a for loop as well. I will give you more examples, don't worry. If you're thinking, hey, how do I learn a couple of more while loops, I'll give you examples, don't worry. But let me do one for loop as well. I'll copy this. And for the for loop, the syntax is slightly different. See, for loops are normally used to iterate through something and produce the output. So normally in other programming languages, you will say I equal to 0, I plus plus, this kind of a syntax. In Scala, it is very simple. You can say for I in the range of 1 to 10, you can just say print I. So this is how easy it is to write a for loop in Scala. The way I wrote it is, I said for, this is I in the range of 1 to 10. This is like I plus plus, I is iterating from 1 to 10. But you may be wondering, what do you mean by 1 to 10? Are you writing something like in English? 1 to 10 seems to be something different, right? See, 1 to 10 is a scalar collection called range. If I go to the Scala shell, if I just type 1 to 10, it will produce numbers from 1 to 10. It is a scalar collection called range. So you can see range of numbers 1 to 10. You can say 1 to anything or anything to anything basically. It will generate a numbers like an array. You can say range is another collection. You can also say 1 to 50 by 2. It's very interesting to work with Scala. So when you say 1 to 50 by 2, what it means? The numbers are going to be from 1 to 50, the step function is 2. It will start with 1, keep on adding 2, 1, 3, 5, 7, 9, blah, blah, blah. So again, this is again a range. So I'm just iterating through this range and printing the numbers. That's what you're using the for loop. So when you say 1 to 10, I can take values in this range, and you can say print I. And if I try to run this, you can see you're printing numbers 1 to 10, right? So now coming to learning Scala. So I want to share some more information before we wind up. Of course, important information. So first things first, where can you find all the material? Now I'm talking about Spark and Scala in general as a course.
So coming to the first question on the Stop Hadoop interview question set, it is what are the differences between Hadoop and Spark? This is a very commonly asked question and it has a very simple answer, to be honest. We'll be comparing three simple points here. One is how storage is handled in Hadoop and Spark, the other one is the processing speed, and the third one is the availability of libraries. So in terms of dedicated storage, Hadoop has its own file system, right? It has its native file system called as the Hadoop file system, while Spark lacks a native file system. Then you're talking about processing speed. Hadoop has an average processing speed when you compare to large amounts of data, because here Spark is really very good at handling large amounts of data without having to do much when you compare it to Hadoop. Coming to the next point, which is libraries, right? So Hadoop has the connection with multiple tools, multiple libraries, and Hadoop is pretty much a big tool. But then when you think about the native availability, where a lot of people depend on it, so Spark provides the Spark Core, you have the Spark SQL, Spark Streaming, Spark Graphics, Spark ML So you have all of these libraries that come attached with Spark, while you will have to learn and integrate these new things in case if you want to use all of these with Hadoop as well. So that extra learning curve in terms of Hadoop is required. Coming to question number 2, it states what are the real-time industry applications of Hadoop? Hadoop, as you might know, it is already called as Apache Hadoop. It's one of the world's most famous open source program, especially for the world of distributed computing, where we handle, large amounts of data day in and day out. The world generates 2.5 quintillion bytes of data a day, so we needed a solution to handle all of that, and Hadoop does just that. So when you think about the practical applications of Hadoop, all the way from the small scale industries to handling a little bit of the big boys as well. So think about Google, think about Yahoo, think about Facebook. So all of these guys also have a solution for their big data, because they are generating a lot of data, right? So everything from managing traffics on the street, handling streaming processing, working on content management, how to archive emails, how to save them, working on fraud detection, which is very important in today's world, fraud prevention, targeted advertising, and guys, you can go on and talk about the applications of Hadoop for a long time, and then make sure to keep your answer concise. Do talk about 2 or 3 points, or if you do know some of the application, then make sure to note at least 5 of it. So with this, we can come to the third question that states, how is Hadoop different from other parallel computing systems? Well, this could very well be the first question through which your interview starts. So Hadoop is actually a distributed file system that lets us, handle a large amount of data, to store it, to work with it on, either local machines, offshore servers, or even on clouds as well. So when you think about it, if your data is stored in multiple places rather than one place, it
Just a quick info, guys. Intellipaat provides online big data Hadoop training in partnership with IBM. The course link of which is given in the description below. Now, let's continue with the session.
creates redundancy, yes, but here we have the good amount of redundancy, because if your data crashes, if you tend to lose your data because if one of the nodes stopped working, then your data is still there. So in a distributed manner, you can store data on multiple places. You can use the processing power of multiple machines to actually go on and work with your data. So this does not happen in a relational database, because when you think about it, right? So if you have a relational database, you have to query the database, you have to, pick up all the tables, records, columns, and it'll be a manual task, and you really cannot make use of multiple machines to do this effectively. It is a good enough method, of course, but at the end of the day, it is not as fast as what Hadoop can do. And of course, Hadoop also provides a scheme where you can build your own column databases, and just for this, we have the Hadoop HBase. HBase is very similar to SQL, and here, we actually go on to run queries on the rows, on the columns, wherever it's required. And basically, this is Hadoop's approach to making sure your data storage and access protocols are done easier. And this is how, Hadoop is different from the other parallel computing systems out there. Coming to question number 4. Question number 4 is a very important one. It states, what are all the modes that Hadoop can be run in? Well, it's a pretty simple question with a very straightforward answer. Hadoop can be run in 3 modes. One is the standalone mode, the second one is the pseudo-distributed mode, or what we call as the single node cluster, and then we have the fully distributed mode, which is also called as the multi-node cluster. Coming to standalone mode is actually the default mode of Hadoop, where it uses the local file system where you're working on for all the input and the output operations. So this is not used popularly in the case of a production environment, but mostly when you're testing or when you're debugging, right? So standalone mode is very important. One highlight you have to talk about when you talk about standalone mode is that it does not support the usage of a Hadoop file system, because it's using the local file system. So make sure to mention that. And then when you're thinking about the pseudo distributed mode, right? So what happens in pseudo distributed mode is that you will have to provide 3 files for configuration. There's the core site.xml, you have the hdfs site.xml, and the map_reduce site.xml, right? So for map_reduce, for core, and for working of hdfs, you have to provide a configuration on which this mode works on. So if you're running on one node, it means that so if you're running pseudo distributed mode on one single machine, it means that that machine itself is the master and that machine itself is the slave node as well. So this is one thing you have to note. And then coming to the fully distributed mode. Fully distributed mode is of course the production phase of Hadoop, where this is where Hadoop is known to be very powerful, and this is where it beats all the other tools out there, because here data is used and data is distributed across multiple clusters, multiple nodes, and once you have more than 2-3 nodes, we call it a Hadoop cluster. And using clusters, you can have a separate node which is a master node. You can assign all the other slave nodes as well, and then work with it in a chain of command in a very structured way. So this is the advantage of the fully distributed mode. Now, moving on to question number 5, it states, what are the operating systems on which Hadoop works? Hadoop supports a lot of operating systems. In fact, it's an open source tool, and the support for multiple operating systems were being added one after the other. It's mostly preferred to use Hadoop with Windows or Linux, because most of us almost use Windows or Linux, right? But then for the people who are using OS X, or the people who are using Apple's operating system, or let's say even the BSD, which is also called as the Berkeley Software Design OS, the support for Hadoop is there. So there is a lot of flexibility in terms of what operating system can be used to run Hadoop effectively. So make sure to mention 3 or 4 of these when asked. Coming to question number 6, it states, what is distributed cache? What are its benefits? Distributed cache, right, in Hadoop is actually a service. So what it does, as the name suggests, it caches files whenever we require it. So let's say there is a file which is cached for a particular job. What Hadoop does is that it'll make it available to the data node, both in the system memory and both in the actual system where it's been accessed from, and of course in the memory as well. Because at the end of the day, this is where your map operations are happening. This is where your reduction tasks are happening, right? So if you have a cached version there, it's almost like copying it and keeping a temporary sample there where you can use it. You can populate any collection that you like, right? So think about arrays, think about hash maps, and all of that in your code, and later use it quickly without having to wait for the pull operation from another node. So what are the benefits of doing this? One benefit is that it provides a very simple path of you accessing the data, copying the text file, data file, or whatever it is. And it also ensures that there is developer efficiency in terms of There is a decrease in terms of access time, and of course what distributed cache does is that it tracks the modification timestamp for each and every cache file, which means that the user or the machine or the language itself can have the capability to check if the file has been modified or not. So the general practice is that the file will not be modified until the job is complete, because once the file is changed, it doesn't become a cache file, it becomes a standalone file at the end of the day, because caching is a copy of something. Once you've copied onto that, it has to remain the same until you work with it, right? So these are some of the benefits and the working of the distributed cache in Hadoop. Coming to question number 7, this is a big one. It says explain the differences between name node, checkpoint name node, and backup node. Well, let us check out name node first. I think you would already know this. Name node is one of the most important components, the core components of the Hadoop file system, which is used to handle metadata. Metadata is what we talk about when we have to describe the events of files. See, files will have certain information, but then to describe what information these files has, that is exactly what metadata is. So what we're doing with name node is that we're trying to map all of these files using metadata to check where the block locations are, what blocks are located on which point in the data node, right? So what we're trying to do here is we're trying to understand and map a way on which, think about a tree structure, right? Think about a directory structure where we have all the files arranged one after the other in the Hadoop cluster. That's the exact purpose of the name node. So to do that, we'll actually require two files. One, we have the fsimage file. It's used to check the latest checkpoint of the namespace, and of course we have the edits file. Edits file will give you a log of changes that has been made after the checkpoint has been achieved for every single namespace entry, because at the end of the day, whatever changes you do, minor or major, it is very, very important that you keep it in check. This is name node. Now let's talk about checkpoint name node. Checkpoint name node is basically very similar to what name node does, and here what we're trying to do is we're trying to create checkpoints for name nodes at regular intervals rather than in randomness. And here, by doing this, what we have to do is we have to download the fsimage, we have to edit all the files, and later after editing, what we'll do is we'll merge these files into the local directory. And after this, we'll have a new image, and the new image, after being merged, is basically uploaded to the name node. So after these checkpoints, after analyzing them, after editing the files, after merging them, is when we create it and upload it to the name node. So this is the checkpoint name node. And then now when we talk about backup node, right? So backup node basically provides the functionalities very similar to checkpoint, but at the end of the day, here what we're trying to do is we're trying to achieve a synchronization with the particular name node. It is very vital, as I've been saying, that your file should be up to date. Your file should have an in-memory copy. It should not differentiate from each other when it's being cached or when it's a copy or anything like that. So backup node needs to save the current state in the memory to an image file, to create a latest checkpoint file as well. So this is what a backup node is. So this is the basic difference that lies in between name node, the checkpoint name node, and the backup node. So when you ask this, make sure to put the answer out in a clear and a concise way. And whenever you're answering questions regarding nodes, name nodes, and especially data nodes, things get a little messy, right? Make sure you put the answer out in a very structured way. Now coming to question number 8, it says what are the most common input formats in Hadoop? Well, there are 3 common input formats in Hadoop that you should know about. One is the text input, we have the key value input, and of course we have the sequence file input. So the default mode, right? So you can have another question here that says what is the default input format in Hadoop? It's actually the text input format that is the default format. And then we have the key value input. So the key value input format is used for plain text files where the files are actually broken down into lines and later used. But in the case of sequence file input, here we make use of this particular format to read all the files in a particular sequence as per requirement. So these are the 3 common input formats in Hadoop, and you have to stay in order. Really doesn't matter. The default one is the text input, and talk about key value inputs, and of course how you'll be reading files in a sequence using the sequence file input as well. So with this, we can come to question number 9 that states define data node. How does name node tackle the data node failures? Well, the name node we've already seen, right? But what is data node? Data node is where the data actually gets stored in the Hadoop file system. The data actually resides here in a way where it has the capability to communicate with the name node. It does this by sending a message called as the heartbeat message. The heartbeat message literally, is to show that it is alive and that it is working. So what happens is that we have 10-minute intervals, and in these 10 minutes, if the name node does not receive a message from the data node, right? So the name node is waiting for the data node to send a message. In 10 minutes, if it doesn't send a message, what the name node thinks is that the data node is either dead, or it's out of place, or it's not working fine. And the name node actually starts replicating the blocks which are hosted on that particular data node which wasn't responding. And it takes that and pushes it onto another data node to make sure that the data replication and data redundancy part of it is maintained well as well. So this is how actually name node tackles data node failures. But then to denote the failure, we have something called as a block report. A block report is actually consisting of all of the lists of blocks that are present on a data node.
Just a quick info, guys. Check your knowledge of Hadoop by answering this question. Which of the following are the core components of a Hadoop? A. HDFS, B. MapReduce, C. HBase, D. Both A and B. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So whenever a system starts to replicate it, right, you will get to know what data was stored in the data node and what data needs to be moved. So this replication of data to moving from one data node directly into the other by keeping a track under the name node by making use of a heartbeat message. This is something which is very important, and this is how communication happens between the data node and the name node. With this, we can come to question number 10 that states, what are the core methods of a reducer? Well, there are three core methods, whenever you're talking about a reducer. One is the setup, we have the setup method, we have the reduce method, and of course, we have the cleanup method. Talking about setup method is basically used to configure all the parameters that we have to feed into the network. See, you have the input data size, you have the distributed cache, and all of these parameters, right? So to do this, you can use public void setup and context as the parameters to send it in. But then when you talk about reduce is the most important part of the reducer, right? As the name says, it is the heart of the reducer. So every time there is a new key that's generated, the reducer is called once with that particular task. The key is given to it, the value and the context is added where this method can run the reduction operation and be done with it as well. And then when you're talking about the cleanup method as the name suggests, again, is pretty simple. It is used to clean all the temporary files once a task is ended. So you will have certain files which are required to perform the reduction operations, but then as soon as the operation is done, you will not require them anymore. So in that particular case, it is vital that you keep cleaning the memory then and there to keep it effective, right? Cleanup method does just that. Now, do take a look at the syntax. And if you have a pen and paper in front of you or your computer in front of you, do make sure to put that down to showcase to the interviewer that you actually have worked on this or that you know it in detail. Now, coming to question number 11, it states, what is a sequence file in Hadoop? A sequence file is basically a flat file, in Hadoop. So whenever we're talking about flat files, especially here in the case of sequence file, it contains binary key value pairs. And we have the map inputs, we have the map outputs, where the map output actually gets stored, as a sequence file internally here itself. So if you're thinking about what classes does this sequence file provide, it provides you the sorter class, the reader class, writer class, and each of these file formats, right? So there's actually three formats that you need to know about. One is the uncompressed key value records. Then we have the record compressed key value records where only the values get compressed. And then you have the block compressed key value records where, it's not just values here, but both the key and the value gets collected in separate blocks and compressed. And the size of these blocks, right, this is assignable to you. So having it uncompressed, compressing only the values, or compressing both key and value in the case of sequence files are very important. So these three classes in the binary key value pair see a lot of usage in the daily world, so it is very vital that you answer this like that. Next, coming to the 12th question, it states, what is the role of a job tracker in Hadoop? Job tracker, as the name suggests, again, its main function here in Hadoop is to basically handle resource management. So we have something called as task trackers, where the job tracker actually handles and manages the task trackers. So it will be checking for resource availability, it will be checking for task lifecycle management, it will be understanding about what's going on in terms of fault tolerance, in terms of the task's progress, and much more. So there's a lot of things that the job tracker does in Hadoop, right? So it is basically a process that runs on a separate node and not on a data node. And this is a very important point that you're supposed to mention. And then of course the job tracker communicates with the name node to identify the data location. And if it finds the data, then it will execute the task. If it cannot find the data, then of course it goes into redundancy. But then one important thing is that it will monitor all the individual task trackers and submit your overall job back to the client. It's like, hey, it takes in all the data, it works with it, executes all the tasks, and sends it back in a structured way. So what it does is that it also tracks the execution of the MapReduce workloads, the operation, and the tasks local to that particular slave node, and creates a file where you can track that as well. So in terms of what job tracker does, is it does a lot of things and it does them very effectively. That's the important part here. Coming to question number 13, it says, what is the use of record reader in Hadoop? So when you think about it, we have input split, right? So input split basically defines a slice of data, but then what it does not do is that it does not describe how to access this slice of data, right? So what the record reader does is here is where this class comes into the picture. Here we take the byte oriented data from its source, we directly convert it into the record oriented pairs, right? So you already know it, it's the key value pair. And after we convert the byte oriented data into its key value oriented data, then we give it to the mapper, where the mapper can handle the task, it can read it and work with it. So in the background, what happens is that the input format, right, it actually defines the Hadoop record reader instance, where it keeps adding up onto that list about what's going on, what files got converted, and if the mapper is ready to pick it up or not. So in that particular case, even record reader adds a lot of value to Hadoop. Now, coming on to the 14th question, it says, what is speculative execution in Hadoop? Well, one important limitation we have to talk about every time we discuss about Hadoop is that whenever you're distributing a lot of tasks on multiple nodes, right? Sometimes it is not always that you have nodes which are really fast. So a few slow nodes will actually limit the execution. It will limit the efficiency of the entire program, right? So when you think about it, there might be multiple reasons of why a task is slow. In a small scenario, this is a very simple thing to find, and you can work with it. Hunt for the node which is slow and replace it. But when you're thinking about a large scale solution, it is not easy to detect which node is slow. So what we try to do here is, instead of fixing all of these slow running tasks, Hadoop will actually try to detect what tasks run slower than an expected time. It will have an expected time through which the task has to finish. It will see what task is taking more time than the expected time, and it launches other tasks as a backup in case if this is taking more time. So this backup mechanism that exists in Hadoop, right, this is exactly what we call as speculative execution. This is a very important thing to maintain high efficiency throughout the execution of our task, getting closer to our big data handling goals, or whatever it is. Speculative execution is definitely one of the most important things that's adding a lot of value in the community of distributed computing. So when you ask this question, make sure to give it out in a concise way. Coming to the 15th question, it says, what happens if you try to run a Hadoop job with an output directory that is already present? Well, if your directory is already present, what Hadoop does is a very simple thing. It will give you an exception saying it already exists, because you really cannot create a directory when already one is created, right? So a Hadoop job requires either a creation of brand new directory or working with it as well. So in that particular case, to run a MapReduce job, you need to make sure that the Hadoop directory will not exist, because if it does, it will not work. It will give you an exception. So in case if it exists, but then you want to delete it, run your Hadoop job fresh, make sure to use the file structure command Hadoop fs rmr, which will basically remove it, put the path to your output, and as soon as you're done with it, you will delete a directory, or you can make use of a Java API as well. Get local conf.delete will actually make sure that your directory gets deleted, and later as soon as you run the job again, this time you will not have an exception, but this time the job will run as expected. Now, coming to question number 16, it states, how can you debug Hadoop code? See, to debug Hadoop code, one very important step you always have to check is to check the list of the MapReduce jobs that are currently running. And once you see the logs, once you see all the jobs that are being run, there you have to make sure that there are no orphan jobs which are running. If they're running, make sure find the location of the RM logs, make sure to check it out, and especially when you run the command that's given on your screen, right, with the resource manager. So what it does, it will look for the log directory. It is very important that there should be no orphan jobs running. So based on what we find on the RM logs, right, we have to check if the worker node was involved in the execution of task or not. To do that, we have to log into that particular node, right? Because without logging into that node, we cannot see if a worker node was involved in the execution of a task. To do that, you can use PSEF grep inode manager, and using this, you can log into the node to see if it is the worker node that was involved. So later, after doing this, what you'll actually do is examine the node manager log, where the majority of the user level logs come from here, for every single MapReduce job out there. So this is a structured way, an ordered way of how you can simplify and debug Hadoop code. If you have a Hadoop structure running on your machine, if you have a standalone structure, or let's say if you're connected to a multi-node structure as well, open up your laptops to show all the working of this practically to the interviewer. That will add a lot of value to your candidature at that particular company. Not just this question, among all the questions we discussed, wherever it is possible, do show it practically. So with that, we can come to question number 17, that states how to configure replication factor in HDFS. See, to configure HDFS, you remember we spoke about 3 files, and one of those files are HDFS site.xml, right? So this is a very important file which we use to configure the file system. So basically, to change and configure the replication factor, we have the dfs.replication property that's present in this particular file. So by changing that, we can modify it. But then if you change it on a file basis, right, per file basis, where you're checking out each and every individual file and working with it, for that you have a Hadoop shell command, Hadoop setrep, where you can put in the file name and work with it. But then if you have to change the replication factor of all the files at a time, but then not like each one of them individually, then of course we have another Hadoop command for that as well. There are certain subtle differences. You have the capital R in the second one that denotes that you'll be adjusting the replication factor for all the files in the directory, and of course for the first one it's only the individual file. So here it's very important that you talk about replication factors on individual files, and of course replication factor changing on all the files that are present in a single directory as well. So make sure to mention this. Moving on to the 18th question, it states how to compress a mapper output, not touching the reducer output. To basically compress a mapper output which is not in touch in the reduction process, what we try to do is we set 2 things. To achieve the compression, we have conf.set, where we're trying to set the output compressed to be true, and what we're trying to do is we're trying to keep the file output format to be false. So after setting these 2 parameters, right, this is how compression can be achieved. It's a simple question, it's a very straightforward answer, and again, if you have a pen and paper, rather than spelling it out, make sure to write it down and show that you'll be setting the bits to be true in the case of the map output, but in case of the file output format, we'll be putting it to false. Now, coming to the 19th question, it states what is the difference between map side join and reduce side join? Well, map side join happens at the map side, right, as the name suggests. So whenever your data reaches the map, this is where the join operation takes place. So then, I'm sure you're already aware of this, but then to do this, you will really have to have a strict structure, right? So especially when you're defining your map side joins, you really need that. But then when we talk about the reduce side joins, it's also called as the repartition joins. So here, it's a little simpler when you compare it to map side joins, because here all we're trying to do is, map the files rather than the input data sets. The input data sets need not be structured out here. So when it comes to that, but then when you talk about efficiency, right, map side joins are more efficient here, because in the case of reduced side joins, it'll have to go through a lot of sorting phases. It'll have to go through a lot of shuffle phases where, you'll be coming in touch with a lot of network heads, and it might take a lot of time and, work power to actually get the job done in the case of the reduced side joins as well. So hence, this is one of the reasons why people prefer the map side join. But then to do that, you need the structure, and this is a very important point that you should talk about. Now with this, let's come to the 20th question that states, how can you transfer data from Hive to HDFS? Well, it's a very simple question with a very simple answer. You just have one query that you have to write where you can, pick up the data from your Hive and push it onto your HDFS. It's a Hive command is insert override directory, where you have the slash select star from EMP, where EMP is the directory where EMP is actually the record there, and after you execute this query, you can import whatever files you want from Hive to HDFS. So the output that we get here is actually stored in part files in the specified Hadoop file system structure as well. So that's one very important thing too. So if you're expecting a very complex process of transferring files from Hive to HDFS, well, sorry to disappoint you, because it is pretty simple, as you can see on the screen. Coming to question number 1, it states, what companies make use of Hadoop? Well, there is a lot of companies that make use of Hadoop. In fact, there's thousands of companies right now making use of Hadoop. Even when you're watching this particular video, the big boys are Yahoo and Facebook, because Facebook developed Hive to perform analytics, and we have Yahoo is one of the biggest contributors in the entire creation of Hadoop. We have Amazon, we have Netflix, we have Adobe, we have eBay, we have Spotify, we have Twitter, we have a lot of other companies where each of these products have one particular or multiple use for Hadoop. So it can be a very small scale solution that they're trying to implement, or in fact it can be a very huge thing that they're trying to add on to their company by making use of Hadoop as well. So in that particular case, right, Hadoop is very, very well regarded and used a lot in many companies out there today. So question number 22 states, how do you stay up to date with the new and upcoming concepts in big data? So the 22nd question states, how do you stay up to date with the new and the upcoming concepts in big data? You have to know one thing is that this is a very commonly asked question here, because with this, right, the interviewer wants to understand what your interest is, where your interest lies, and what are your abilities of learning something new and how can you learn it well. So talk about how you've learned things in the past, talk about how you're planning to use these past learnings. Probably you could have taken an easier way to learn, a more structured way to learn, or there are many other concepts which keep coming out, right? So the tool of today will become obsolete tomorrow, and it is very vital that you know the latest versions of the software, what are the changes that happen. And it's not only that, it's about how you change yourself with these new changes, or how you plan to impart these new changes in a very simple way, in a fashionable way, in your particular project of whatever you're handling. So the interviewer wants to understand this. He or she wants to understand your interest, your ability to actually find, and how you will learn new things, because in a production environment, when you're looking for a job, it becomes very vital that you have to pace yourself and learn new things rapidly. So make sure to keep this answer concise, but then put it out in a clear way. If you have a path, it can be very different from what I told you. You might go on the internet, check a couple of YouTube videos, pick up a certification program, or whatever it is. You really have to mention your way on how you plan to learn new things. As an added bonus, talk about how you've used these new things as well. Coming to the 23rd question, if you're a fresher, or if you're an intermediate user, or let's say if you're an advanced developer, there's a good chance this question is asked. It's a very frequent one. Hadoop is used in multiple different kinds of. So Hadoop is used in multiple industries, right? So you might be working at Facebook, which is a social media company. There's many other companies, right? There's Google, there's Yahoo, and there's Adobe, which do a lot of different things compared to social media. So based on the industry that you've worked in before, if you're a fresher, of course, you can say you're a fresher, and you'll move on to the next question. But then if you're an intermediate developer, who's looking forward for this interview, if you've had any experience in that industry, right? So make sure to elaborate about it. Talk about the industry experience that you have, because at the end of the day, you can talk about the tools you've used, you can talk about the techniques that you've used, and how you've made a change in the same industry before, and basically what you bring to the table as well. So it is very important, if you have the industry, do talk about it. But then if you do not have it, talk about how you plan to bring the learning from the industry that you belong to into this particular one. So you might be moving from social media to another industry, but then talk about how you plan to make that switch of what you'll carry along with you from that different industry, to see to it that if it works or not, or how better it can be implemented in this particular industry as well. So this is a very important question. And then the 24th question states, what is your plan after joining for the Hadoop developers role? Well, The first thing you have to talk about is when you ask for any plans in the future, right? So talk about how you're planning to understanding the complete data workflow setup in the company, because once you understand the workflow of the company, then you can have a plan of action. You can work on the plan of action, discuss it, implement it, and verify it to see if it's working or not. Don't just say that you're going to step into the company and start changing things around, because that definitely wouldn't work in a production environment. So you yourself have to get very familiar with what's going on, what's already existing, and then you can work on seeing what can be changed, what can be made better, or in fact if you fit into the actual requirement that is already there, and you will not have to change anything. So in multiple cases like that, it is very vital that you state out a plan of action, right? You joining, you learning new things, you talking to the people who have done it, see what can be done better, verifying if it can actually be done better, and doing it better. So this is something that would add a lot of meaning to your particular interview as well. So with this, we can come to the last question, the 25th question, that states, have you earned any sort of certification to improve your learning and implementation process? Well, I'm sure if you're at this point of time, if you're at the 25th question, you will already know the value of what a certification program would bring to you, right? So you will have a lot of experts teaching you a lot of content over a couple of months. You'll be picking up industry level projects. You'll be working on real time projects. You'll be given thorough training where basically you have learned all the concepts thoroughly. A good certification program will also give you industry level projects where you can actually implement your learning to see and verify if you have actually learned, because at the end of the day, what you put on your resume is your projects, right? So if you put on a certification, well, it's well and good, but in an interview, as soon as they talk about the certification, the first thing the interviewer is going to ask is, what did you learn and how have you solved problems using that? Because when you think about it, all the IT problems that exist out there today, right, are being solved, and we have solutions for that. See, the entire process of big data handling itself is a problem, and handling that is the solution, right? So we had a lot of data that's being generated every day, and now we know how to handle it and work with it. In fact, that is one thing that you could state about what you learned in that particular program, but then make sure to elaborate about how you've learned it and how you've planned to use it in the near future, or how you already used it in the past to solve a real life problem. So all of these will give the interviewer an impression that you are very good at advancing your career, that you've put in your time, your money, your effort into working on Hadoop or working on big data. In fact, it also shows that you are an effective learner and that you have strong aspiration to pick up a certification program, to learn to it, to see through it thoroughly, and become an expert at the end of it as well. So a certification program adds a lot of value to you as well as the interviewer, because all of that, the knowledge that you carry is very important for the company there as well. So in terms of job prospects, in terms of impressing the interviewer, in terms of working well at the job that you do, anything, right, a certification program definitely helps. So with this, we come to the end of the top Hadoop interview questions set. I take this opportunity to wish you guys all the very best for all the interviews out there. You can use this as a guide to see how you can approach each of these questions in an effective way, and how you can answer them in a clear and a concise way too. So with this, I wish you all the best, and I'll see you on the next one.
Just a quick info, guys. Intellipaat provides online big data Hadoop training in partnership with IBM. The course link of which is given in the description below.
So guys, we have come to the end of the session. If you have any doubts, please put down in the comment section below. We will try to answer it as soon as possible. Hope you all enjoyed the session very much. Thanks for watching.